Hi there. Thank you for joining in this lesson. We're going to talk high level comparison and also the different important considerations when you're trying to design VNet to VNet peering, or maybe VNet to VNet connection, or site to site connection, or maybe even Azure Express route. But within this lecture, we are primarily focused on these three topics. That's a virtual network peering and VNet to VNet connection and site to site connection, so that we will know what is happening in the technical background and we know that when we will be using. If you have already completed all of these configurations part, this lecture will be useful for you to understand what's happening in the back end, and also when to use and what kind of technology it's using, and where we will take as a design consideration. First thing first, we know that we can use VNet peering to create a connection between multiple different virtual networks. Let's see here, you have a different VNet 1 and VNet 2. You can do that and it can be crossed, or maybe subscription, cross subscription, or cross region, and so on. In other way, we are actually trying to establish connection with the VNet peering, virtual network peering, from one isolated network to another isolated network. In this scenario, we are not using anything called VPN gateway, but in the real world, we can achieve this with the VPN gateway. There's a component within Microsoft Azure portal called Virtual Network Gateway. So within this Virtual Network Gateway, you can achieve the similar configuration with the end goal of connecting different virtual networks. You see here, you have the options. Let's say you have a test VNet and maybe East US, and you also have another region, maybe West US, and whatever the resources here you have, you wanted to make a connection so that both can communicate. So this same thing can be configured with the help of VNet to VNet connectivity by introducing in each of these VNets a device called VPN gateway. So now you know that there is a specific configuration is required in terms of VNet to VNet connectivity, that's called VPN gateway. Within this VPN gateway, there would be a public IP will be assigned here. Similarly, other side of the west side region also, if you have another VPN gateway, you will need to assign a public IP. So what would happen is this IP will dial to this IP. Similarly, this IP also will dial here, and to connect with these two devices or the VPN gateways, it needs to have some kind of handshaking and also a shade key. So that shade key is a secret character. So if both are matching that secret characters, it will establish a connection with the help of either IPsec tunnel. So the connection, whatever it's transferring the data, would be completely encrypted. And this VPN gateway will work with something called a gateway subnet that needs to be created and associated with your VNet. So the first part would be here, building blocks would be the first part VNet, and then you need to create something called a subnet gateway, and then you introduce this a device or the software appliance called a VPN gateway. And remember that when you deploy this, it takes close to 45 minutes time in the backend to completely provision a dedicated VPN gateway for your VNet. So just to summarize, the public IP addresses that two VPN gateways can establish a connection that allows the secure and private connection with the help of your IPsec tunnel. And it is a special tunnel that is completely going to be encrypted all the traffic between these two networks. So this entire design primarily designed or originally designed for your hybrid connectivity, so that the site-to-site connection with Azure to your on-premises network can be established. So if you look at here, the device is the same device which can also used not only just for the VNet to VNet connectivity, it also can be used for your site-to-site connectivity. Let's say you have a VPN device on your on-premises, and you can establish a connection, but that device must be supported in terms of the VPN gateway, handshake, and other standard protocols, and that has been documented within the VPN gateway supported appliances. For a minute, if we go back and summarize between the Vnet peering and the Vnet to Vnet connectivity, both are supporting similar to the features like cross-subscription, cross-region connectivity. However, just to understand that Vnet peering, we are going to be used in the backend as the Microsoft backbone for your private IP, because that doesn't require any public IP connectivity, and within your Microsoft Azure network it's gonna communicate. Whereas with VNet to VNet connectivity, definitely when you introduce the VPN gateway, the IP address will be needs to have the public IP. In fact, you can have primary and the secondary public IP also, so that for the higher availability purpose, and this entire communication can be encrypted. So in the real world, we can use either VNet to VNet connectivity or virtual network to virtual network peering options also. Let's summarize with the comparison between VNet peering as well as the VPN gateway. So when you use the VNet peering, it is designed for VNet to VNet connectivity, whereas it is designed originally for the VPN gateway is originally designed for hybrid connectivity to site or point to site connection. The key differences for the virtual network gateways would be if you are in need of some kind of compliance or standard point of view where you need to have repeating gateways, and that must be support of transitive of routing, which we know it's not supported in VNet peering. And then for the encryption and other purpose, you would definitely fall back to VPN gateways configuration with the VPN gateway interaction. And if you don't have to use your encryption and you don't need to have your transitive of routing, then VNet peering is a purpose built for connecting your VNet together, and you know that it's going to be a private and with the low latency interconnectivity which uses across the Microsoft backbone network. So that's where you're going to use the VNet peering. So these are the key differences in terms of VNet connectivity as well as the VNet peering. I hope this lecture is useful for you. Thank you for watching this. Hi there, welcome back. So far we learned about virtual networking or VNets, but now it's time for us to go for a deeper more into integrating some other networking components. So this falls into the integrated networking topics like VNet peering and VNet to VNet connectivity and service endpoints and private link. And this lesson is all about service endpoints. So let's talk about what exactly service endpoints. The use case for service endpoints are limiting public access to some of your Azure resources. If you see here, the subnet, within the subnet you have a virtual machine. The subnets are part of your VNet. Now what's happening is within this subnet, whatever the machine you have, it's trying to access with the help of service endpoint to your maybe as your resource. For example, it can actually go and talk with any of these services. So let's talk the similar architecture, whatever we have seen here. What's happening is within the service endpoints, the machines, whatever the resources you have here, is try to access your storage account, for example, or any other resources that are currently available within the service endpoints. Let's say here I have a storage account. I may also have your storage, maybe SQL database, data warehouse, or maybe database for Postgres, or maybe database for MySQL, or maybe for MariaDB, Key Vault, Service Bus, Event Hub, and Data Lake with the Generation 1 and App Services. So all these are currently available as a service that can be accessed with the help of service endpoints, and these service endpoints can be configured for any of these services. And remember that these are just the list as of August 2020. And it can be increased in the future, and also make sure that not all of these resources or the services are available within every region, but luckily all these are currently available in all the regions. But you please do check it, what are the services are currently available in your region. So that being said, let's take an example of one service, maybe as your storage account here within this design. By default, we know that if we have a storage account, that can be accessed over the internet from anywhere. But that's not the ideal design. What we wanted to secure, and that specific storage account only should be allowed within that specific a subnet, or let's say from your on-premises network. So let's say within your on-premises, whatever the machines are going out, definitely there would be a public IP. So if you give that public IP, machine is coming with that public IP as a NAT output, then only you should be allowed, or something like that you can configure, so that what happens is the secure communication is happening with the help of service endpoints for any of these services by using your existing subnets. So if you remember here, we are not creating any additional subnets or any additional networks. So what we are trying to do is we are actually depending on a subnet. So we say that, whatever the 10.1.0./24 subnet, so we use this subnet and we enable whatever the machines are there here within this subnet to connect with the help of service endpoints, and we allow them to contact or allow them to access any of these services. Let's say here in this example it's a storage account, so I can allow for only storage accounts to be accessed. So that's the idea. That's where the network security can come into the picture, where by using the service endpoints you can highly secure your Azure resources. So technically what happens is when you selected your subnet and when you try to create your service endpoints to your Azure services or Azure resources here, whatever they are in the list, so what happens is in the backend it actually creates a route table and it updates that route table, and based on the route, these machines within this subnet or within this subnet, whatever the resources have, that will be communicating with the help of service endpoint. That's how it's going to work. Let's take the key points for a service endpoint. The first point would be it actually maintains a public address, the service and does not get a private IP address, and the service endpoint is accessible by Microsoft DNS because the IP address hasn't changed. DNS stay the same IP, and it's not available from a private on-premises networks. That's a drawback. For example, you may want to access a service endpoint over your site-to-site VPN with a private IPs. That won't work because there's no private IP addresses assigned to the service endpoint. So you can use, however, in that situation you can use by adding your organization's public IP. Let's say here whatever the NAT is happening within your subnets from your on-premises network, that IP address we would be adding to the service endpoint, so that that public IP is allowed. So whatever the clients are coming from your on-premises should be remain the same IP address that we configure on top of your service endpoint, so that it will be allowed. So if you are looking for a concept where it needs a private IP address, then the best way would be to consider for private endpoints or private link, which is a specific similar concept, but with this we are actually talking with the public IP, in that it's going to be a separate network we are going to create. Because if you see here, we are actually using here existing subnet. I've been stressing on a word called subnet all the time because we are not creating here any specific virtual networks or Vnet or networking concepts. So we are using the existing subnet, or maybe we are just creating a Vnet, and definitely Vnet will have a subnet. But with the private endpoints or private link concept, you are actually going to create a specific network. So that's a major difference. That's why you will have a private IP in that situation. So You can check out other lecture for private endpoints or private link concept, but for now let's jump into demonstration and see how we can simulate the specific design and try to work with our virtual network service endpoints. As a first step, I'll show you my networking components. So if I just go to my virtual networks, I have two Vnets, one with the West US, other one would be the East US. So I'm going to focus on only West US 2 region. So I'll just click on West US 2, and within this Vnet, I do have here a subnet, which is specified for my VPN gateway. Also, I have a normal subnet which is used within my Vnet. So if I just go to my virtual networks, I should have a virtual machine within this subnet. So let's go to my virtual machines, and you see here under West region I have a virtual machine which is in a start state, running state, and you can check out the subnet, which is the IP address range also matching with that, and I use the same Vnet or the subnet. If you see here, AZ-WS2 or West US2, VNet1, AZ-WS, that's a West US2, and VNet1, subnet 1. So this is what we have. So the demo should be, looks like, I'm going to configure, the first point would be our Vnet. I'm going to enable the service endpoint for the storage account. So I need to have a storage account. Let's see, if I just go back to my storage accounts, I should have a storage account with the same region. If you see here, West region, and also the same resource group. So if I just go to my storage account, I have a resource group, and the West location I do have here. So what I'm going to do is, now this specific storage account which can be accessed from anywhere. Let's say if you see here, my IP is coming from a different region, even though this is not in Microsoft network. And this is what's my IP information. So I should be able to access this storage account from anywhere. So I have a storage explorer here on my PC. So what I'm going to do is I'm going to enable to connect to that specific storage account. Let's have it try first. Let's try to connect with the connect button here, and when I click on here, normally the storage account will ask for the string specific, and if I have a connection string I can give here. So let's say I wanted to take the connection string of the key one, so that should auto build actually, and then I should be able to connect. So I'm able to pull up all the specific keys information here. Let's say if you see here, my AZ demo service endpoint specific service account. If you see, this is my service account. So the service account, I'm able to browse from a different machine that's publicly I'm able to access. So this is not what we wanted. We wanted to secure. So that's where it comes, the service endpoint, which will allow you to only grant access within your subnet. So that's what we try to discuss here. So within the subnet only it should be allowed, and it shouldn't allow from outside. So that means the public IP shouldn't be allowed, let's say, or it should only allow for your on-premises network only. And in that situation, what we do is, within your on-premises, whatever you have the NAT IP, public IP, that we would configure. So as a first step within this demo, we would actually go and disable the public access and secure to access only for the private IP. So to do that, what we're going to do is we are going back to our storage account and enable the service endpoint. For that, in this case, this is the demo storage account that we wanted to work. So let's click on that storage account, and if you just go back to under settings, you have an option called firewalls and networking. Within this you have an option allow access from. So currently it is allowed from anywhere. That's why we are able to connect it here from any location. So what we're going to do is we are going to select that specific network, virtual network, and click on existing virtual network, or you can create your own Vnet also. So in our case, we're going to use existing virtual network, that's Vnet. So in my case, that's my subscription. and this is my Vnet, and within this my Vnet I have two subnets. So out of that, the subnet is the subnet 1, which is this. So endpoint service request required. So this is what I'm going to configure and say enable. So it takes some time and it will finally enable. In this case, it's successfully enabled now. That's good. So I'll just close this. Oh, cancel. It looks like it's not yet added. Yeah, it's added now, and I can save here. So one more time, so it's going to save the configuration. So if I just straightforward, if I just go back to this specific storage account, and if I try to do a quick refresh, what would happen if I try to access maybe containers? So it says that you don't have access if you're not able to retrieve it. And similarly, if I try to connect, so I'm keep on getting an error because I can't access, because this is completely restricted for only that specific Vnet, and within that Vnet a specific subnet. So let's try the same configuration, try to access from our virtual machine, which is coming from our west region within that subnet. So I'll just connect to the VM and we'll see from here what happens. Connecting to the machine and post to the connection. You can see here I have the same subnet IP address for this machine. And now if I just go back to my Azure portal and try to connect with the connection string, I should be able to grant access or get access here. So it just got connected without any issues. And if I just explore furthermore, I should be able to access the files. So I can create here a container, for example, VHDs, and I can upload files. I can do all the things that I wanted with my storage account. So this is how you're going to secure with the help of service endpoints configuration for your any of the Azure resources that are listed here. So that's how it's going to work. So let's say if I want to access, since it's not working fine from my local machine, so how would I do that? Let's say you have maybe on-premises network here. Within your on-premises network, you wanted to grant access for your users to get connected to your storage account. So for that, what you will be doing is you would be actually adding the NAT IP address. For doing that, you simply have to go to your, again, service endpoint, in this case the firewall, and within here you can simply add here the IP. So as you know that this is my public IP, I just verified, so I'll simply take this public IP configuration and simply I'll just put it here, and that's it. So that's going to be my exception, and if you see here, it actually discovers by default whatever the public IP information, but I just wanted to show you that. So if you have multiple IPs, so you have to give maybe your head office maybe location, or maybe your branch office 1 or branch office 2 locations IPs, so that it will allow only for your networks. So that way you're going to secure. So that's how it's going to secure your network with the service endpoints, and all these components very similar. It's gonna work in the similar fashion for the service endpoints. Let's try from accessing from my local machine by just to refresh. Let's see what would happen. So if I just go to refresh, I'm still not getting because I have to log out. Let's try to detach and then attach it. So that way I'm gonna connect it. So I'll just click on connect, and I'm gonna use again same the connection string mechanism and connect it with the connection string connect. So it's trying to connect, and if I just go back here to the blobs container, I'm able to access. So that's how it's gonna work. I hope it's really useful for you to configure this entire configuration. Kindly take a minute to review the course so that it will be really helpful for me. Thank you. Hi there, welcome to this lesson on Azure Private Link, where we are going to have a look on how we can use the Azure Private Link services to integrate specific Microsoft services within our virtual network. To understand about Azure Private Link, or what exactly is Azure Private Link, it means that we are talking about providing a private connectivity from your resources in a virtual network to Microsoft service via a private link. So the key message here to remember is the private IP addressing. So other way of explanation for what exactly Azure Private Link is, it will enable you to give you an access for your Azure platform as a services, for example, either Azure Storage or SQL database, and these are hosted at your customer owned or partner services over a private endpoint in your virtual network. And if you look at the network traffic between these virtual networks within this service negotiates over the Microsoft backbone network. So you are eliminating exposure of public internet or internet connectivity. So we can also create our own private link within the services to your virtual network and deliver it privately to your customers. Okay, so we do still get a familiar optimized backbone routing. That's what we discussed and that we have seen within the previous lecture for service endpoints. So when we use your private link here, not only we get the backbone path of between resources in your virtual network, and also we get the supported Microsoft service, but we get a private IP address that within the resources. That's a key as we talked beginning of this lecture. If you see here, there are two things that we have within this short PPT. Like we also have your private endpoint. So what exactly this private endpoint? So private endpoint is a network interface it's going to create automatically when we try to configure either private link or private endpoints. So it is a network interface that connects you to privately and securely to services powered by Azure Private Link. So this private endpoint is nothing but another way, it's a network interface, right? What we talked. So it will have an IP address. Definitely, it's going to be a private IP address from your Vnet, and effectively bringing the service into your virtual network, because since it has the private IP address, and the service could be an Azure services, for example. It could be a storage account or maybe your CosmoDB or SQL database. Such different services we can take as example. So we talked about the private endpoints, which is nothing but it will have an NIC card and it will also get the IP address. And when we talk about the IP address and the communication, there should be something called DNS, right? The FQDN, it's going to be a part of your connecting string. So it is very important to correctly configure your DNS settings to resolve to all your allocated private IP addresses. So existing Azure services might already have a DNS configuration within your network. Maybe let's say if it's your on-premises or maybe on your cloud, you might have already your own DNS configuration. So in that situation, you might have to reconfigure according to your configuration to resolve that private IP address or the private endpoint IP address to that specific Azure resources. Let's say there are different services as we talked. For example, if I take it as the database, so I need to give here as the I need to give as a private link database.windows.net or database specific information to be to be configured, and these are the list of specific zones that needs to be configured according to your scenarios. So again, the scenarios could be either you fall into without a custom DNS server, or maybe you may have your working with a DNS fast forwarders, maybe within your on-premises workloads. And also last one would be the you might have a configuration where you wanted to forward your virtual network and as well as the on-premises workloads using a DNS forwarder. So in that situation, you might have to send these specific resources information to be added into your DNS server so that it will properly resolve with the private as well as the public request, because we are talking about the private, so all the requests should be diverted into private, and that private link or the FQDN should have an IP address for your network. So we need to configure that specific configuration, and please make sure that you check out the specific link which is associated within the lecture of this course, and you can check out here by visiting to docs.microsoft.com, and then you can go for the private links here. So this is the link which talks about that specific DNS configuration. Now let's go back to the slide and talk about the key benefits. So the key benefits are here: you can access privately the complete services within your Azure platform. So when you connect your virtual network to services Azure without a public IP address at a source or a destination, that means it's really secure because your services are not exposed to the outside, and the service providers can render their services in their own virtual network, and consumers can access those services in their local network. And the private link platform will handle complete connectivity between the consumer and services over the Azure backbone network. And the second point is on-premises and the peer network. So accessing services running in your Azure on-premises over your express route. Let's say you have a configuration for the private peering or VPN tunnels or peer virtual networks using private endpoints. There's no need to set up any additional public peering or transfer or communication over the internet to reach the services, because we are going to configure just the DNS specific configuration for your on-premises network. So all we have to do is we have to simply resolve that specific service, and it would get connected with the help of backbone of Microsoft network. And third point would be the protection against data leakage. Definitely, since the private endpoint is mapped to an instance of your platform as a service resource instead of the entire service, so you're not exposing everything, you are just exposing whatever the service is needed. And if they try to access any other services, that specific service will be automatically blocked. This is a mechanism provides the protection against any of the data leakage risks. And coming back to the other point, global reach. So connect privately your services running in other regions. The consumer's virtual network could be in a region A, and it can be connected to different services behind the private link in a region B. So that really helps, or it resolves your regional level virtual network problems. So you don't need to even go for a peering or other concepts site to site and other things, so it works. And the last point for the key benefits would be you can extend your own services. So when you enable the same experience and functionality to render your services privately to your consumers within the Azure by placing your service behind a standard Azure load balancer, you can actually enable it for private link, and the consumer can then connect directly to your services using a private endpoint in their own virtual network. And you can manage the connections request using approval call flow. There's a method how you can approve it. And finally, Azure private link works for your consumers and services belongs to a different Azure Active Directory tenants also. It doesn't depend on specific to your own tenant. And last but not least, let's also have a look on the logs and monitoring point of view. When we look at the logging and monitoring, like any other services, for the monitoring purpose, you can also monitor with the Azure Monitor for your private endpoint locations for the data inflow and outflow. Similarly, private link also can be monitored with the in and out data processed, and also NAT port availability information and you can actually archive the logs to your storage account, and you can stream to even Event Hub for further analysis. And as we talked here, Azure monitoring logging also very useful in terms of having a look on what's going on within the private link or private endpoint section. And now let's jump into the pricing. That's the last one. If you look at the pricing for Azure private link pricing, for the endpoint and the inbound outbound, or for that specific data, it's going to charge 0.01 per hour basis for the endpoints, and $0.01 per GB for the inbound and outbound data process. That's how it's gonna apply the charges in terms of the data inflow and outflow. And for the endpoint, it's going to also charge per hour basis also. And there's no charges for the private link service that you create. Instead, it's actually based on the data flow. Let's try for the demo purpose. What we can do is we can actually search for the private link, and you would be getting a link here. And this is where you're going to actually configure. Once you configure the connectivity, specific information will be appearing here as the active connections. And you can configure directly either from here or go to that specific resource. Let's say if it is a storage account, I can go for that specific storage account and configure your private endpoint connections. So you have two options: either you configure from that specific resource properties, and from the settings you have the private endpoint connections, or you can also go for your private link and configure your private endpoints. So if I just click on add here, and then I'll just select my resource group here. In this case, I'm going back to issues, and then I'll give here maybe a private endpoint specific name, and there should not be any space, so I'll just give, and then I'll click on next for the resources. This is where we are going to check about what kind of resources we can enable the private endpoint. Let's say I want to use this within my directory, that is my Azure Active Directory, and then I'm going to use here as specific resources. So these are the type of resources that we have, and these are the things that are supported for the private endpoint. So in our case, I'm actually going to try with the storage account. So I'll just click on the storage account. Now what happens is, unlike with your service endpoint, where we used to get the entire storage account configuration, but now if you look at here, with our configuration with the private link or private endpoint, here you can go and configure explicitly the services. So what I mean is, let's say I want to just work with the file services, I can go and configure the specific resources. That's what we talked earlier within the PPT, like whatever we configure, that only will be granted in the private with the private link, and the remaining services gets automatically blocked. So I'm gonna choose here my storage account. In this case, I have a storage account called for East region for AZ demo private endpoint. That's my storage account, and you see here you have the sub resources. So this is where you can configure. Earlier, if you remember, with the service endpoint, we configure for entire storage account, but here with the help of your private endpoint, you can go and configure for a specific service. So what does it means is, if you're trying to configure maybe a file, and also for the tables and the queues, you have to do it 3 times. That means every specific sub resource you have to repeat it. You don't have a checkbox mechanism to just to right away you can configure. I'm sorry for that, but that's how designed within the GUI from the Microsoft. So just select here file specific and click on next, and it's going to actually configure automatically a specific subnet that we can choose here. So in our case, we have entire network is this, so it's not going to create, but it's going to use my existing Vnet. And now this is the time where I need to go for a design consideration whether I want to use my private DNS or I have my own DNS. If so, I need to integrate, I need to create the specific value within my DNS zone. So what I have to do is I have to go to DNS server and then create a DNS zone with the given IP address that's going to create for us as the endpoint, private endpoints. So in our case, integrate with the primary DNS, I'm going to choose only the default private DNS zone information for now, and I'll just go to next tags. I'm not going to apply any tags. Let's review and create. So this is the review setting. For a minute you can have a look on and create. So this might take a minute or so to create that specific resource. So in the meantime, if I just go to by open this in another window, and I just wanted to show you the resources that are available within this portal. So let's go to my resource group here, to my east region, and if you see here, there's nothing called private link or private endpoint, all that. So it's going to create in a minute or so here. So it's just creating private endpoints, and if I just go back here and do a quick refresh, I should be able to see here a specific one. For example, here private endpoint which got created, and this is very similar what we talked. It's going to have an IP address. This is the network interface. So with this network interface, it has assigned an IP address also. If you see here, so what to be done is you have to create a DNS record for this specific zone with this IP address. That's how you have to design your services. And it's still, the deployment is underway. Now the deployment is completed, so let me go back to the resource group and try to refresh and see what else it has created for us. It has completed, and you do have here a different configuration like private endpoint which got created, and also something called the private DNS zone has been created, which is a global location, so anywhere it can resolve this one. And there's a record which is pointed to the private IP. And now if I have my own DNS, I have to go and create the specific DNS zone. Unfortunately, you have to do it for every service, because as we shown within the previous article, it is completely different. So you have to create the number of different zones, and then the records that's to be created, and all of your client machines that are trying to access these Azure resources should point to that DNS server. So that DNS server will have these all the records with the internal IP. So what happens is they will point and they will get connected to the internal network instead of go and connect over the internet. So let's say if I try to check my resources, let's say within this resources I have my storage account. For that we have done this entire configuration, AZ demo private endpoint, and if you see here I have the access keys also. What I'll do is I'll just simply reconnect by here to this, and this machine is not connected to my Vnet. I should be able to access without doing anything also, right? Because we didn't configure anywhere to restrict. So it should allow me to connect to the specific storage account, and if I have maybe a blobs or maybe share folders, everything I'm able to grant the access, and it's good. But ideally the private endpoints or private link share are dedicated for not to route over the internet. So this specific is not a good case of testing. So what we have to do is we have to block it with the help of your storage account. Let's say if this is your storage account, in my case it says your private endpoint is my that's the name of my storage account, right? So I'll just go here from my firewall and virtual network, I should see that currently it is allowed for all networks. That's why I'm able to connect here. So what I'm going to do is I'm going to say that select a network, but I'm not going to select any of the virtual networks. That's a tricky part here. So I'm not going to select any of the virtual network, but if at all, if you want to give for a specific subnet, let's say here maybe I can choose here my Vnet and then my subnet. I can grant here, but I'm not going to do this. What I'm trying to do is I'm trying to say here select a network, but no networks are available. So I'm going to save this. So by doing this, what would happen is it will not allow any of the network, but internally it is already have a permission for the connection specific to the private link has been already created, private endpoint has been already created, so it will allow for that, but not for any other Vnet. So if I just go back here and say or try to refresh here, maybe like just a refresh, it says that I do not have a permission. So I got an error straightforward here. And if I just try to do here also, it got error from my public internet facing machine. So it is not allowing for any public network. Now the best way is securing with the private endpoint is to test again from our existing private Vnet private endpoint machines. So let's go back to our storage account and see if I have any of the Vnets. So if you see here, this is my resource group. Within this I do have a Vnet which we tested here. This is a RGES US Vnet one. So this Vnet has already serviced with our configuration for the private link or private endpoint configuration, right? So within this Vnet we also have a VM. So with this VM also getting the similar IP of 10 from my Vnet. So it's a good test to test from this machine. So I just connected here and you see here I'm getting actually the IP address, and also host name of this machine is from the EUS VM01. So now if I try to actually try to connect directly from my Storage Explorer and see what happens. I'm trying to copy my connection string so that I can connect it here. I'll just click on connect button and I use again the connection string. Next I'll simply paste my connection string and connect. So this time it gets connected for sure, but it will be only for the file share, because we only granted for the file share, we didn't granted for the blobs. So that's why we are getting an error for the blob, and similarly for the queues also we get an error, but for the file share we are able to get actual files list and other information. So this is how it's going to work. And if you really remember, we didn't configure here even the Vnet also, and in addition to that, in the private endpoint connections we did actually give a explicit configuration that should be taken specific to the endpoint for only the file. You see here the file, and let's have it actually do a quick FQDN and see on that machine what we are trying to get. So I'll just copy this and I'll just go to my virtual machine within this Vnet, and I'll just go NS lookup. In fact, you can actually when you just NS lookup with this, it's actually resolving to the private IP instead of the public IP. That's interesting. And because this machine is DNS is configured with the Azure DNS, so I'm getting the private IP for my storage account. In other way, it is actually connecting to my private IP address by using private IP, not over the public internet. So that's really useful and easy way to configure and secure your private endpoints. So just for the summary before we wind up this lecture, private endpoints accomplish a similar task, but what we have done with the your service endpoint. Similar tasks it can achieve, but it actually works differently with the private endpoints. A virtual network interface is added like this. In this case here is the private network endpoint NIC card has been added, and it will have a specific private IP which is associated with your Vnet. So let's say if you have already connected with your VPN, or maybe express route or site-to-site VPN, all that machines also connections can be established, because it behaves very similar to other network devices since you have a network interface. That's a key here. Some of the key points that we discussed within the lecture is all the public access for your storage accounts can be completely blocked with the help of storage firewall, and your internal DNS resolves the storage account host name to a private IP address that we have tested within our virtual network also. And external DNS also can be resolved to a public IP as well as to your private IP also. But if you want to apply any of the NSG, that's network security groups, are not applied on your private endpoints networks, and outbound network security groups rules can be applied other network resources to block traffic to private endpoints if really needed. That being said, for the monitoring points, you can go and check for your private endpoints. For the monitoring, you can add your metrics. You can even go and create a new alert if you really need it. The way we do it in the monitoring section, all that are applicable for this specific settings. And thank you for watching this entire lecture. I hope this is really useful for you. Please give me a feedback on this course by writing a simple review. That really helps everyone. Thank you. Hello and welcome back. In this short lecture, you're going to learn about virtual network routing and its connectivity. Let's take an example where you have one of the virtual network. Within this virtual network, you have subnet 1 and the subnet 2, and also there are some other resources on each of these subnets. As you know by this time, when you configure any of the virtual network, by default all the resources can go and communicate with the internet that's outbound is fully allowed, meaning that technically there are some kind of default routes are already configured, which will be done by Microsoft Azure automatically. In a minute we are going to do that. We are going to configure, we are going to override those default routes, and we would redirect those traffic and all that. But just to assume that when you have your own virtual network, definitely all the virtual machines can go and communicate with the internet. The reason being, the backend you have already a default route which is configured. You might be thinking that there could be some kind of network security groups which will actually block this access. Yes, that will block, but the route path is already configured and it's a straightforward, and you're just applying some kind of filter. What if you wanted to change this default behavior? Let's say what happens if you want to block one of these paths. Let's say for these machines shouldn't go to internet, but subnet 2 will be allowed for the internet. How can we allow? By going this path to internet like this is allowed, but going here is completely blocked. So this is where the path can be configured. That's nothing but a routing path. So this is where we do the custom routes and we change the default routing behavior. If you think why we may have to do this, let's say you wanted this entire traffic to be diverted to a specific firewall appliance, and then it should be filtered. So the default path is everything is going to the internet. Instead of that, you don't want that to go to internet. Instead, it should expect the traffic should go to maybe a firewall. So that's a default. You're overriding your default route, and you can configure such things. So let's jump into Microsoft Azure portal and do similar configuration and try to understand how it looks like the custom path, custom route path, and default routes. When you go back to Microsoft Azure portal and have a look on one of the virtual machine, let's say if this is a virtual machine and within this you have the networking, and each virtual machine will have associated a network card will exist. So just click on the network card and you just go to here effective routes. This is where it's gonna list the routing paths that it's gonna use to route the traffic or the path it's gonna set it. Let's try to understand this effective routes that are listed here. You see here there are a few of the routes which are default, and the first one, if you look at here, which talks about anything with the 10.1.0 series, it's gonna communicate with the next hop as the virtual network. So it will just route the path to virtual network, and from there it's gonna communicate. And similarly, if anything is not as a 10.1.0/26 16, then it's gonna hand it over to other routes. So let's say you're trying to browse Google, or let's find out the Google's IP address. Let's say you're trying to browse the Google website, so it's gonna point to this IP, and when it's not following this IP address anywhere, it's gonna actually take the 0.0.0/0. That means if any of the IP address, it's gonna allow over the internet. This is how it's gonna you're getting the internet. Today you're getting internet because default route is accepted, because 0.0.0/0 is already configured as a default route. So that's why you're getting the internet. And if you see here, this is another subnet where it's you're gonna communicate with that, and these are all other series similarly. So we have for this virtual machine, all these are enabled as the default route paths. Within networking, you have a concept called longest prefix match, which is very important when you're dealing with routing, because when it says that it is that I'm going to use whatever the route entry matches my destination prefix most closely. So when it comes to the closest one, let's say if these two are close, then it just takes a preference over the longest one as this. So it doesn't go to the internet, instead it simply comes here and it would check out. So this is how it's going to work within the routing. Now let's jump into the real demo. Like we wanted to block, or we wanted to override the default route. So this machine shouldn't go to internet. So how we do is we'll simply go back to our virtual network. So in this case, I'll just go to virtual network is here. This is the virtual network. That's a Vnet. So I'll just go to the Vnet, and then if you just go to the subnet, and within this subnet, you have something called route table. So, oops, I missed out. So here you have the route table. So when you create actually a route table, you would be able to see here. So you can apply those route table to override that configuration. So that what happens is whatever the default configuration you have done, so that's gonna override with this specific route table that you are actually configured here. So as a next step, I'm going to create a route table, and then I will come back here and apply this route table whatever we have created. So to create the route table, just go to create a new resource and then type as route table. So you would see a resource called route table. So click on create. This is a straightforward inputs that you need to give here in order to create this route table. So I'm just going to select my DNS, and in this case it should be region as East years, and I'm going to give here the name as the block internet route. If you have your on-premises, you may have to choose this also no, but in my case I'm going to create entire this route table to be applicable for Azure resources, so I'm going to choose as yes. And then you can apply your tags for the billing purpose and review it and create a route. So it's going to create a route table. Route table is created. Let's go to the resource, and if you see here, from the routes, there are no routes currently configured, and also there's no subnets got associated. What happens is if you associate those subnets, the configured routes, whatever you're going to configure here, will be applied to those subnets. That's how it's going to work. So I'm going to create a first route. So I'll simply click on add and give a route name. Here I can say that this is going to be block internet, and here the address prefix, like you can, as we talk, anything that was not mentioned within the route table, we wanted to block it, because internet is open, means it can access on a different IP. So the best one is as this. So I'll just give the 4 dots and then /0. So anything here, but the next hop I'll select as none. So what happens is if anybody is trying to access, so the prefix is this, that means any of the IP, like you take any website's IP address, the next hop is none. It's not going to deliver anywhere the packet. So click on OK. So that would actually create the route table for us. Now the route is successfully created. Now we have not yet assigned to any of the subnets. So as a next step, what we'll do is we will associate with our one of the subnet. So the first option would be either you can directly assign from here, or you can go back to your virtual machine and the similar configuration what we have done. Let's see, I'll just open in a new tab. Here we can go back to our virtual machine. In this case, this is my virtual machine. Let's say the DNS demo VM1, and I can simply go back to my networking, and here this is my Vnet. So within the Vnet you have the subnet. So this is where I can open my subnet, and this time if I just go back here, I can be able to see here route table. I can simply select here and save, or I can directly even do it from the route table by associate here. And all you have to do is you need to know what's your virtual network. So in this case, this is my demo Vnet 1. That's the only Vnet 1 we have within my resource, and I can simply select the default. So it's gonna click OK. That's gonna actually save and apply. So it does the same thing. Either you go from here from the Vnet properties and then the subnet, or you can directly go back here and do the configuration. So now it's associated. So I'll just go ahead and one more time I'll just click on here. So this time you should be able to see here as the block internet route is configured. Let's say you wanted to have one more route where you wanted to send the internet traffic to your firewall. So what you're going to do is you would actually go back to the route and you would create one more route saying that this could be my firewall appliance. Maybe in this case it could be a checkpoint or maybe Sophos or whatever it is. So you can give your the name of that your firewall so that it's more meaningful. Later point, you can select here as a virtual appliance, and you can give your appliance IP address. So let's say if the IP is 10.0.1. maybe 0. maybe here in this case maybe 200. So that could be your firewall appliance, and give you the address prefix. So all that addresses ranges will route the traffic with your firewall IP. So let's say if I want my all the DNS specific queries should go to my route table, I'll simply give this specific subnet information, and then it will simply go and create that specific route table, and all the traffic will go and route with that IP address which is configured as the firewall appliance. Since we have two now route tables, or within this route you have a two entries, let's go back to one of the virtual machine and see what happens. Let's say I want to go to demo VM01 and my networking, and then I'll simply go back and select my virtual network interface and click on effective routes. This will open up here, and you see here what happened. The default ones are all showing as a default, but the custom routes that we created showing as the user created. So what happens is here one become as the invalid. Earlier this was an active, but we have created a very similar one. If you see here all these IP address prefixes which is similar, but here we have said that next hop is none, and this explains the address prefix as identical. So there are different scenarios where address prefixes, when it becomes as the identical, we might have to consider a special case. So let's talk about those special case scenarios, what happens, and what are those special cases when we can see these kind of identical things. Let's say you have a Vnet to Vnet peering, which we are going to talk in the upcoming lectures, or maybe you can check out in the networking section. Vnet to Vnet peering is nothing but your virtual network to another virtual network you can peer. That means all these machines in the Vnet to virtual network 2 can communicate with virtual network 1, maybe a subnet 1 or subnet 2 also can be, resources can be communicated. So there could be default routes which are provisioned automatically by default when you do the Vnet to Vnet peering. And also there is another special cases which we are going to learn in the upcoming lectures about the service endpoints. If you are trying to use the service endpoints, it's going to create a default routes automatically. And also let's say you are trying to create from your virtual network to a express route scenario. In that situation also you're gonna get the default routes. So for express route, definitely there would be a different protocol you're going to use, that's called border gateway protocol, that's BGP protocol. So the BGP protocol is works as a gateway level, and for that also it could be a different routes will come up, and those are very identical routes will be created. So what happens in these situations? We talked about the identical route address prefixes, and then in that situation, like a Vnet to Vnet peering or express route or maybe service endpoints, in these situations or in these scenarios, it's gonna go for a different path that's called, so the order that it's going to apply is a custom. So the first one would be the custom is the highest priority, then it's going to work with the BGP route, and then the system default route will be accepted. So this is where it's going to check, and it's going to work in that fashion. This concludes the lecture on virtual network routing and connectivity, and just make sure that what is going to override for the identical. This could be one of the exam question, or might be a real-time problem that you might encounter. All the time the custom takes a precedence, and then BGP, and then the system. Let's say you are blocking it, custom that's going to apply the policy, and it's going to ignore the BGP and the system. Similarly, if you have a policy on a BGP route path, and then it's going to ignore this system, but if that is conflicting with the custom will take over the preference over the route path. That's how it's going to work. Thank you for watching this. I'll catch you in the next lecture. Hello and welcome back. In this short lecture, you will be learning about Azure Firewall. Azure Firewall is very similar to your on-premises firewall or any of the managed firewall, but here within the Azure, it's a firewall as a service model, which you are getting as an offering from Microsoft Azure Cloud. So there are not just a Microsoft Azure firewall, there are different third-party firewalls also available, like Checkpoint or Sophos next generation firewalls and Palo Alto. All the great firewalls are available. Out of that, Microsoft also introduced something called Azure Firewall, which is also works very similar to other third-party products. But this is dedicatedly from the Microsoft. So you get the support from Microsoft Azure Firewall. So to begin with that, to understand more about Azure Firewall, it's a managed, it's a completely managed and cloud-based network security service that provides to your virtual networks as a resource. So it's a fully stateful firewall as a service, which is built on high availability and unrestricted cloud scalability. So within this, it works on L3 and L7 connectivity policies for the user policies, and also it is fully integrated with Microsoft Threat Intelligence for known about malicious IPs and other FQDNs. So it's a fully integrated this Microsoft Azure firewall. With this, you can centrally manage and enforce, and you can manage, not just the manage, you can also log every information, every possible information, and you get that network connectivity policies across your subscriptions, and you can filter them, and you can identify what kind of traffic it is originating from your virtual networks or your Vnets. And it's fully integrated with Microsoft Azure monitoring for log analytics services. And this Azure firewall is fully built on high availability, so no additional load balancing is definitely not required for you to configure. So if you just install and configure this Azure firewall or introduce this service within your resource group, that would take everything. When it comes for the communication side, this Azure firewall works based on hub and spoke method. Like it is a central point, as I said earlier, from where all the spokes will communicate to the firewall. So let's say if these are into different Vnets, that communication will go and communicate within the Azure firewall, and then the server communication or within that Vnets also will be established the communication between with the help of Azure firewall. To do this, you definitely need to depend on your routing table. So there's a Azure routing tables which you are gonna create it, and then you would divert the traffic from the Azure firewall. And this also supports not just the cloud, it also supports your on-premises traffic also can be managed. Let's jump into more to understand about Azure firewall. So Azure Firewall, as we discussed, it's a firewall as a service model, and this is fully managed cloud-based network service as a security feature which is coming from your Microsoft Azure cloud to protect all your network resources. And it's a fully stateful firewall as a service which built on high availability and unrestricted cloud scalability. And you can centrally create, enforce all the logging applications, and you can monitor your entire network connectivity across your subscriptions and also from different Vnets. And as your firewall uses a static public IP, that means you can get the exact log information whatever it's going outside, and you can block a lot of firewalls rules can be applied, either application specific or any other things for the outbound, and you can get that specific identity for the traffic which is originating within your virtual network. And the services is fully integrated with them for the log analytics services, so you get the more in detailed information with the help of the logs when you are subscribed for the log analytics services. That means you can integrate that, and also it's highly availability, it's built in, so no additional load balances or no additional cost is required to manage these kind of services, unlike other third party always recommends you to go for more than one firewall mechanism. This doesn't require. And also you can enable with the availability zones, and your availability increases up to 99% if at all you use for the availability zones, and there is no additional cost for the firewall deployment in availability zone. However, there are additional costs for inbound and outbound traffic which is associated with your availability zones. And we didn't talk about the pricing. Pricing is it's very plain, based on hourly pricing. So how many hours you use, based on that it's going to charge. Also the data which is traveling from your firewall also will be measured for the costing purpose. If you're looking for the better performance per region, deploy one firewall one firewall per region basis. And also you can centrally create alert any networking rules by source and destination IPs or ports or application protocols. And also you can have your FQDN tags, which makes easy for you to known rules side if you're trying to create any of the network traffic through your firewall. And you can apply service tags, and it also built in threat intelligence for off, medium, or block automatically. All that kind of configuration can be enabled, which we are gonna look at in the demo, which is coming in the next lecture. And also we do have the outbound SNAT and inbound DNAT support. And also if you look at the limitation sides, there are multiple limitations. If you are looking for the more known issues or limitations, go to this URL. But for now, as in recording of this May 2020, these are the limitations, and who knows, in future it may change. So coming back to the most common known or useful cases where you have the limitations is network filtering rules for the non TCP/IP UDP protocols, such as ICMP kind of thing doesn't work for internet bound traffic. And you cannot move your Azure firewall to a different resource group or a subscription because it is fully associated with a subscription and your network resources. So once it is tightly integrated, you can't move it definitely. And limited port range is supported, like 65,000 range, and post 30 doesn't support. You can check out more from the known issues within this URL. And also no customs DNS is supported. That means it only uses Microsoft Azure DNS, and there is no support for your other DNS support. And also no SNAT and DNAT for your private IP destinations. That's how it's gonna work. Now in the upcoming lecture, we're gonna try spinning up 2 virtual machines, and we will create one of the jump server. From the jump server to your server location, you can do a RDP and then access some of the websites. Then that traffic will be routed back to your firewall, and if the rule matches within the firewall, it will allow for the internet connection, like we create for Microsoft site or maybe for the Google or different sites. And we will try to filter the traffic from the firewall. That means we are going to deploy 2 servers and 1 firewall in the upcoming lecture. Let's go back to the Azure calculator, price calculator, and search for the firewall, and you get it Azure firewall. Let's take that and see the firewall deployment is per deployment you're going to charge per hour basis, and also for the data processing per GB it's going to charge for you. And let me change currency to USD so that it will be easy for everyone, convenient. And deployment is per deployment it's going to charge $1.25 per hour, and any of the data it's also will be included per GB 0.0016 or 0.16 cents. And the secured virtual hubs deployment, this is the price if you're trying for any virtual hubs pricing, which is in a preview, which is not scoped for AZ-500 or AZ-300 exam series. And these are the normal pricing, and I hope this entire lecture is useful for you to understand more about the Azure firewall overview. If you can look at here, it's stateful as a consolidated. You can go through this specific link. This would definitely help you out to understand better. And let's catch you in the next demo lecture on Azure Firewall. Hello and welcome back. In the previous lecture, we learned about Azure Firewall overview, and in this lecture, we will be learning about Azure Firewall with the practical demo. That means within this demo, you're going to set up your test network. Within that network, you are going to create a Vnet with 3 different subnets. One subnet will be dedicated for your firewall. Other 2 subnets will be dedicated for here 2 different servers. So these servers are deployed into different subnets. So let's talk about the 2 different subnets. So the first subnet which we talk about, the jump server subnet, means it's a jump server where you try to log in from internet and from there you log into your workload. So workload will have a different subnet and jump server will have a different subnet. So these two subnets are part of a single VNet. That means here also firewall also will have a different subnet. These three will be part of single VNet. Now once I have created these two servers, that means as a first step I create the VNet and three subnets, and then I also create two servers, Windows servers, and also I create here a firewall also. So this workload server will not have a public IP. That means it's not have any internet connectivity. But what we do is we change the public DNS. We will change the DNS to a different DNS server which we configure, and also we will associate with the help of routing table with the static route, so that the traffic anything originates from this subnet will be go and hit to your firewall, and from the firewall if the rule matches it will go, but if the rule doesn't match, the default rule is to deny, and that gets the denied traffic as the firewall will show you within your browser as it's not matching. So for this demo what I'm going to try to do is I will be trying to open here within the server workload a google.com and microsoft.com and other different websites. That's a demo. So let's jump into the Azure portal and try to create this infrastructure. While I was creating, I'll also explain what I'm trying to do here. If you're not clear at this point of time, you can also understand what I'm trying to do. I will try to capture every possible step. At the same time, I will like to go in a fast forward. So let's jump into the demo. Welcome back, and as a first step I need to create a resource group. So I'm going to create a resource group by clicking on add and giving the resource group name as test -wrg within the location called West US, and from there I'll just go to create a new VNet. So for that, once this resource group got created, I can refresh to find out, or just go to your Vnet. So from the Vnet, click on virtual network and then click on add. So here I'm gonna create a Vnet for the address space of here, and I need to select the existing resource group and giving the name and choosing the same location, that's a region, West US, and instead of review and create, I must have to go to the IP address, and then I need to give here a space, address space. So I'm just choosing as a 16, and this is very important that once you choose this IP subnet or IP range, here the default will be there. That means the name is already given as a default. Make sure that I can say that it could be a bug or it could be a recommended setting, but you must have to follow the exact name. Either you do it on your lab or you do it on your production. As per my testing, it should follow a specific name called Azure Firewall Subnet, and this name must be matching. Otherwise it will fail when you try to deploy Azure Firewall in the firewall deployment phase, not now. So I would like to give all the time this name, and also I'm going to here associating the specific subnet with the range. So here as a 26 with the one subnet, and click on save. So that actually creates a VNet for me, and the remaining settings are fine. So this specific VNet is for your firewall subnet. So that's a 10.0.1, and review and create, that gets created. So here I'm not choosing anything DDoS or firewall specific settings. I'm simply going for the default. So what I have changed here is just the IP addresses specific I changed with the IP subnet information. Now if I go to go back to my VNet, I need to create another two different subnets. So I'll just go to that VNet and go to subnets. If you see here, I have already 10.0.1.0 subnet. Now it's time for me to give other subnet. One subnet is for my workload computers, So starting with the 2, which I'm trying to give. So this name can be anything. It doesn't matter. Just for only this, it is conditional match. But other things are fine. So in my case, I'm just giving as a workloads SN and 2 /24. And I'm also trying to create one more subnet quickly. You see here, it's already created. So I'm just trying to give here as the 3. This is for my jump server. So I need to give here a meaningful name for jump-sn, maybe server name, server network, sn as server network, and simply click on OK. That actually create here subnet. So here 2 subnets got created, right? Now total we have 3 subnets as we talked. Now I'll just go back to the virtual machines and try to create a virtual machine. So before that, let me go back to the virtual machines here and click on add. So here I need to create a new virtual machine. So click on add, select the right resource group, that is in our case test -fwrg. All the time I'm trying to choose this, and here the machine name I have chosen as a server jump. So one server I'm creating as a jump server, and it's a Windows server, so I am selecting as a Windows default settings. But make sure that in the networking you have selected a subnet specific, and the Vnet should be a proper, and also subnet is for the jump server, so it's a jump SN. And you make sure that you also have here the public IP. So because it's a jump server, that means from internet we are trying to come to jump server. Once the jump server is accessed, when we reach here jump server, that means this should be within this subnet, and once we have the internet coming within this with the public IP of this public IP jump server.ip, and then what we do is we do MSTSC to another server called workload server, and from here we try to browse. That's what the demo. So as a next step, I'll just go for other default settings. I'm not going to change anything because this demo is completely specific to a firewall, so it's a default. I'll just go advanced and show you what are the options I'm choosing. Tags also, I've not taken anything review. So once I reviewed all these settings, I can simply let me scroll down so that you can see the complete settings and create. So that would actually create a virtual machine. So we created the jump server. Now the next step is to create another server, which is a workload server. So here I would take this time to create a workload server. So it's just taking some time. Yeah, it has just created. Let me go back to the dashboard and create virtual machine and click on add, and this time I'm choosing the same resource group, but the computer name I'm choosing as the different name, that's a server-workload, same region, and again Windows Server or Windows 10 I can choose, but let me go to the server configuration. But make sure that this time I'm not going to choose any of the public IP. Even RDP ports also not enabling. If you see here, RDP port is not enabled, and also here in the disks I'm not doing anything. But in the networking, you see here it's more important here. Here the virtual network is the same, but the public IP is not there, no public IP. And if you see the workload subnet is I have taken because this machine belongs to workload. So what I'm trying to do is when I try to browse from internet to this jump server, this is a jump server. So from jump server I'll do the RDP, but from here to this specific server which we are trying to create now, this server doesn't have a public IP. That means from here to here I need to do the MSTSC, and then this is in a different subnet, so this is no public IP, so local private IP I will be using, and then remaining options are quite similar and default. I'm not much changing anything here because this demo is specific to firewall specific. And once this is done, we have now a subnet, which is 3 subnets which are associated with your firewall or with a single Vnet, and then 2 virtual machines. Then next step would be deploying the firewall. So let's submit this completely, creating this VM. Once this VM is created, I will be creating a firewall. So I'll just go back to dashboard and search here as the firewall. So I get as the firewall and click on add to create a firewall, and it's basic. All I have to do is I have to choose here the resource group, write Vnet. So the name I'm just giving here, oops, just a Vnet, and the same region I'm choosing here. Now the important point is, instead of you creating new subnet or new Vnet, what I'm trying to do is, since I have already existing my machines as well as my Vnet, I will be using this method as the use existing. And this is where I've been trying to explain here. When you choose here this option, it says that it must be matching with specific to a Vnet name called Azure Firewall Subnet. So make sure that if you don't give in the first Vnet when you're trying to create, instead of the default, you should give there as the Azure Firewall Subnet. If you don't give that exact name, you get it here as the error. That's the practically thing. And also, definitely I can't use the existing public IP because my firewall itself will have a dedicated public IP. So all I have to do is I have to create a new public IP by clicking on add new, and this is where I can give some name like Azure Public IP Firewall, something like that, and it must be a standard and static. So the IP must be static and also it should be standard, and in fact those are by default. So click OK, and that's it. Review and create. That's going to create for you a firewall. This would take post to the review and click on create. It takes at least 5 to 10 minutes time, so make sure that you have selected the right Vnet and a public IP, definitely, and then click on create. That's it. It's very basic steps to create the firewall, but next step would be the configuring the firewall settings. So I'll just wait until this to be deployed. So it got deployed now. I've waited for 10 to 15 minutes time to complete this entire step. As a next step, I'll just go to my resource group so that I can show you, what are the resources I have inside that my resource group. So my resource is test-firewall resource group. You see here I have different resources, 2 servers, 1 firewall. Let me sort on a name, maybe that might help you, or the type maybe, like you see here 1 firewall public IP and also 2 NSGs and 2 VMs and 1 firewall here. So I'll just go to my firewall, or sorry, I need to create here now route table. So I'll just go to the routing. That's where I need to create a route table. So just click on that, create a new route by clicking on adding. So here what happens is you need to choose a right resource group and the location, and post to that you need to add a static route. So I'll just choose my name and other things. I'm just trying to fill the default values like firewall route and other things, and I'm not doing anything much here other than choosing the right location and right resource group and right subscription name. So this would actually takes a minute or so to create for me this route table. Once the route table is created, if I just do a refresh or page refresh, I will be getting here the firewall-route, which is we just created. Click on that, and now it's time for us to create a subnets to be associated. So let's go to the subnets and associate here and select the Vnet which you wanted to associate. In this case, test-firewall, and also the subnet. So here I'm going to associate the workloads static route. That's I'm going to do it. So that means the subnet is the workload which I'm associated. So with this static route, what I'm trying to do is from here, from the route, click on give some name, maybe like this is for the workload, so I can give here as the firewall specific default gateway kind of thing, and then suffix would be anything like 0.0.0/0. That means any communication you want to go out from your appliance. That's appliance is nothing but your firewall, So in that case, if it has to go, so the next hop should be your private IP address of your firewall. So if you don't know, just go to the firewall overview. You will see the firewall IP. From here, overview, you can check out here the firewall private IP. So take this IP address and give it there in the static. So let me switch back to the other tab which I'm running this wizard for the route table. I'll just give here. So what happens is I'm trying to route any information, that means any kind of communication with the virtual appliance for the hop IDs to my firewall. So any communication, it will route back to my firewall. So that's what I'm trying to do. Click OK. So now the route has been done successfully. Now it's time for appliance to be for the creating the firewall specific application rules. So let's go back to firewall here. So I can go to the resources and then I can click on from there, or I can search for the firewall, or I can pin it. So in my case, I'm just going back to firewall. So test-fwrg, which is my firewall. So from the rules, I need to create here two type of rules. I don't need to play with anything with the netting. So I don't play here anything. I'm going to create first as the application rule, and then I'm going to create the network rule collection. So let's jump into the application rule. So into the application rule, I wanted to allow maybe Google for this point of time. So I'll just give a name as the allow Google, and then I'll be creating FQDN base. So let me go back. So I'll just this is in a different tab. Let me go back to the rules. Again, application rule collection. I'm sorry for that, but add. So here I would be entering a name called app collection 1, and the rule priority is 200, and the action is I'm trying to do allow for my target FQDNs. So that means I know the exact URL name. So I want to allow, and the IP address here, if you see here, I just fill this allow as the Google, that's a rule name, and the source subnet is this. That means anything from my, if you remember, this subnet is your workload subnet, right? So from here, and then the protocols, I'm going to choose here HTTP and HTTPS, and the FQDN of your www.google.com or whatever the website. So I'll just enter those values here. And similarly, whatever the websites you want to whitelist, you can give it here, because whitelist is allowing action. The action what we are choosing here is the allow. If you're not allow, then you may be blocking a certain website. So let me type here completely google.com and click on add. That might take a minute or so to create your application rule. So once the application rule is created, I need to go for the network rule. So in the network rule, I can again create a specific DNS rule. So in the DNS, like I wanted to route the traffic from my public DNS servers. Instead of you route the from a different DNS service, I wanted my traffic to go from the a specific DNS service. So that's what I'm trying to do. So here I'm just entering the LO DNS, again rule priority 200. So here the IP address information, all that, the name and other things, I have to fill it. So service tags are just the optional, but LODNS protocols, I can choose here definitely the UDP protocol, because DNS is UDP. In this case 53 I wanted to give here, and the name I just wanted to put it as a static, that's a net-collection01. So I'm choosing the UDP protocol and the IP address here, and the source is from my workload source, that is 10.0.2.0/24, and the destination address is a specific DNS service. You can give here maybe Google DNS server or any of the DNS server which you are trying to use. So in my case, I'm just entering a different DNS server which I have here, and that DNS is a public IP DNS, which are the public DNS definitely, like 8.8 or 4.4.2 something like that. In this case, I'm entering my own DNS server by comma, so that primary and secondary DNS it is taking. And the destination port, definitely it's a DNS port is 53, so I give here as the 53. And next step, I can simply click on add. That would actually create the network rule also. That means now what we have here is we have already created the application rule to allow GoGo, and next DNS also we allowed. So these DNS is nowhere configured on your virtual machines. So the virtual machine, especially we are talking about the workload virtual machine. So I need to go to my srv-workload. That's a workload machine which I'm going to test. So on this machine, network called properties. So just the settings and networking, and then the network card. So from there, I need to give these DNS servers. So these are the DNS servers configuration I need to enter. So let me go to networking, and then you can choose your NIC card, which is in this case srv-work 883. So simply click on that network card, and once you have chosen the network card, you have the DNS server. So this is where you need to give the DNS. So in my case, I have the custom DNS servers, right? So these DNS servers we created and configured under our network rule, right? So I'm just assigning this. So when you apply anything additional custom DNS, it means you need a flash of your IP config along with your DNS. So we need you to restart your virtual machine. So I'm going to restart the virtual machine in the next step. So now its configuration is saved. I'll just go to the virtual machine called the same virtual machine, which is a workload. I'll simply restart this virtual machine, and I'll wait a second to restart my virtual machine. So it just got restarted now. And as a next step, I need to connect to the virtual machine. And if you see here, there's no public IP, and there's no public IP. And the IP address is 10.0.2. Series. So I need to just go to the jump server to connect. So I'll just go to the jump server overview and just trying to download the RDP file, so that I just hit to my jump server. From there, I just log in, and from there, I need to connect to my workload server. So I'll just click on this. So I just logged into this. So I'll just open MSTSC to log into my workload server. So MSTSC, and the IP address of my workload, which is 2.4. In this case, I can give my user ID and password for the authentication. Once it is authenticated, I can log in, and also I wanted to disable the enhanced security, internet enhanced security, so that I can browse without any additional pop-ups. So I'll just close this server manager, server admin. I'll just go to local server, and I'll just disable this so that I'll not get any additional prompts when I'm trying to browse, because it's a server operating system. And recommendation settings I'll choose, because this is the first time I'm opening my IE. So I'll just choose IE11, and I can simply open google.com, and this works without any problem. That's good. Now if I just go to Microsoft.com, maybe it doesn't work if I try to go for Microsoft.com. And if you just read it, let me zoom it maybe so that you can read in a better way. Like, it's actually blocked because it found as a deny action. That's a default action within your firewall. So it got priority wise application rule, otherwise everything getting denied. So it got denied by default. So that's good. So I can maybe give a try for Microsoft to allow. So this time again, I'm just editing the same application rule with same subnet. That's the workload subnet, and the protocol same, but target FQDN name is this time Microsoft.com. maybe whatever the website you wanted. So the traffic will route to your firewall, and firewall will send the whether based on the rule matching, it will allow or deny. So just updating this firewall rule might take a minute or so. So it got, no, it's not, it's saved, it's still saving. Yeah, it got successfully saved. I can go back to my site here and I can refresh simply. I don't need to reboot even. So it's opening the Microsoft site. Similarly, Google also works without any issue. And what if I try msn.com? So that would definitely blocked because that rule was not matching anywhere. So that's how this works. Similarly, Yahoo or any website you try to open, it doesn't work. I hope this entire lecture or demo will be useful for you on how to create, how to work with your firewall services to secure your network. Thank you for watching this. We'll catch you in the next lecture about specific to firewall specific settings. Hello and welcome back. In this short lecture, we're going to learn about Azure Bastion service, which is a very cool service which will manage or which will help you to manage your virtual machines to connect securely directly from your Azure portal. As a first step, let's understand what exactly this Azure Bastion service. So this service is completely newly introduced by Microsoft with a fully platform managed, that's a PaaS model which you can use inside your virtual network. Let's say this is your virtual network, and inside this you would be actually creating another subnet, a dedicated subnet for Azure Bastion subnet. Since it's a PaaS service, you would be using to connect directly from the Azure portal to Azure Bastion service over the 443 protocol, and then from here you can connect to your virtual machines. It could be a Linux or it could be your Windows machine, so you can directly connect within the single portal. So you don't need to again download the RDP or SSH file to connect it. So it makes easy seamless integration directly to the Azure portal, since it's a platform as a service model, and this only requires the HTML5 version of any of the browser. That's only requirement, and this can be eliminated. If you see here, you don't need to have a public IP if you want to communicate directly, and it will completely makes your life easy when it comes to managing RDP protocol to be enabled and disabled when you don't need. So you don't need to work on those NSG specific RDP or SSH specific rules, since completely Azure Bastion does not require you to connect from the external side. So you don't need to configure within your NSGs external ports like RDP or SSH specific thing, and it will protect against your port scans because these are never exposed, since these virtual machines will have the private IP address within your Vnet, and it will protect against zero-day exploits, and also it makes hardening in one place. Since it makes into one place, it's so easy for up to date or to make any kind of changes. So let's jump into the Azure portal and try to create how this can be created. I have a virtual machine which is in a not Europe location, and it also have already configured to respond over the public internet. So I'm going to disable that all later point. If you see here, the public IP is already configured so that I can connect from here directly downloading the RDP file. But that's not what we wanted. We wanted to work with the Bastion. So for that, what we do is we would actually create a specific subnet within the within this Vnet. So I'll just click on the Vnet, which is not EU Vnet app service, because this is for the app service. Before you begin to create a Bastion service, you need to know that only it is available in a specific regions, and this might change any point of time as Microsoft keep on doing the infrastructure changes on their data centers. So they would come up with the new features or new services that can be offered everywhere. So at this point of time, we are in North Europe, try to create the Bastion service. So this is already available, this service. So we should be good to create in this location. So within this location, North Europe, on my Vnet, I'll just go back to my subnet, and here I need to create a specific subnet with a perfect match of a specific name that should be Azure Bastion subnet. So I'll just click on here with the creating new subnet, and the subnet must be the same name. You cannot have your own name here. It must to be matched with Azure Bastion service. So this is very critical, because if you are trying to onboard platform as a service model for your Bastion, because that's comes into the platform as a service model, so it must have to follow certain standards so that their internal Microsoft scripts will work. So I'll just give here, and I'm gonna set it here either 27 or whatever the series, because it needs to be minimum as a 27 as the CIDR block should be there, and you can configure the way you want it, like other things. And most important point is you are not gonna configure for this as your Bastion service the user defined routes. That's not supported, and also network security groups also not supported. So we'll simply click on OK. So that would create a subnet. So what we have done is either you create a new Vnet, that Vnet should have this specific to the Azure Bastion subnet, or if you have already a virtual machine that has a Vnet already connected, you can introduce this Bastion service as we talked in the PowerPoint slides. All you have to do is you have to come here and create a new subnet called Azure Bastion subnet, and that must be minimum as a 27 subnet ID, and then you just go back to services. From here you can even search from the create a new service. Here you can just search for the Azure Bastion that would provision. Here you see, here you have the service. Just click on that and click on create, and choose the resource group that you have already created. So in my case, alpha demo, this is where my entire resources are available, and also instance name that I can give here, like I can say that maybe Azure Bastion for my web apps, this is app service, so app service Vnet specific. And remember that the region must be the same. Let's say you are trying to create Azure Bastion service in ECS, but your Vnet is in North Europe, it doesn't work. So it should be the same region. So in my case, I'm gonna select North Europe. That's where my all Vnet, including the new subnet which we created, Azure Bastion subnet, also provisioned in that region. And I can select now the required Vnet. So the Vnet we wanted to configure is not EU Vnet app services, and automatically it will detect that specific naming that we have given for the subnet. In this case, Azure Bastion subnet, and the name must be the same. That's what we discussed, and it should be at least the 27 or larger the subnet. And this subnet is, this is where it's gonna provision this Bastion service. So the Bastion service will be provisioned within this subnet, and from there that's, if I just go back to the next slide here, so this is where it's going to provision that specific subnet, and we created this specific subnet, and this is where we are introducing a new platform as a service model for Azure Bastion, and this will enable the communication for other VMs or other subnets that are part of this virtual network. So this is boundary is at the virtual network layer, and you can have multiple subnets. So multiple subnets can be configured to talk with Azure Bastion service. So let's go, and you can go back to the tags. Although this is recommended to give the tags, I'm just skipping for the time being here, and I'll create the service. So this might take another 4 to 5 minutes, and we will have the Bastion service will be provisioned here. So I'll just pause the video and I'll come back to you. Now the service is provisioned. I can simply go to the resources and have a look on the service. If you see here, the configuration is quite similar what we have configured, and it doesn't show you anything here. Like under the overview, it's just showing the public DNS information and the Vnet which we configured for this Bastion service. And apart from that, provision state is success, and there's nothing is configured here. So all we can do is now we should be able to go to the virtual machine which is in this North Europe region, and within this subnet, so whatever the machines are within this subnet can connect by using Azure Bastion app, Bastion service specific, and the name what we have given for the Bastion is Azure Bastion app servers for the Vnet. So I'll just go to home and click on my web app which is in North Europe for the VM01. So instead of connect this time, what we do is we will click on Bastion and make sure that you are going to prompt it here with a pop-up also. So we might have to clear out that pop-up, and I'll just enter my username and password. So what would happen is the entire RDP protocol, instead of it will go and come back here, it would actually connect with the HTTPS port. And you see here you got already a pop-up blocker preventing. So for the first time, if you can allow as always, that would make us easy for later point. So click on that. This time it uses the a public DNS which was configured here for the Bastion, and with that it will redirect automatically, and I'm able to connect to the virtual machine, you see here. And here the clipboard also you can configure here. So the virtual machine is connected here. Let's say I want to go to the machine and type host name and ipconfig, so it works. And in fact I didn't remove the public IP for the machine, so we can take it out now, that public IP for this machine. Let's say I do not want public IP now, because definitely this machine is now fully provisioned with the Azure Bastion service, so no need of having a public IP. However, you can configure even the RDP specific protocols to protect that machine from the Azure Bastion also. So you can allow by configuring your NSGs, and also on that machine you can also configure the RDP to be allowed, otherwise it doesn't work. I have stopped the virtual machine and then removed the public IP, that's a network interface card specific, and then also started the virtual machine. Now if I just go ahead and refresh here, I don't see here a public IP address for this machine. That means this will have only the private IP address where we can connect it. So definitely with the RDP protocol you cannot connect, because this will be redirecting with the public IP and you don't have the private IP. Whereas with the Bastion you can actually connect with the valid username and the password. So let's click on connect by giving the user ID and the password. This time it's going to connect also. So Azure Bastion service is really very cool and very useful in order to secure your entire virtual machines and resources, especially either it could be a Linux or it could be a Windows, it doesn't matter. All we want is that machine should be, the port should be open between here to here. That's it. Within this Vnet, if the port is opened, it can connect, because we are provisioned this Bastion service in a different subnet, and from here to here all the communication would be happening over the outside external port would be the 443, but from here to here it would be again the RDP protocol only will be used. What if you disable here the RDP protocol on your local machine, it doesn't connect because the port is needed. And also for your information, just wanted to show you something here, like say this is a test example. So this text can be copied to my physical machine. Also you can expect the commands will copy paste it, and also for my test machine, that's my physical machine, to the inside also it can be copy pasted, so both the directions copy paste will work. So that's a cool, and you're not losing anything from RDP feature wise. Let's have a look on the pricing also, how it's gonna cost for the pricing for the Azure Bastion service. The pricing is fully depends on the region wise. Let's say from the June 1 to June 2 how the transfer would happen, and based on that, and also the pricing per hour point or 19 cents also will be charged. On top of it, the bandwidth based transfer, which is a 5 GB is free for every month, and post to that it's going to charge for us. Let's say if I wanted to validate for the not Europe, so I'll just simply go for the not Europe, and it's gonna show you the same pricing, because it's almost everywhere same pricing, especially for the Bastion service. But let's see here, you see here the June 1 to June 2 5 GB, first 5 GB is free, and post to the 5 to 10 GB it's gonna cost as a 0.087 cents per GB. It's going to charge from the data which is transferring between the different zones. Before we conclude this video on Azure Bastion services, I just wanted to enforce that the Bastion service will enable you to communicate securely over the Azure portal. So the user will open the Azure portal, and he would open up a connection between Azure Bastion service that you provisioned, and from there it's gonna communicate with your virtual machines. That's how it's gonna work, and this is so secure. And the only disadvantage or advantage side would be both the sides. I can, you can say advantage or disadvantage, both the sides, but the user has to go from the Azure portal, so you cannot just open up RDP protocol from anywhere. So in other way, that's going to be secure your network and secure your resources. So that's how it's going to work. I hope this entire lecture is useful for you. Thank you for watching this. Please take a minute to rate the course. Hi there, welcome back. In this lecture, we're going to learn about DNS within Microsoft Azure Cloud. As you all know about the DNS is very critical service. So when it comes to the managing DNS within Azure Cloud Vault, you can fully utilize Microsoft Azure DNS, or you can also use the third-party DNS appliances like Infobox or Bluecoat or ThreatStop DNS specific one. All these could be appliances, or could be virtual machines, or the services that can be used as a third-party DNS specific things. And within this lecture or upcoming lecture, we're going to learn about Azure DNS, where we're going to define this Azure DNS as the private DNS, also the complete Azure DNS, that's a global DNS which comes from the Microsoft Azure Cloud, whereas the private DNS you can actually create on your own and manage all the required zone files and other things. So if you have a question that can I install DNS on my own on any of the VM, yes, you can do that. You can simply spin up a virtual machine and install the DNS service that works as your own private DNS. So it would be the similar to your on-premises DNS service. And coming back to the pricing for the DNS, Azure DNS, as you see here, if I just go back to the Azure DNS for the pricing, it would be per month basis. and the first 25 hosted DNS zones, it's going to charge for 50 cents per zone per month, and post to that it's going to be 10 cents per zone and per month again. And this is going to be almost similar for almost all the regions, close to the similar, but not much price differences if you look at for any of the Azure regions, since it's a global service from the Microsoft Azure portal. Let's try to understand about 4 different real-time scenarios and where and what kind of DNS servers or DNS zones or DNS configuration can be used. So let's take the first scenario. Let's say you have few of the virtual machines within the same Azure cloud, and they wanted to communicate with each other. Then the best recommended solution would be to use your Azure provided DNS. As you know that Azure also will provide the DNS where you do not have to create any of the A records or any records that would automatically created by Microsoft. You can simply use that, or you can create your Azure private zone and maintain your virtual machines and their A records or maybe C names or service names, all that into your private DNS zone. But try to use from the Azure provided DNS, and if that's really not gonna address any of the scenario, then move to Azure DNS for the private zones. So that tells about a virtual network, single virtual network. What if you have more than 2 different virtual networks and you want different resources to be communicated with each other from Vnet 1 to Vnet 2 resources? Then it's the best recommended method to go for use Azure DNS private zone, or maybe a customer managed DNS service also can be used, where he can come up and spin up a own DNS server, and that would be fully managed by him, or maybe her. That kind of configuration can be done. That's the recommendation. And now let's take the other real-time scenario. Let's say you have within your Azure cloud, few of the resources wants to communicate with your on-premises network, maybe virtual machines or maybe some of the application servers. Then go for customer managed DNS server, because we're talking about the on-premises. That means they do have their own DNS, they do have their own managed DNS servers, so it's better to go for customer managed DNS server. And the final scenario, let's take the consideration where you want to communicate from your on-premises computers to Azure cloud. In that situation, this is quite opposite to the third scenario, because in the third scenario we are actually trying to communicate from the cloud to on-premises, but here from on-premises to the cloud. In that situation, for this specific scenario, you can use the customer DNS service. Simply forward the queries to the Azure for the name resolution. So you may have to choose for the forward queries option to Azure name resolution. So these are the most common real-time scenarios that we will be applying based on this scenario, and we would be utilizing our DNS services within Microsoft Azure Cloud. I hope this is really useful for you. In the upcoming lectures, we are gonna talk about complete Azure DNS for creating public and private DNS, along with the zones and other configurations with the full of demos. Thank you. We'll catch you in the next lecture. Hi there. Welcome back. In this lecture, we're gonna learn about Azure Private DNS. Before we jump into private DNS, let's refresh what exactly DNS is. Azure DNS is a hosting service for DNS domains that provides a name resolution for using Microsoft Azure infrastructure. So in the backend, it will be purely Microsoft infrastructure. So you have a reliability and great performance that offers by Microsoft, and concerns for any of the security concerns would be taken care by applying Azure RBAC, and also you can monitor the activity logs, and you can also go for resource locking, all that other DNS specific configurations that you can easily do it along with the security that extra offers from Microsoft Azure portal. with the configurations of within Microsoft Azure, like you can go for alias record sets, and you can use the records to work with your Azure public IP addresses for Azure Traffic Manager profile, or maybe CDN endpoints. So you will be getting all the advantages if at all you have a single management console, right? So that's where the Azure DNS comes into the place, where you can manage your existing DNS also directly from the Azure portal. This makes the ease of use, and also you can integrate your applications that require automated DNS management, can easily integrate with the services like REST API, or maybe their own SDKs can be integrated, so it's easy. So just to conclude that for what exactly Azure DNS. So Azure DNS can host your domains in Azure portal or within the Azure infrastructure. You can manage your DNS records by using the Azure credentials. You no need to have additional credentials, so you can integrate your APIs, tools, and even the billing also makes easy. You will have the billing just like for other Azure services. And you cannot use Azure DNS to buy directly a domain name, so there is a different method, like you can go and buy app service, so app services for domain, and then use it here for your own domain name purpose. Or you can go and buy from a third-party domain name registers like GoDaddy or Namecheap somewhere, and you can use it. So now let's talk about Azure Private DNS. So Azure Private DNS provides a reliable and secure DNS service to manage and resolve your domain names within your virtual network without need to add any custom DNS solutions. So you don't need to depend on somebody's alternative DNS solutions. Instead of that, you can use existing Microsoft DNS service for private DNS zones creation, and you can use your own custom domain name rather than the Azure provide names available today. Let's say you have your own, you can use definitely your own zone. For example, for this mission, you can use for .contest.com, and this can be resolved within the your Vnet, so it doesn't go outside. So that's where we talk about the private Azure DNS zones, and you can link all these. So this is something called a link concept, which we are going to talk, and there is something called auto registration, which we are going to talk. So when we talk about the auto register, the DNS zones will have automated records. That's a record gets created automatically within the DNS, which we are gonna have a look on in the upcoming demo within this lecture. And also for the more important point here is the records that are contains a private DNS, what we refer here, are not gonna resolvable from internet. So it doesn't work over the internet because it's a private. You will have your own DNS zones which are a private. So let's jump into the portal and have a look on it, how to create, and later point we will jump into different scenarios and we will come back here how these scenarios will be useful in the real world. To create private DNS, all we have to do is go to the all resources and search for the DNS. You will see here one for the public DNS, other one would be the private DNS. So the public one is just the DNS zone. It means like you have a domain name. In my case, for example, PaddyMaddy.com. If that domain is registered, I would go here and do the changes. But whereas a private DNS, let's say you have different VMs, and that needs to be resolved within that virtual network or maybe cross virtual networks, or in that situation you are going to use the private DNS zone. So just click on the private DNS zone. I would click on setting up my DNS zone. So I have already a resource group code created, and I'll just choose that DNS demo, and here I can give here my private zone name. Let's say this is the zone, like private dot maybe PaddyMaddy.com. So this is going to be completely within the Vnet communication or the scenarios that we are going to talk here. If you see here all these scenarios which is gonna scope up. Let's see, this can be within the single Vnet or it can be cross Vnets, and this can be with your split with the horizon functionality, which we are gonna come up in a minute or so. But the private zone instance name needs to be created. So this is going to be your zone. So simply review it and give the tags. Tags are very important in terms of the billing, and enter the tag information and click on create. So this gets created. The next step is to associate your virtual networks with your private zone. So what we're going to do is, let me show you here. If I just go to the private.dns zone, and within this, if I just go to the virtual network linking, so I have to link up any of the virtual networks. So for this demo, I did not create any of the virtual networks because I just wanted to assign this complete virtual networks or for this demo. So I'm going to create a new virtual network. So I'll just go to my home and simply here virtual networks. So within this Vnet, click on add and then give your resource group name, and I'm going to choose my Vnet name as the DNS demo Vnet 1. And coming back to the IP configuration, so I just wanted to go for the default. I'm not fancy here to look at a great design, so I'll just use the existing or the default address space and the subnet space, because in the next step I'm going to create actual virtual machines based on those Vnets. So choose the tags. Tags are really important again, and click on create. So that's it. It's going to create the virtual network. Once the virtual network is created, we will be provisioning at least 2 virtual machines to demonstrate how the auto registration works, how to create the DNS records and all that. So I'll just go to the Vnet and I can actually provision. If you see here, it's the normal address space and the subnet. So what we can do is we can just simply go to the DNS, and that's again private DNS. So within this, I can go back to virtual network linking, and this time I can click add, and I can give it a name actually here, which is link name. So in my case, I have a lot of other Vnets, but out of that, for this Vnet which we have created for this demo purpose is the DNS demo Vnet 1 we just created, and I'll choose this. And as you take the enable auto registration, what happens is as soon as I provision any of the VM, it itself creates a DNS record for you with the private IP address. So you no need to worry about creating a record for each and every applications, or maybe each and every virtual machine in this case. So that's easy. So I'll just take this enable auto registration, and I'll give here maybe my Vnet for this as DNS a Vnet demo, and I'll simply click on OK. So that would actually associate the Vnet. In case you don't have a Vnet access within your Azure portal, let's say this happens actually in the production, like you don't have every access, so every resource access you will not have. In that situation, you simply have to select this and give the resource ID that was given by your Azure admin, and that would actually enables the linking. So I'm clicking on OK. So since I know it, so this would actually enables the backend linking. So why we are doing all this is just for the automated records to be created. If not, you will actually create your records directly from here. Let's say you have here, if you see here as your private DNS host.microsoft.com, and then you can create your records for your machine. Let's say you have a VM called VM01, and you would be giving as the VM01 and their private IP. Maybe if it is 10.10. Maybe 2 example, you would give that IP. Or if it is not a record, you would actually create here like CNAME or IP version 6 or MX, PTR, SRV, text. All type of records are available and you can create it. So if at all you wanted to create on your own, this is the place where you create it. So very similar that you have a DNS on your on premises, similar type of records can be created here. So let's go back to our virtual network and try to create 2 different virtual machines, and the linking is successfully created. Now we will go back and we'll create 2 virtual machines. So I'll just choose new virtual machine here. Let's click on new virtual machine. This is going to create a new VM and fill the required things like a resource group and the computer name, all that information. And along with the username and the password, and go for the disk which are default. And the networking, make sure that you take in the associated Vnet which we have associated with our private DNS zone. So in my case, the same Vnet which I have taken, and then click on next for any management and advanced tags, and review it finally and create it. That would actually create a VM. I'm going to repeat the same step for another VM also. So I submitted here for the creation. I'm going back to another virtual machine and trying to create similar steps to be followed and give the new VM. I'll quickly fill the required information for creating the virtual machine too. So I'll just take the Windows server and user ID and password, disks which are default, but make sure that in the networking the linked virtual network to be selected, because that's where it's gonna look for the auto registration and all other configurations. So I'm gonna review it and I'm gonna click on create. So that would actually create the required configuration. I'll just take this, review and create. I'll just submit it, create button. So it takes some time to create two virtual machines. Now the two virtual machines has been successfully created. I'll just go back to these two virtual machines and I'll just connect it. I'll be fast forwarding this entire video because I'm just trying to connect to this demo VM02 as well as the VM01, and later we would be configuring ICMP protocol to be enabled, and then if both can be pinging or not, that is the basic thing, because we just wanted to check all these basic things. That's it. We'll just configure ICMP protocol to be allow. So we're in the firewall. Just click on the advanced view and enable file and print or just the ICMP. That would allow the ping configuration. So I'll just ping to the other side machine. I've done the same thing and other machine also here. So if I just go ahead and ping here, so I'm actually getting here the response for these machines. So the ping is established. Let's go back to our Azure DNS actual demo where we wanted to test it. Click on the private DNS and select your DNS and go to the overview, and you should be able to see here by default the required records has been automatically created. This is just because we have already associated here the Vnet with the auto configuration. If at all I have not taken this checkbox, what I have to do is I have to create for all the virtual machines manually the A record. So that's how it's going to work. So let's say if I want to create some more records, all I can do is I can go ahead and create, let's say I'm talking about maybe a VM03. I can create here another IP address like 10.1. maybe whatever the series of the IP that have, I can give here. So this would actually resolve this VM03 to this IP. So that's how it's going to work. So I'll just click on OK. And if I just go back to my VM 03 as try to resolve, it should be able to ping to this machine because both have the same IP. Let's go back to the VM01. This is a VM01 and try to ping here. It should actually ping. Oops, that's wrong. So I'm able to ping to the VM03 to the same IP, which is actually, you can even look up NS lookup and you can put it here, your 10.1.0.5. so it should show here the record also. DNS demo VM02 is the actual computer name. So this is how you're going to work with the DNS for the private DNS. And also other important point here to note that we are actually talking about the complete DNS configuration on top of your virtual network. Let's say you have your Vnet and you wanted to configure additional DNS servers or your custom managed DNS servers. You can go ahead and configure here. By default, Azure is completely managed this. So this is the recommended or easiest way of doing. We talked about different scenarios where when to use what kind of Azure provider DNS or go for our custom DNS or private zones. All that we already talked in the recommendations. So make sure that you check out that lecture, and if at all you have some third-party DNS providers, you simply have to go ahead and configure their IP address so that that would actually take care of the appliance based configuration, would go and talk with that DNS service. Or if you hosted your own infrastructure as a service DNS by spinning up some of the VM, then you would give here your custom DNS server IP address so that the entire virtual machines will be completely communicated with this by using with this custom DNS server. That's how it's going to work. Let's say these two machines are connected. So these two will go ahead and use that custom DNS that you have configured here. If we go back to the scenarios that we have so far demonstrated within this lecture is very similar to this. Like instead of the network A, we have here a Vnet with two different VMs, and these Vnet also have auto registered. So what happens is these two virtual machines has been auto registered with a specific IP address. That's what we have done. So this scenario is typically for a single virtual network. What if you're looking for two different virtual networks? Let's say you have a virtual network 1 and 2. So in that situation also you can have here, if you see here for a few of them, different Vnet or within this Vnet whatever the different virtual machines you have here. So these are not actually manually created records. So if you are not enabled for your private zones the auto generate the record, so what would happen is it's gonna you have to create manually, and then the name resolution can happen. That's how it's gonna work. And other scenario is the split scenario, and this is where in this case where you wanted to realize your DNS to be behave like depends on where the client sits inside your Azure or outside of the internet for the same DNS zone. For example, you may have a private and public versions of your application that has different functionality or behavior, but you wanted to use them within your domain for both the versions. In this scenario, you can configure for the outside as a different and inside as a different, and that's how you're going to actually configure your split horizontal functionality. You can check out the link which is which I have associated within this lecture for the resource section, and that really helps you to understand more about the private DNS scenarios that can be useful for you. I hope this entire lectures are useful for you. Thank you for watching this. Please give me feedback on my course by writing a review. That really helps me. Thank you. Hi there, welcome to Azure Public DNS Zone configuration, where you can actually configure your public domain names. Let's say you bought a contoso.com and contoso.com specific records. Maybe all these days you might be maintaining with namecheap.com or maybe GoDaddy. So you can actually maintain all these records directly from the Microsoft Azure if you have the public Azure DNS. Let's say to create this, you can simply type as the DNS. This is where you get it. So we also talked about the private DNS in the previous lecture, and this time we are going to talk about DNS zone. So when you click on the DNS zone, you have the DNS zones, and just click on add button. That takes to the routine wizard where we can choose our resource group, and this is where we need to give the proper zone name, that's a domain name, what we have to give here. Let's say I have a masterloader.com is my domain, which is currently with a GoDaddy. What I can do is all these records I can actually create by pointing the name service back to my Azure DNS. So what I'm going to do is I can give simply here my masterloader.com. That's a domain which I bought it from GoDaddy, and then you fill the tags. Tags are very important in terms of the billing and easy to identify what resources costed, how much, all that. And let's review and create. And this is where it's gonna complete the public DNS creation. Now the creation is completed. Let's go to the DNS And what I can do is here I can create my own DNS records. If you see here, there are the default two records got already created. One for the NS servers, which talks about the name servers information, and SOA start of authority records on this. So as a next step, what I have to do is, if I wanted to map all the records directly to Azure, what I can do is I can simply change the name servers. Let's say I have here current my name servers as these, so I'll just take these name servers name, and I'll go back to my GoDaddy and simply change the name servers to point to my custom name servers. In this case, the Azure Global DNS server name server. So I can give here there's one name server, other name server is this. So simply just go back and paste the value. If you want one more, you can add it. Definitely, we do have here. Like this, we can paste all the name servers and click on save. That would actually save, and that takes some time to completely replicate back. And post to that, what happens is you will have the full control of your public domain name. In this case, it's a masterlori.com, and whatever the records, let's say you want to create child zone from here, or maybe another record. Let's say I want to create maybe here my mail servers specific, like mail, and then I can choose here my MX record or whatever the record I wanted. I can simply choose here like MX record, and I can point to MX server name and the domain name. Similarly, you can create even a record, or you can create C names. All that are possible just because now you have the full control of public DNS server, and this is where you actually create all the records. This is how it's going to work, and this is quite easy, and it's similar to what you have on your GoDaddy or Namecheap, or maybe on your public DNS that is managed by some other vendor, or maybe on your on-premises server, DNS server. So it's quite same, but it's just the single console, and you have all the flexibility where you can apply for ARM-based access. For applying the role-based access, you can apply even tags and get the billing information. You can apply logs, and all the possible options you have very similar to other Azure resources. I hope this entire lecture is useful for you. Thank you for watching this. Hi there, welcome back. In this lecture, we're going to learn about Microsoft Azure Network Watcher. A Network Watcher is a tool that will help you to monitor and diagnose and view even metrics, and on top of metrics you can even set some kind of alert so that you get that alert. So it's most useful for diagnosing any kind of network related problems, and you can read the logs, and you can set those logs for your entire virtual network. So virtual network specific any kind of troubleshooting that can be easily done from the Azure Network Watcher. And this Network Watcher is designed to monitor and repair any kind of network health, or any of the infrastructure as a service specific products, but not for it doesn't shoot for the PaaS or any of the web analytic specific. So it's purely dedicatedly works for infrastructure as a service products only, especially like virtual machines or virtual networks or application gateways or even load balancers. So any of these components, you have any issues, you can go ahead and check the traffic flow, all that from the Azure Virtual Network Watcher. With the help of Network Watcher, you can do the monitoring as we said earlier. Let's say you have a web server or a VM that is communicating with your database server, and you might be configured some kind of custom routes to your database server or between your web server to database, and that might causing some issues. If you want to find out that, you can go ahead and configure your monitoring. That would really help us to monitoring based on the FAQs, FQDN based, or maybe URN, that is a resource ID identifier based, or IP address based connections. All that can be done. Even you can go for the connection monitoring capability. So it just monitors the communication at the regular interval and informs you about the reachability and latency and network topology changes between your VM and any of your endpoints, as I said, like maybe from your web server to as an endpoint as your database server. So it just gives you alert, it gives you the monitoring capabilities complete. And if your endpoint becomes as unreachable or not able to connect, so it will help you the connection troubleshooting. It informs you the reason for any of the potential reasons, like maybe a DNS name resolution problem or CPU or memory or firewall within the operating system of that specific VM, or maybe hop types, like from this network to the next hop communication. Also you can check out even the custom route information and any of the security rules that you are configured from NSGs or maybe a subnet layer. So all that information you can check out directly from the uh, Azure Network Watcher, and you can diagnose the network traffic filter problems. You can do almost all kind of diagnostics specific to the network, as specific to routing problems, network filtering, traffic filtering, and also outbound connection for a specific VM. You can capture even the virtual machines, specific packets, and on top of it, you can, as I said, go for metrics and configure those metrics so that you get that CPU percentage and all that metrics. And also you can have the virtual network, a complete topology can be viewed, and even that can be even downloaded if you wanted. I think it's time for us to jump into the Azure portal to create Azure Network Watcher agents and the configuration part. If you see here, I have two virtual machines that are already running state, and these machines I need to install an agent which is becomes as an extension. Okay, that extension should be installed on top of these virtual machines. That's called Azure Network Watcher extension. So let's go to the virtual machine and go back to the extensions here within this blade and click on add new extension. And if you see here, there's no extensions currently, so click add, and if you just scroll down, there's something called Network Watcher agent for Windows. So all you have to do is simply create this. That's gonna install on that machine. So I'm gonna do this installation for the two virtual machines. So that has to be done. Once I submitted that, it's gonna add in a minute or so. And let me go back to other virtual machine also add. So currently I have done for the VM02. I'm going to install for VM01 also the similar steps I'm going to follow, like click on add and then add the Network Watcher agent for Windows and create and click OK. That would actually submit. So in a minute or so, in the two machines, it's going to install the agent. I also wanted to just to show you here about my networking. If you see here, my virtual network which I'm talking about is DNS demo Vnet 1 is the Vnet which we are talking about, where these two virtual machines exist. So I'm gonna configure this specific network watcher to associate with this specific subnet. That's where I'm gonna apply some kind of rules, and I'm gonna work on that. So let's go to the Azure and search for the network watcher. So you have this one, so just click on that. Now what we'll do is we will try to run with all these options that are available within the network watcher. So the first one is the overview, where it's going to talk about network watcher is enabled in what all the regions. You see here, if the status, if you look at here the status, it's partially enabled. That means not for all. So if I just expand a little bit, I can see for my subscription, for West US, it's not enabled. Let's say if I want to enable, all I have to do is I have to just click on these little three dots and enable network watcher. That would enable the configuration network watcher. And then if at all you have maybe any of the VNets which are located maybe in West US, so now they are able to monitor by using all these options, or you can go for network diagnostic tools, or you can use a metrics, and you can even integrate with your log analytics and other logs information. All that can be applied on top of your virtual networks or your VNets in other way. So this is what we talked. And now if I just go back to my virtual machine, and you see here the deployment, the agent also is successful. Before we jump into it, you see here if I just go to the overview of this virtual machine and see, this is in East US. So in this region, that's a network watcher. I'm just gonna search for East US. So East US is already enabled, so that means it's good that we are good to configure. If at all in your case you might have maybe like West India or South India, so you just have to have a look on this configuration and try to enable, so that this will be enabled for network watcher capabilities for your VNets. So that's the first step. And also we have the agents has been successfully installed. Let's say if agent is installed already, that's the extension. If I just click on extension, I should be able to see here as the Azure Network Watcher extension. All we have to do is, that's it, the extension is available and it is the provisional status is successful. So as a next step, what I'm going to do is I'm going to back to this Azure portal and I'll continue with other options. So starting with monitoring tab. Within this monitoring you have topology. As we talked, the topology is how your network VNet is connected with different virtual resources. Let's say you have a VM1, VM2 and some other applications also configure. If they are completely associated with your VNet, you can view it. So let's say this is my subscription and my resource ID, that's a resource group, is my DNS demo, and here I do have here one VNet. So I'll just click on that VNet and you see here, if I just scroll down a little bit, I can view a nice diagram about how this is there. Let's say this is my VNet. It's a default is my subnet actually. So within this subnet I have two different virtual network, that's a network cards. Okay, these are the two network cards. That means these network cards are associated definitely with your VM. So two VMs and the two NSGs and the two IP addresses also assigned for these network cards. So this is how you can view. So let's see, if I just go back to other resource, maybe I'll just show you one of my other production. Maybe if I just go here, I should be able to see here for different networks. So you see here, it's a big one where I have my link server and also my mail server and different network calls, different NSGs and the different my subnets. All that has been configured here. This is where it will be useful for you in terms of having a complete an idea about the topology. So we talked about the topology. Now let's go to the connection monitor. So connection monitor will help you to configure and track your connections, whether they are a reachable state and do you have any latency, and also network topology changes if anything is happened. In the overview section we talked about, let's say, one web server and the SQL server, and somebody has done some changes or introduced maybe new NSG for the SQL server. Maybe in that situation you might lose the connectivity, so that kind of things can be easily troubleshooted here. So let's do in other way. Let's say if I just wanted to monitor connection monitor, click on add and I can give here some name. I'm gonna give this name EndPoint. Let's have a look on it. So here the virtual machine which I'm going to talk, so in this case I wanted to talk about DNS demo VM01, and this is my VM which is my destination. I'm going to select in the below. So here in the destination I'm going to select the VM1. So VM2, I'm sorry, because we have selected as a VM1 as a top source. So from the source VM2, source destination VM is VM02. Now you want to monitor some kind of maybe a port. Let's say I want to monitor maybe 445 or maybe port 1433, there's a SQL server, or maybe port 443 Such ports can be easily monitored. Like I'm gonna monitor 3389 just for the testing purpose. And when you click on advanced settings, you also have the similar port configuration, anywhere from 1 to 65,000 plus ports can be given here. And the probing intervals, like default is a 60 seconds. It's gonna check whether this port is enabled or not. So once you are finished with this, you can give a meaningful name based on the settings that you have configured. So I'm going to give here my connection monitor for monitoring VM012, VM02, RGP port monitoring, and simply click on add. So that's going to add a connection monitor. That might take a minute or so, but you will have some kind of data whether this specific VMs have any issues between the communication. So you'll know that if something goes wrong, you can always fix it and it gets the alert for you. This is the best example drawing what we have done so far. Let's say you have here the sources and destination, and also you can do some kind of configuration also can be tested, which is currently into the preview mode. But when we see preview mode, it actually unified end-to-end connection monitoring, which can be done with the Azure Network Watcher. Anytime soon it can release as the general availability or GA, where you can go ahead and configure even for your on-premises network also, like end-to-end configuration for your networks. That can be done by creating and testing even the configuration part. But let's jump into the NPM, Network Performance Monitor, in short NPM we also call this. NPM is recently added within the Microsoft Azure, where this NPM or Network Performance Monitor can be straightforward, can be integrated with your log analytics services, so that you get the more information, more diagnostic information can be viewed, and it's you have the more capabilities what's happening with as a one product from the log analytics services. So you can click here, add NPM, and then configure your log analytics workspace, and then you would be getting all the log information directly forwarded to your log analytics services. So let's go back to the connection monitor. By this time it could have already done some kind of a pooling, and just click on that, and let's see if I just go down. I should be able to see here, because we configure for every 60 seconds as an interval. So far it has already completed 4-5 minutes, so we should be able to see some kind of information. Let's say here it's reachable, the status is reachable, and the agent also have a version information, because agent extension is compulsory, and without that you cannot monitor this. That's why we, as a first step, we install that extension so that we can actually monitor or create our connection monitors in the network watcher. If I go a little bit down, I can see here in a grid view what happened, the status, whether the status is proper or not. And if I just scroll left side, because I just zoomed this text so that you can view it. If I just on 100, it will be very smaller text for you. And you can see here the RTT shows in a milliseconds is 1 stands 1 millisecond, so that's good. That's best ping status. And if I just click on topology view, the view completely changes, and it will be a downloadable format very similar to what we have here. If I just click here, I'm just scrolling so that I can get in a zoom wise, like what's happening from here to here, the status is fine, and all that information I can get it. And if I just go up, grid back again, grid view will be available. So this is how it's gonna look for you. Now it's time for us to go to other network diagnostic tools to learn. So the first one is within the network diagnostic tool, which is very helpful in terms of the troubleshooting, because here what we are talking about earlier was just the monitoring, so whether it is available or not. But here you are gonna actually know that what's happening. Let's say IP flow. If you take IP flow as the one option, what happens is this will help you out what's happening, whether the specific security group or maybe NSG or maybe some protocols, whether they are allowed or denied. All that kind of traffic specific things can be flow, basically the IP flow completely we can check without logging to those virtual machines. Let's say I have selected here my subscription and I have a resource group called here DNS demo, and I have a virtual machine. I've just taken a random virtual machine, and let's say I wanted to know a port number, TCP port, with the direction as incoming, so that's the inbound. Let's say I want to know whether the port as 80 is allowed or not. Remote IP address, let's say my IP address, if I give here, let's say here my public IP, I've just taken my public IP and giving here on a remote port as 80. Let's see what happens. So definitely the inbound should be blocked because we are not enabling anything. And what is that rule which is either allowing or blocking? Also you can easily find out, because definitely NSG has not created any of them, and the rule which is talking about is deny all inbound. But if we look at the outbound, that's the outbound from this virtual machine to the port, maybe like 60,000 some port, or the outbound from the virtual machine. You are sitting on a virtual machine and you're trying to go out, so definitely it will be allowed. So let's say you are trying to use the one other remote IP address. Let's see what happens. So it should check and giving us the access because the outbound is completely allowed, and these are coming from the network security group based rules. So that this is actually coming directly from the network security group rules. So definitely the IP flow will be very helpful to understand what rule is getting blocked and what is causing the problem. Now the next topic is within this network diagnostic tools, or next hop, very similar to your trace, where you have your virtual machine here and you want to find out what's happening with the source and the destination between. If you find some kind of any hop point for your packet, you can easily find out. Let's say I have here my I'm just selecting here. If I just go to the next hop, I can select my subscription and my resource group. In this case it's a DNS demo, and my virtual machine and my network interface, and now my source IP is this, and I wanted to reach the destination, let's say Google IP or Google DNS. What happens? It's gonna actually give you the complete hop information. So the next hop here is the internet, which is coming which is coming from the system route, which is a default route of the route table which has created by Microsoft Azure Cloud. So you can easily find out. Similarly, if I just go to another configuration, let's say I want to reach maybe 4, what would happen? Let's see, it's just the 1 point between 4 and 5, and let's see. And here the next hop is it is actually using the type is the virtual network, because within the Vnet this 4 and 5 or exists, so it's again a system route. So you can use the next hop to find out how the traffic is actually going with the route commands. And coming back to the effective security rules, this is another one where it's going to talk about what rules are applying at the network security level or network security group level, and what specific inbound or outbound rules are effective. That's why it might be blocking that specific packet. So let's take that. Let's say I want to talk about DNS demo. I want to select one of the virtual machine, in this case maybe VM01, and it's going to actually show you the complete information of just increase the font here. So you see here it's the effective rules. You can easily find out what is the effective associated NSG in this case, and the interface network card, which is going out the traffic, and the inbound rules, or all these are the inbound rules that is applied. For example, RDP protocol is allowed within my NSG, Like here, it's allowing the NSG specific rule, which is coming from this specific NSG as the RDP protocol 3389 allow. And similarly for the outbound, everything is getting allowed. So this is effective for this virtual machine with the help of this network security group, and it is associated with this network card. And this is again for this specific virtual machine. This is how you're going to troubleshoot. And also you have an options at the you can directly even click on the NSG to get more information by going directly to there and configure the required roles if at all you want to allow or deny any specific things. So that's about the effective security rules. And now we can talk about the VPN troubleshooting. Let's say you have a VPN device you have already within your subscription, and you want to troubleshoot that, and all that specific information can be stored in a storage account for further level of troubleshooting. Let's say if I just go for my subscription and my resource group, I can select the VPN device. So in my case, I have one VPN device or VPN gateway device, and then I can select my storage account. In this case, I can just go for my data room diagnostic account, and I can click here a specific container. In this case, it should be a VPN, and simply click on create. That's going to create actually in the back end for a container, and that's where it's gonna choose the container specific information. So I'll just click select my container which I just created, and if I click on start troubleshooting, it's gonna run all the diagnostic in the back end, and it gives you more information about the VPN troubleshooting steps and what happened and the whatever the users, why the users are not able to connect. All that information you would be getting out. All that information will be on your storage account which you have selected. So in my case, in this case, it's unhealthy example here, and the specific information gets logged into the diagnostics. Say, let's say I want to go to my storage account which I have selected and go back to the blob container, and the VPN sets a container name, and you see here the number of times we run it. So it's going to come here, and this is the latest one. So I'll just take this, and this has been downloading. I'm trying to download as a zip file which is already run the diagnostic information, and that information I should be able to get here. Click here to download. So it's going to download, and later point I can check what's happening within this specific one, what's the errors, all that I can find here with some kind of text notepad. So CPU 0, current available memory is available, all that information is currently logged in. So there's some other way it's useful, in other way. The reason being this is unhealthy. I have already removed some of the configuration, so that's why it's actually showing unhealthy. And let's jump into the packet capture phase, where you're gonna look at capturing some kind of a packet between your source and destination of the networks. If you try to capture any of the packet, it's going to actually store into the storage account or in a file, or both the places can be captured the data. So as a first step, I can choose my subscription and my resources, and I can select my virtual machine here, and this could be a test capture example. And simply there should not be any space, so just give the test capture, and I'm going to store into the storage account. If so, I can select my storage account, in this case DNS specific one, and the minimum bytes per packet, and also the maximum byte per session you can configure. These are the default values. If you want to add additional, you can add it, and you can also go for further level of filtering from what IP address you wanted to, and what ports to be explicitly to be captured, the protocol specific packets, and remote IP address, remote port numbers, all that, and you can save, so that it's going to save that configuration, and you can view that packet data, captured data with your network packet captured data can be viewed from a different editor tools or the viewer tools, so that you can easily go for further level of troubleshooting. So let's go to the connection troubleshooting within the network diagnostic. It's going to talk about any of the source and destination. If it is not able to reach, it's going to actually check for communication purpose. Let's say I have here my subscription as this and my resource group as DNS demo and my virtual machine specific or application gateway specific. So in this case, the virtual machine is your one, and I want a resource group. Destination is again, I can choose DNS demo and this time virtual machine 2. So it's gonna actually check for the TCP IP ICMP protocol based, or you can specify the port IP, for example 443, or whatever the port, for example 1433. So this is another type of verification from your connection monitor, but it's gonna show you here the actual details. Let's say if I just click on check, it's gonna give the more information about the connection, whether the source to destination on that specific port, the connection is open or not, and it has validated. Now if you see here, it's unreachable because on these virtual machine VM02 firewall is open and it is not configured to allow the port as 1433, so that's why it stopped. Whereas if you just go with ICMP, it's gonna work. If I just run the check where we enable the ICMP protocol to be allowed, so this way you can come to know that instead of you log in there and do the troubleshoot from the VM to one source VM to the destination, you can actually do it directly from here, and you can troubleshoot and you know that you know what's happening and you can fix those errors. So let's jump into the metrics. So within the metrics, it's going to actually tell you about the metrics that are enabled in a different regions. And let's say if my region is here, like North Europe, or whether it is enabled or not, and the users quota also you can find out. Let's see, you have a limit of subscriptions. Per subscription, you have a few of the network watchers only can be enabled. Let's say packet capture sessions can be at 10,000, and network watcher can be per region. You cannot have more than that. So these are some of the limitations. You can check out the documentation on this specific limitations, not just the network watcher limitations. This page also talks about other limitations for within the Microsoft Azure subscription and services, limit quotas and other all that information. So in our case, since we enabled here ECUS, so it says that hey, you have one of one as already enabled, so you don't have any additional option for network watchers to be enabled in ECUS. But whereas you can go for other regions, let's say let's say South India, you didn't enable for network security group specific, so you have some limitations. That's what it's about, the quota for the metrics. And NSG network security group flow, how it's gonna work. This is all about NSG specific logs for the traffic flow of the English and egress IP traffic, which is flowed between your network security groups. That information will be logged here, and you can have the information also by checking it here, and you can enable the flow log so that it's gonna actually capture, and it will be available there. And also you can forward this entire traffic information to the log analytics services also. And for that, you can simply select your storage account where you want to store all these log flow, so that later point, maybe for the auditing purpose, or maybe for your regulatory purpose, or for the troubleshooting purpose, you can use the NSG flows. And diagnostic logs are very similar as any other logs, but these comes from your networking components like your network card or network security groups, where you have those resources, simply enable for that specific card any of the network diagnostic settings, and that would actually capture all the logs into the storage account. So these things we can talk even in the monitoring section also, but it's very simple. You just go and select the required network card or maybe NSG and click on add diagnostic and simply select what type of metrics you want to collect and where you want to send. You want to send for log analytics services, or maybe archiving to a storage account, and later point for regulatory purpose it can be used, or you can even stream to your event hub services. So these are the network watcher specific settings that are available. I hope this entire lecture is useful for you. Thank you for watching this. I'll try to catch you in the next lecture. Please give me a feedback on my course by writing a review. Thank you. Hi there. Welcome back to Azure Load Balancing lecture. And within this lecture, we're gonna learn about how it's gonna work at the layer 4 level for the load balancing, and also the key features of our Azure Load Balancer, and also the architecture of Azure Load Balancing services. So when we talk about the load balancing or load balancer, it actually refers evenly distributing load, that's incoming traffic, across a group of backend different resources. If you see here, this is the load balancer icon within Microsoft Azure portal, and what happens is if somebody is trying to access any website, let's see, there's a website called maybe contoso.com. so this contoso.com is hosted, so that contoso.com IP address is assigned to this load balancer, and these three backend machines, maybe think that these are the web tier, or maybe it might have another backend also, but at the end this one of the machine will respond to the user whoever opens the contoso.com. So for this there needs to be all the time validated these virtual machine's health status. Let's say if the virtual machine, the middle one, has some issues, there should be somebody has to tell that, hey, this machine is no more working fine, so you should dynamically change the traffic to send to only load balancer to the first machine and the last virtual machine. So this is called the health probe. So you have some vocabulary here that's called the health probe, which will continuously check on given port numbers about the health of that specific service. If it is not available, it tells to the load balancer not to send the traffic to those specific VMs or to those specific services. Let's also have a look on other configuration load balancer at the front end. Let's see, think that this could be your public load balancer. That means the public IP is associated, and it can outbound communication for your virtual machines and for your internal virtual machines, and these connections are accomplished by translating their IP address with the public IP address. So whenever it goes, it actually goes with this public IP which is assigned for this public load balancer. And similarly, you can also have an internal load balancer. When I say internal load balancer, this will have the internal IP address. So it's not going to be a private, it's not going to be a public, it's going to be a private IP address, and these will communicate with these business tier machines on a different port, and these ports are fully monitored with the health probe monitors. So when do you use, if you think about these scenarios, you can use the load balancer either internal case or for the external case. You can use any of these scenario based on the requirements, and also increase the availability by distributing different resources load across, not just for your Azure resources. You can also distribute this load to across different Azure regions and the zones. And also you can configure your outbound connectivity for your virtual machines, how it should go out. And also you can use the health probes that we talked about, which will monitor the load of the resources. And also you can employ port forwarding to access virtual machines within the Vnet for a specific public IP address and the port that you wanted to configure. And you can also configure Azure load balancer supports the IP version 6, so you can configure, and this entire thing will work at the layer 4 configuration. Let's also have a look on the pricing side. So this is the pricing for the load balancing pricing, where it's going to talk about the first 5 rules within the load balancer, which is going to cost per hour basis 0.025 cents, and the additional rules it's going to cost as a 0.01 per rule, and anything for the NAT rules it's a free, and the data processed will be charged again based on the 0.05 cents per GB base. That's all about just an overview about the Azure Load Balancer. Make sure that you check the resource section of this lecture so that you can read furthermore about Azure Load Balancer, and we will continue in the next lecture about the Azure Load Balancer as a demo. And thank you for watching this. Hello and welcome back. In this lecture, we're going to learn about Azure Load Balancing with demo. So this is going to be the second lecture on Azure Load Balancer, and this should be even the final lecture on Azure Load Balancer. So what we're going to do within this lab is we will be spinning up 2 virtual machines with a name called VM01 and 02, and we would install web server role on both the machines. So that's nothing but IIS role I will be installing on VM01 and 02. And what I'll do is I'll little bit do the changes for the home page, where if I browse on the VM01, I can able to see it is actually coming from VM01, and similar configuration I'm gonna do here. So once I browse here as a VM01, that's HTTP VM01, I will be able to see VM01, and similarly here VM02. And later point I will attach to the load balancer by configuring health probes and other all configuration. That being said, let's go to the Azure portal and see what we have so far. So within this Azure portal, within this configuration, you have a resource group called demo NLBS ASG, and within this resource group you have 2 virtual machines that are already created. It's just a plain virtual machines like VM01 and 02, and these 2 virtual machines are connected to a virtual network called Vnet. That's a Vnet. So if you can check out here the Vnet name, it will be visible as the demo NLBSG Vnet. And if I just log into this virtual machine, and I did already configure going back to the server roles and installing the web server role, and post to that what I've done is I have done a little bit changes to the www root file, which is this file. So I simply added a word called VM01, so that this is actually coming from VM01, that's a host name. And if I try to browse, since I already installed the web application or the web services, I can browse with the IP address also, like VM01 is coming up, and if I try to browse with the computer name, I'm also getting. And same thing what we have so far on VM02, we were able to browse since the web application is already installed, and we did a little bit changes to the file of IIS stat file. And what we're going to do is now we will be actually creating a network load balancer, and we will associate these 2 virtual machines as we have seen within this PPT or within this deck. Like we will be introducing load balancer, and then we attach these 2. So when I browse from outside, because this NLB will have a public IP, and when I try to browse, I should be able to get a request either from VM01 or VM02. And in case if VM01 gets down, I should be able to get a request from VM02. And if you look at the configuration, how to configure this is very critical in terms of configuring for choosing what type of SKU we need to choose. Let's see, I have a configuration here to look at about SQS. Like, let me open up that link and show you here, like if I just go back to the NLBs, I didn't even attach to the Azure overview lecture about these SKUs, about Azure load balancer SKU. If not, you can go back to load balancer /SKUs. And there's a comparison when you're trying to create, you would get as a basic load balancer as well as the standard load balancer. When you go with the standard load balancer, you get all the benefits that are available or that are coming up with the load balancer, and it is a little bit cost also, but you can test all the configuration and you can just go through these. Like this gives you the advantage of the zone redundant configurations can be configured, and also high availability ports can be tested. So all that specific things can be done, and you can go and configure the standard load balancer for this demo. So I'm going to do the standard load balancer. Later point you can check out SKUs specific comparison between basic and standard. So I'll just go back to Azure portal and type here load balancer, and I would get here load balancers, and I don't have anything, so I'm going to create here one, and I'll choose my resource group as demo NLB ASG, and I should be able to give here any of the name to just to identify this NLB. So this is for my web app example, so I'll just give as a web app NLB01, and this is an easy use, and I'm going to choose the public IP base. That means as you know, the two design scenarios that we talked, like if we go for this, if we assign the public IP for this specific load balancer, the people can access any of these virtual machines, web request. Since it's a port 80 we configured, can access anywhere from the internet. Whereas if you configure here internal only, that's a private IP address is assigned, that cannot be accessed outside. So that's where the key difference. So in our case, we are actually trying to use a scenario called the public IP based or public scenario. So I'm going to choose this. And as we discussed about SKUs, you can either choose the basic or standard. As we talked earlier, I'm going to choose the standard, and I'm going to give the public IP name. So this is the web app for NLB my pip. That's the public name address, and you can check out here giving the availability zone. So if I want, I can go for geo redundant, all that. So I can simply go for just the one availability zone which I wanted to configure, and I'm not gonna choose even the IP version 6 if at all. If I wanted, I can choose that too. And post to this, if I just go for tags and create, it's gonna create the NLB. So this takes very quickly it can create about the load balancer, because this is straightforward and we haven't assigned any of the VMs in the backend. As we talked, the deployment is successful. Let's go back to the load balancer and try to configure front end and health backbone, all that configurations. Let's say in your design, if you have multiple IP addresses assigned for your load balancer, you can actually configure from the front end IP configuration. This is where we gave the public IP, which is automatically got created and assigned here with the name of NLB pip or public IP. And if you want more IPs, you can also configure so that they can reach this specific NLB with a multiple different public IP addresses. So this all depends on what kind of configuration you're trying to create. So in the next configuration item is configuring your backend pools. So backend pools are nothing but here the web tier machines like VM01 and 02. And if you remember, we were actually connected to the public IP. So these IPs are, it's not going to show, because the way we want it is these must be having the private IP. So it shouldn't be exposed with the public IP. And so we will try to open up here, try to create a backend pool. It's not going to work actually. Let me show you that. Let's create here a backend pool for web app. So here I can choose my Vnet, in this case demo NLP specific Vnet, and you see here it says that there's no virtual machines found. This is just because even though these are in the East US and the standard public IP configuration, no public IP configuration for all IP addresses must be configured on the virtual network. So in our case, the public IPs are already configured. So what I'm going to do is I will be actually going back to the Azure portal in a new tab, and I'll remove that public IP because that's not really needed for my requirement also. So I'll just simply go back to my VM01 first and stop this virtual machine, and similarly I'm going to do the VM02 and stop it, and then later point I'll be simply delete the unassign the public IP that is currently assigned for this virtual machine. So both the virtual machines are in a stop state. So I'll just go to overview and the networking. From here, I'll just click on my public IP for my VM02 and simply click on deassociate. That's it. It's not going to assign, or it's not going to take the configuration of the public IP. And if I really don't need, even I can delete from here if I really want it. So once that's done, I'm just going back to the VM01 and I'll repeat the same thing from the networking. I'll click on public IP, that's the NIC public IP, and say deassociate. Now both VMs has been deassociated for the public IP. So I'll just go back here and I'll simply just come back here by changing something here maybe, or just go back here and click on add pool. This time it should actually show me something here. I'll just select my VM name, and if you see here, I am now getting a not the gray button. I can actually browse here, so I'll simply click on add, and this time I'm able to get the VM1 and VM2. So I'll just take these VM1 and VM2. So this will become as the backend pool. So I'll just give here as the web app service. This is a pool 1. That's it, and I simply click on add button. In case if you have already a virtual machine scale set, you can do that even so that it's the same kind of configuration that is available on your scale machines, and you can also configure the auto scaling, all that configuration along with the front end as the network load balancer. That would take care of a lot of load. So in our case, just the virtual machines, click on add. So that's going to validate and come back, and it will create the backend pool, and it's going to attach here in a minute or so. And that's about the backend pool. So after that, we're going to create the health probes. So it has just completed the deployment of these backend apps has been allocated, and I can actually start the virtual machines also in the backend, and I'll be doing that as these two virtual machines are currently in a stop state. I'll simply start those virtual machines. That way I can go ahead and start the virtual machine. It was a failed status because the page was not refreshed, so I'm just going to start the VM. So this has taken the start button, and I'll also do for the VM02. I'll start the virtual machine. This is going to start automatically. Now if I come back to my actual NLP configuration, now this is where the health probes to be configured. Let's create the health probe by clicking on add button and give a proper name. Let's say this is for the HTTP specific, so I'll just give as the HTTP probe, and this is not a TCP port, it's going to be HTTP protocol, and this is the path. Let's see if you have some of the files or folders that needs to be validated on a port 80, then you can give here you can give here maybe a folder or all that content, but in our case it's going to be the entire website root, and this is for the intervals of every 5 seconds it's going to check, and if it is reported as a 2 consequent failures, it treated as the unhealthy. So I'm just clicking on OK. That takes a minute or so to create this health probe. So what we have done so far is we created the front-end IPs. If really wanted, we can have multiple IPs, and the backend we configured 2 virtual machines that will connect to this front-end IP address. So these front-end pool, that the 2 VMs, will be validated on this specific health probe about HTTP protocol based on a port IT for the entire route, and if anything is reported as too consequent unhealthy status within the 5 seconds, it's going to report us back. That's how we have configured so far. So that being said, now we didn't configure it how the load balance will happen. So all we have done is where are our backend pools, that's the virtual machines, and where is our health probe to validate that 2 virtual machines health status. But we didn't configure anything balancing rules. So this is where you're going to configure the load balancing rules. So just click on add. This is going to be a proper rule which you need to configure. So I just gave here a name as the NLP rule 1, and this is going to be for IP version 4, and on a protocol TCP and the port IT, backend port also IT, that's a request, and this is the pool that we created as a backend and health probe, which is going to validate and port IT. Now this is very important, like session persistence, like let's see a user connected from internet, and he's trying to open the website and he's trying to do some kind of drafting or maybe some kind of customization within a VM01, because the session is handed over with the help of the load balancer to the user from VM01. Let's say if he's trying to again re-enter or redo some kind of changes, it will try to go and connect to VM01 only because he's already on top of VM01 and his current session is going on. So that's called the persistence. We can configure based on the client IP address or maybe client IP and the protocol also. So that's where it's going to tag up and it's going to check that configuration. This is also sometimes called as a sticky sessions, and you can configure that. And idle time for timeout for closing this connection for the end users, you can configure here. And TCP rest you can configure, and floating IP address. And regarding the floating IP is mostly used by your SQL Server for always on kind of options, and the rest of the things are just the normal. So I'm just clicking on OK. This is going to be creating a load balancing rule for us. Now it's time for us to look at what happens when we try to browse from the front-end IP address. So in this case 20.55.16.87, and simply open up a web page and click on opening this. So you see here we got the VM02 session is open automatically, and also why this is opened from the VM02 is we did even configure a port to open from the network security group also, which I didn't told you in the beginning of what we have done, but I just forgot. And you can also need to open the port from the network security group, because without opening the port it will not allow the inbound traffic to these virtual machines, because on top of this virtual machine you have NSG configured. Similar configuration we also have done for the VM02 as well as for the VM01. We did enabled the NSG configuration. Like if I just go back to the VM02 and the networking and select my NSG, in this case this is the NSG, and you can check out here the port is configured to allow port IT here as the allow traffic has been allowed. That's why I'm able to browse successfully here. And you see here if I just try to refresh, I'm always getting the VM02. What happens if I try to shut down or to stop my VM02? So I'm just going to stop this server, that's a VM02, and we try to browse this. What will happen? So it's going to check and simply it should fail and fall back to VM01, and the page is loaded as VM01 this time. That's how you can configure the entire NLP. But this important thing is the backend pool machines do not have RDP port enabled publicly. If in case if you are trying to connect, how you're going to configure that. So that's where as the NAT rules comes into the picture, where what you can do is you can actually configure the front-end IP with your load balancer, and you can go for a custom port where 3389 can be mapped to a custom port mapping, and that way you can actually log into your RDP port, and you can learn more about the NAT rules, which is useful for the network address translation. Similar configuration, let's say you are trying to reach from port 80, but in the backend is a different port, so you can do that custom port mapping with the help of NAT rules. So these topics we also talk in the network as a network firewall concepts also. That's where we also talk about the NAT rules. You can also check out the NAT rule configuration, which is provided within the documentation link. But in general, what you can do is you can actually give your port IT, and let's say, or maybe a 443 example, and that should be port map should to 3389. That's how you can configure, so that it actually goes from the 443, but at the end it's gonna hand it over to 3389. That's how you can configure, and you can do the RDP, but make sure that your NSGs also should allow 3389 port or 443 port specific requirements to be allowed. That concludes this entire lecture on network load balancer. I hope this entire lecture is useful for you. Thank you for watching this. We'll catch you in the next lecture. Hi there, welcome back. We are gonna learn within this lecture about application gateway. And the application gateway will work very similar to the traditional load balancer. And in fact, we had a lesson on load balancing lesson. If you have not yet completed that lesson, I encourage you to go and check out the Azure load balancing lecture. That really helps you, because some of those concepts are still applicable, or on top of it, it's going to work. There are a few of the differences between the Azure load balancer and application gateway, and we're going to talk on that within this lecture. As a first step, let's understand about application gateway. Azure application gateway is a web traffic load balancer which works on a layer 7, and it will enables you to manage your traffic for your web applications, whereas a traditional load balancer purely works for OSI layer 4 for TCP or maybe UDP port specific, like route traffic based on the source and IP address based on the ports and destination. It's gonna work. But whereas this is just for the applications, web applications, so that's a major difference. And application gateway can make routing decisions based on a traditional attribute of an HTTP request. Let's say an example, you have you're trying to browse the contoso.com, which has the URL, and if the URL is contoso.com/images, let's say this images are coming, then the request will route the traffic to a specific set of servers, in this case and known as the server specific pool. In this case, it's the image server pool. And for example, if you're trying to browse contoso.com/videos, so application gateway knows that the user is coming from a different URL altogether, so it will automatically send the traffic at the layer 7, because it understands that, and it will redirect to video server pool. So again, the pool is like, you can have multiple servers and you can combine as the one of the pool. So we're going to talk on that in a minute, but for now, you can understand that the request, whatever the request is coming, that can be understood by the application gateway, and it can simply forward to the right server pool, so that it can give the good experience for the end users. In other way, it's going to be fully routed the traffic to another pool, which is happening here either for the images or videos, and with the optimized experience for the end users. Now let's understand about the application gateway features. So coming back to the features, since the application gateway is a web traffic load balancer which will enable you to manage traffic to your web applications. So it has different components also, like you see here the application gateway specific front-end IP, which is going to be static IP, which will be interface for the your web application. And also you will have, very similar to the traditional load balancer, very similar, you also have the listeners, and also the routing specific settings will be there so that it's gonna route back. So let's talk about the features wise. These are the list of different features that are supported by application gateway. Let's say it can support the SSL TLS termination and auto scaling for, and also for the zone redundancy and static virtual IP as we talk, and also WAF or web application firewall, which will consist of different set of rules that can protect your entire application from different kind of attacks, like SQL injection attack or maybe cross-site scripting attacks. All that can be prevented with the help of your WAF specific configuration, and also ingress control for AKS for your Kubernetes services and URL based routing, and also the multiple site hosting. When we talk about the multiple site hosting, you can configure the routing based on a host name or a domain name for more than one application on the same application gateway, and which can allow you to configure more efficient technology for your deployments by adding up to 100 plus websites to one of the, at least one application that's a web application gateway. So each web application gateway easily can support 100 plus websites, and each website can be directed to its own backend pool. For example, in this case you have a backend pool as one, but if you have a multiple pools, it's gonna divert to multiple pools too. And also when it comes to the redirection, for example, if you're trying to browse on a HTTP and that protocol might not be secure, so you can say configure to automatically redirect to HTTPS protocol, so that all the communication ensures that it's going to be secured. In that way you can configure, and that's one of the option for the redirection. And also the session affinity, when it comes to the cookies based session affinity feature is really useful when the when you wanted to a user session to on the same server to maintain all the time, or until the user's activity goes off, you can still maintain that session affinity. So you can use the gateway based cookies. The application gateway can direct subsequent traffic from a user session to the same server for processing. So this is very important in cases where session state is saved locally on the server for a user session. Application gateway also supports WebSocket and HTTP by 2 traffic. This is a traditional port support for the port 80 and 443, that's HTTP and HTTPS based protocol. Also you can reuse the same TCP connection for multiple requests between your for the request for the responses, resulting in more efficient way of utilizing when it comes to the a protocol called WebSocket and HTTP by 2 traffic. So basically this will allow you go for a duplex communication between your servers and your client, along with the TCP port communication. So that's what you're going to use, and this will be very useful when you're going for the more interactive communication between the web servers and your clients, which can be used even bidirectional without need of polling as it required in HTTP based implementations. And also for the connection draining, when it comes to that, if let's say you are planning some kind of backend pools go for a service updates, so in that situation it's going to be very useful for using the connection draining. This will enable you via backend HTTP, and it can be applied to all of your backend pools during the rule creation. Once you enable the specific settings, the application gateway ensures all the deregistering of the instances of the backend pool, so you don't receive any new request while allowing existing requests, so that you can go for actual maintenance of your web application servers or the pool servers. So you don't need to worry about the connection draining. So, and when it comes to the custom error pages, let's see, with the help of application gateways, you can actually create your custom error pages instead of actually displaying the default error page of your HTTP or web application default errors. You can simply, go for and give a meaningful error message for your customers by showing some kind of branding or layout for your custom errors. So that would give more value in terms of the end users. When they are getting an error, they can easily identify, oh, this is what some kind of maintenance or some other thing can be added for your front end. And for the rewrite HTTP headers and the URLs, what you can do is with this, you can go for your client and server to pass the additional information with the request of the response. Let's say writing these things will give you, major 3 different advantages, like adding a security related header fields, like protection specific protocols like HSTS or X-XS protection. All that can be added for your packets or your HTTP headers, or you can remove even response header field that can revolve sensitive information. Even you can go for striping port information from X forwarder for headers. So this will give you the support for the capability to add and remove or update your HTTP request and response headers while the request and the response of your packets move between the client and the backend ports. So you can also rewrite your URLs querying a string or query string parameters or host name with URL rewritable or URL path based routing. And you can choose to either routing request to one of the backend pool based on the original path. That's what we actually talked about, like images and the videos also in the previous slide. And coming back to the sizing, application gateway can be configured with the standard underscore V2 sizing. That would actually most of these features are fully supported in the standard underscore VT or V2. That's the size actually. So that's where you can go for the sizing and the scaling, or you can use the fixed size deployment. So what happens is when you go for this, it actually talks about the average backend response size. Let's say starting from the 6 KB to 100 KB, and either you can go for the bandwidth of 7.5 Mbps or 13 Mbps or 50 Mbps based on your small, medium, large size of your application gateways standard sizing. If you look at this diagram, it tells how the application gateway would work. Majorly different blocks which are involved. Let's say a user browses this application gateway. What happens is actually the user has to resolve that FQDN name to one of the IP address, and that IP address would be the front-end IP address of your application gateway. So that would be taken care by your Azure DNS or your other DNS servers, and then it actually gives the IP address to the client, and then the application gateway accepts the whatever the incoming traffic. But here it could be a suspicious activity, or it can be any kind of an activity, but it just accepts, and then it checks for the logical entry to check whether the connection request is really a valid, and it's gonna hand it over to what kind of front-end IP address or the protocols and the port numbers and the connections that are actually coming from the application gateway. And later point, it actually handovers to the listener. So this is where the listener will actually check in the back end whether that specific incoming traffic has a proper port and the rules are configured. And also, if at all you have configured your web application firewall, or in short we also called WAF, what happens is WAF will evaluate the rules whether the incoming request is valid, or it could be a suspicious activity also, or it could be a security threat. So in that situation, it will check and it will allow the action. If the rule is matched, it will send that to the backend pool. If the rules are not matching, it will simply either, if you are putting as a detection mode, so that's a type of mode where it will just only log it. But if you put it as the online mode, where it's going to actually block that prevention mode, we call it as a prevention mode, it's going to actually block that security threat, and that's how it's going to work. So these are the backend action, what would happen actually. So logically, user to application gateway, and from there it checks the listener has any of the configuration, and also your application firewall, that's a web application firewall, will evaluate the rules, and that would send, if the rules are matching, it will send back to the required backend pools. That's where it's gonna work. If no rules are matching, it will put it into the prevention mode, and it will simply stop the request further. And when we go back with these things, I just wanted to put it into the internal components that are actually involved, or the components that are required actually when we try to configure our application gateway. These are the components that are involved. So it's good to know that the first one is a front-end IP. That's your virtual IP or VIP for your application gateway. And also the listeners will work based on the ports. If you are worked with the traditional load balancer, you know that listener, this is quite similar. And ports, or the port is, that's where the listener listens for the client request, and you can configure any kind of ports ranging from 1 to 65,502, or maybe a 65,199 based on the version 2 SKU or version 1. And coming back to the listener types, there are two types. One is a basic and a multi-site. So basic is the typically it's just for the single domain site, whereas it has a single DNS mapping to one IP address of your application gateway. And this listener configuration is required when you host a single site behind your application gateway. Whereas a multi-site is you have more than one, or you can configure 100 and plus, as we talked in the introduction of this application gateway. And coming back to the request for routing rules, this is where the rules comes. Rules are a way to route back. Let's say for HTTP setting or custom probe or backend pool, that's where you're going to configure your rules. When we say the backend pools, it can be one of the requests which is coming from the backend servers. To solve the request, backend pools will contain some kind of components like network card, or maybe virtual machine scale sets, or your public IPs or internal IPs, or FQDN here, or multi-tenant backends such as your app services. All that can be configured here. And coming back to the health probe or custom probes, so health probes by default, an application gateway monitors the health of all the resources that are connected for your backend pool. And if it finds any kind of unhealthy of your backend pool resources, it will report back as the healthy or unhealthy based on the actual status. Thank you for listening all this introduction about application gateway, and we are gonna learn the application gateway demo in the upcoming lecture. And thank you once again. I hope you really enjoyed. I know that it's taken a lot of time for covering this entire topic, but it actually feeds your entire basics. Thank you. Hello and welcome back. In this lecture, we're going to learn about Azure Application Gateway demonstration. Application Gateway, which will be useful for the web traffic load balancer, that will definitely enable you to manage traffic on your web applications. So very similar to your traditional load balancer, but it works on layer 7. That's a major difference. So if you have not gone through the application gateway overview lecture, please go through that lecture and then come back to this lecture, where we are gonna learn within this lecture about configuration of the application gateway. So what we're gonna try to accomplish within this lecture is, we will have a pool called backend pool. So there are two different pools we will create. One is a default, other one would be the backend. So within the default, you have a normal application server, which is in this case, let's say VM01. And for backend pool, other one would be, I will name it as a video server pool example. So this will have the VM02. So this VM02 will have the video files. So as an end user, if I try to browse, this request goes to my application gateway. So application gateway, what it does is it actually checks if you as the end user try to browse as a contest.com example, it will simply there's no custom routing path defined, because it's just the straightforward your FQDN or your domain name. So it just simply goes to the VM01. Whereas if you just go like contest.com /videos, then it actually directs to, with the help of application gateway, to this VM02, which is a part of backend server pool. So that's what we're going to achieve this. So to create this entire scenario, I have to create few of the VMs, as we talked, like VM01 and VM02. Also, I need to configure my application gateway. So these are the things are involved, or these are the components or the required configurations to be done. So as a first step within this lab, I will create a resource group called application gateway demonstration group, and then I would create a virtual network called Azure Application Gateway Demo Vnet. This is what I'm going to create, and within this Vnet I'll have two subnets. One subnet for your backend pool, that's where you have the VM1, and also you have the VM2, and also one other dedicated subnet which should be at least minimum as the /27 subnet for your application gateway. So what would happen after creating the virtual machine is I need to create these two VMs. So I'm going to create two VMs, and also I'll do the NSG configuration to allow a port IT. That means I'm going to install on these two virtual machines web applications. That's the IIS I will be installing, and also I'll do a little bit of changes to the IIS, so that you know that the request coming from where. Like I'll just add into the paint with the VM01 and VM02, so that you know that this request is coming from VM1 or VM2. And also I'll do on a VM2 part of the VM videos within this IIS, so that if request as an end user, if you try to browse, it directly goes to VM02 with the help of application gateway. That's what we're going to try to do. So by explaining all these, or the high level explanation, let's jump into the actual demo, where we are going to create as a first step a resource group. So I'll just give a resource group name as the Azure Application Gateway -demo. That's what I'm going to create. So these are the components that I need to add, so that you know what I'm trying to do with. And you see here, that's the Azure Application Gateway as the resource group I'm going to create. So post to this, I'm going to create I'll just go to the home and create my Vnet. So I'll just click on Vnet and I'll click on add, and this is where I'm going to create in this application gateway demo. I'll put the Vnet name as the Azure Application Gateway -Vnet. So I'll just remove the demo and include Vnet. And in the ECS region, that's the same place, but here this is where I need to make sure that give the proper IP subnetting. So I'll just go for 21 subnet this time, 10.21/16 as my address space, and my subnet, this is where, as I said, two subnets to be created. The first one for the backend, other one for the application gateway. So this is the application gateway specific, so I'll just give as the application gateway subnet as /24. And now this is for my backend, so I'll just give as a backend specific naming, and then I'll give the specific subnet information, so that all my VMs will take the IP address of from this subnet. So when I'm creating my virtual machines, I'll make sure that I'll use this as the backend subnet name, and when I'm actually creating my application gateway, I'll use this as my application gateway subnet. That's what I'm going to do it. So make sure that you give the two subnets, and must be the application gateway one /27 minimum. So 24 I gave, and the remaining things are the same, pretty much same things. I'm not gonna configure much here, and I'll just review and create. So this would create a complete Vnet, just created. As a next step, I'm going to create my virtual machines, 2 virtual machines. As I said earlier, the one like a web hyphen VM01, which I'm going to create. So I'll just go to the virtual machine, click on add, and I'll choose my resource group here as application gateway demo, and I'll give the VM01 as the web hyphen VM01 maybe, and then is yours, and I'll choose as a Windows 2019 server, and the remaining settings are quite similar, and there's no much difference. So I'll just go ahead and give the user ID as Paddy and some password, and RDP is a default port. I'm just choosing my licensing part, and then the networking. This is very important. So I'm just actually choosing here the public IP so that I can connect and show you also. And for the subnet, this is very important. As we created Vnet, I'm going to actually choose for the backend one. This is the backend subnet which I'm going to choose, because /24 that's a 21.0.0, which I'm going to choose for my application gateway. So that being said, I'll choose as a backend service because I'm going to place this VM into the backend server pool, and remaining settings are pretty much same. And if you want, you can even go for auto shutdown, all that configuration if you want to save. But for this VM, I'm not going to choose anything. I click on create. That's going to create my virtual machine. So in a minute, I'm going to create one more VM called VM02. This has been just done. Now I'm going to create one more VM, very similar settings, but this time I'm going to choose web-VM02. That's only a name difference, and remaining things pretty much same, which I'm going to choose. And I'll choose here this time also 2019 instead of 2012. Oops, so 2019, and then gives the user ID and all of that. So I'll just give sizing Y. It is coming as red. Yeah. Again, Patty as the user ID and the password as the known password, which I normally use. And then licensing, if I really use this, if I have on premises, I can save the cost. And disks default, I'm not going to do anything, but as we talked in the networking, we have to choose the backend subnet, not the application gateway. So I'll just choose the backend subnet, and remaining settings are same. As I said, for the management, if you want auto shutdown, you can configure auto shutdown so that you can save the cost in your lab. That's pretty much same the configuration, and click on review and create. So that's going to create another virtual machine. So what happened is 2 virtual machines got created. However, we have not added any of the web applications, that's a web server on these virtual machines. So what I'm going to do is I'll just RDP. So I'll just download the RDP file, connect. So I'm going to connect to the VM02 this time. And then later point, I'm going to connect to VM1 also simultaneously. And then I'll install the web application. So let's go to the resource, and then I'll choose from here VM01 and try to connect RDP file, download the RDP file, try to connect, and once we connected, let me enter here the user ID and the password. And once the VM is connected, I can straightforward go ahead and from the server manager install add and remove features, and then web application. So these are the default things. I'll just open up server manager and click on add roles and feature wizard, click on next. So if you see here, this is a VM02, and I'll choose web server, which is IIS in this case. So click on next. That's going to install web application. That's a web server. So you have your web services will be running, so you would do the custom settings. I also remove the IE enhanced settings so that I can browse if I really wanted to check the status. So that's what I've done on this virtual machine. Now it's my time to go for VM01. So we have done on the VM02. Similar steps I'm going to do on VM01. So just go to the manage, add roles and features, wizard, and then if you see here VM01, and select the VM01 make sure, and just go down and choose a web server. So this is where the IIS service gets installed. So you have the backend, I mean, you can interact with the web services. So think that you are the developer, that's it. So what we are trying to do is just the development side. And also I'll just disable the IE enhanced security for this virtual machine also. So both of them has getting installed the required web services. In fact, Web02, that's the VM02 has been already installed. Now, as a next step, I wanted to do small changes like we did for the NLB or load balancer, what we have done. Similar thing I'm going to do here by opening the web root folder and IIS-stat. This is where I'm going to put as the VM02, so that in case if I try to browse from the external, I know that this request is coming from the VM02. And I'll just show you the host name also. If you see here, host name is VM02. That's web-vm02, so I'll just give as a VM02. And now this is the VM01. I'll just do the similar changes, but within the initpub, www-root, just go there, initpub and www-root, and edit that in a paint, maybe MS Paint, and just add the VM01. And click on save. That would save. And if I try to browse from internal, I should be getting as the VM01. But if I try to browse from the external, at this point of time, there was no network security group has been created, so I can't browse. So if you see here, this is a VM01. That's why we have added 01. Now, as a next step, we would actually create NSG rule. So that's what we're going to do. But before that, actually, I wanted to make sure that on a VM02, I wanted to create a folder called videos here. I'll give here as a videos, as I said, and then within this I wanted to give some kind of HTML page, like just not a fancy one because I'm not great HTML developer, but what I'll do is I'll just give this as a video section page or something like that, so that if I try to browse this test.html file, like console.com/videos/test.html example, so I should be able to get a view so similar to this. So I'll just paste this content, and if I just browse this, I'll get this kind of an HTML page. So I just paste it there, like it will show you as this page is completely from a video section page, and this is created by so and so person. Just not a fancy one, just wanted to show you a draft, very simple HTML file. And now once we have this, our content is ready on the VM1 and VM02, which is working as a web service. That's good. So later point when we create the application gateway, we will create two backend poles. But as part of the demo, while we are creating the application gateway, we would only create one backend pole. Later point, post to the application gateway configuration, we will create additional pools, so that you know how to do it later point also, not just from the wizard based. But for now, I wanted to configure the network security group to allow the configuration from outside to view. So what I'll do is I'll just take this IP address, and if I try to browse, I don't get it actually because NSG was not configured. So what I'll do is I'll just go to that VM02 networking, and then select my NSG, in this case web-VM02-NSG, and inbound security roles. Click on add, and add the port destination is 80. In this case, the name also I will stick to 80, and click on add. So now what happened is we created NSG rule to pass the port 80 traffic for VM02. Similar thing, I'm going to do it for the VM01 also, and later point I'll try to browse and show you. So I'll just go to the networking, NSG, and inbound security rules. Click on add. Simply I'll add the port 80 as an exception so that I can browse it. So let me open the browser and quickly and show you these two VMs IP address I have just copy pasted in my memory, and simply browse it. So I got the VM01 here, and I'll also try to do it from the another browser, maybe here VM02. So both are I'm able to browse it. That's good. So now we know that we have working virtual machine 1 and virtual machine 2. So it's time for us to do the actual application gateway configuration. to do that, what I'll do is I'll just search for the Microsoft Azure. In the search and under services, you can see here application gateway. So I'll just choose the application gateway by typing application gateway and then click on add. So this is where it's going to ask us to choose what kind of resource group you want to use. So definitely I wanted to use the same resource group which I have been using for this demo. That's called Azure Application Gateway Demo. And application gateway name, this is the name of your application gateway to identify. You might have more than one, right? So just to identify, so I'm gonna choose this as the app gateway multipath demo, and I'll stick to region as ECUs, and this is very important here by selecting the tides. So if you select the V2 and you got the auto scaling option, that's the tile specific one. And if you choose the standard, you don't get the auto scaling. If you just go to this link which is given within this tile specific one and go back to this section, that's a feature comparison between SKU for version 1 and version 2. You can see here, if you're just choosing the version 2, you are able to get the auto scaling option, zone redundancy. So you will be getting the static virtual IP for your application gateway, and also you can go for English control of your AKs, that's the Azure Kubernetes services, and also you can integrate with Azure Key Vault services, and you can rewrite the HTTPS header information. And also apart from this, you can just go through this table when you have a time, but you also get the other benefit of custom rules can be created with the help of Windows application firewall, or the web application firewall. Web application firewall, or WAF we call it. So WAF will give you the custom rules if you choose the standard 2. So I'll just choose the standard 2, and when I choose the standard 2, I can by default in the backend it actually configures, or it will give you the provision of configuring the WAF v2 configuration. In fact, once we created this web application specific this application gateway, once we created this, we will actually create the WAP firewall rules also, custom rules also, in a minute also. But for now, I'll choose the standard v2. And you see here you have the auto scaling, so I'll just give 1 or 2 here, the scale units, it doesn't matter for me. This is demo, so I'll just choose 1, maybe scaling up to 10. And you see here HTTP2 option, if you want to, you can choose that, and you have the zone redundancy like zone 1, zone 2, zone 3. So I'll choose here my zoning configuration also, and simply I'll choose the available zone configuration. If you just go through this, these are the available regions and zones, and if you just go through these articles, it gives you more information about the SLAs and the Azure region specific. Certain regions are become as a zone, so you have the full fledged replication, and you have the high availability. And HTTP2 is the other level of support. By default it is disabled. If you want, you can go ahead and enable this protocol. And this is very important. If you see here the virtual network which I need to choose, if at all I have not created earlier my virtual network, that's my Vnet, I should be able to do it from here also. In my case, I've already created, that's what we have done. So I'll just choose the Azure Application Gateway -Vnet. That's what we have done earlier. So I'll choose that, and you see here the subnets. So coming back to the subnets, you have the 2 subnets. If I just drill down here, I have the 2 subnets. Let me just go down. Oops, it's not showing properly. But if you see here application gateway, and if I just go a little bit scrolling down, you have the backend subnet also. So in my case, I must have to choose the application gateway subnet instead of the backend server subnet, because backend server subnet is dedicated for your backend pools. That's what we have designed as per the design configuration. So now I'll choose the application gateway subnet, and I'll go for the front end. So in the front end, okay, I'm still here the subnet, so I'll just go back here. I don't want to create, so I don't want to manage. If I just go ahead and manage, I'll get that options to create your own custom subnets if at all you have not done. So make sure that it should follow minimum as /27 and backend. So in the backend, if you see here, actually what happens is the key is here. The configuration is a key. So this configuration requires front-end configuration to be done as well as the back-end configuration. Then in the configuration you will have a rules. So within these rules you can say that if anything coming from the videos, you can say that hey, it should send the traffic to the back-end pools. That's how you're gonna configure. So we have not gone through these steps, so I treat this as a step 1 and step 2, and this is the step 3, which is a key, because step 3 is depends on your step 1 and step 2. So that being said, let's configure the front end. So what is a front end? Front end will be your application gateways, a front end IP address. That IP can be later point. You can register with your DNS services to a specific FQDN name, but in our case we are not going to do all that, but we would simply configure a public IP so we can browse with a public IP. As you see here, I also told that these are the key things which needs to be configured as part of the application gateway configuration, and we did even discuss this in the overview section. So the first one is front end. So in the front end, I'm going to choose a public IP. So since I have taken as the standard 2, that means it's going to be a permanent VIP, which is going to be. So I'll just click on add and create a VIP. That's a virtual IP. So I'll just give here as my public IP name, just the application gateway, maybe a VIP. Click OK. That's going to create the virtual IP. And coming back to the that's a front end, right? That's what we have done. Now front end is just done. Now the back end is needed. So what's the back end? Back end, you have your virtual servers, or the VMs will be there as a pool. Let's say you can have default pool. That's if anybody is browsing as a contoso.com, it just goes to the pool of default. And if somebody is browsing slash videos, that would goes to some other pool which is dedicated for the videos. That's how we can configure. So let's click on add pool. So I'm just configuring because I wanted to later point configure this entire setup once we have done the application gateway creation. So what I will be doing is here I'll just give as a temporary as the backend pool for videos. And later point we would discuss more further, because we didn't talk about the listeners and all that topic yet. So we're going to do all that configuration. So here, just for the namesake, I'm just entering here the required details. I'm not accurately giving. So here you have an option for the backend pools, like you can configure for your web applications like web services, and you can go for your VM scale sets and your virtual machines, and other public IP address or maybe IP address or FQDNs also can be given as a target for this backend pool. So in my case, it's a VMs actually. So I'm going to give here as the maybe just for the routing purpose, I'm going to give here default. And here the backend pool without targets. I don't want to go for fancy one now. I will come back later point and I'll do that configuration. So this is a very important one. So what we have done, front end we configured. This is what we have done as the public IP. And for the backends, this is what we have done here. So within this, we gave the default without any VMs. And now it's time for us to configure the routing path. So what happens is, this is where you will say that /videos or whatever that it will go. Or maybe for contoso.com, it goes to a specific backend pool. If contoso1.com or contoso2.com or contoso3.com, so these are the three different domain names, right? So in that case, it just points to a different backend pools. So that kind of configuration you can configure under routing rules. So I'm gonna do this routing. So as I said, I have done the front end and the backend pools, all that. Now it's time for us to do the routing rule. So click on the add routing rule, and this is where it will ask for the listener configuration and also backend targets. So here two important things like we are trying to do. One would be the listener specific and the backend targets. So it's time for us to do the rule name. So let's say if this rule is dedicated for multipath, so I'll just give that name and then the listener name and front-end IP address, which is my this is IP, right? What we have created as part of the front end, that's what we will be giving. And the protocol, if it is HTTP, HTTPS, if it is HTTPS, you need to upload your certificate, and the port based on that, actually HTTP or HTTPS port based on that, and listener type, it's a basic or multi-site. When I say multi-site, so the listener, this is very important, like listener says that if it is a contoso.com, it's going to be static. So simple, contoso.com is a single domain name. But what if you have maybe different domains altogether, like contoso.com 1, contoso.com 2.com, contoso3.com, contoso4.com, or maybe in other way, just to just for the example, xyz.com, abc.com, or maybe 123.com. So these are the three different domains. What if you wanted to map to different pools, in backend pools, then you would be choosing the multi-site actually. So in our case, we are not trying with a multi-site, but we are trying with only single one. So that's the configuration that needs to be done. So if I just without proceeding further, it will give the error. Okay, so I'll just give here as a default multi-path specific one, like videos path specific as a role name, and I'm just giving here listener name as a demo example, but it has to be actually HTTP. Later point we will change if really needed, and or we can just give here demo-http, and it's going to be basic. And if it is a HTTPS setting, so here the path which is backend, we are now into the backend targets. So within this backend targets, I need to choose my specific configuration, like HTTPS settings. This is HTTP settings without space, and then backend port is 80, and then cookie based affinity. So if we want a session based affinity, you can configure here under HTTPS settings, and also connection draining, you can configure all that here. So in our case, connection draining is not enabled, which will definitely help to a specific let's say within your backend pools, some of the servers are meant for the maintenance window, let's say for Windows updates or some kind of updates, then the traffic doesn't go to those machines. That's called a draining facility you have within Microsoft Azure for application gateway configuration, especially from the HTTPS settings. And the timeout 20 seconds override path. So this is the critical path which we are going to give. So here I will be giving here as the path / let's say videos kind of path can be given here. So that's what I can give here, the multiple path I can configure. Let's say backend pool for videos / star. So anything if you try to do videos / it will go for VM02 as a target name. So HTTPS setting, backend is the default. So we didn't configure proper backends here. Like as we talked in the beginning, we need to configure two things, one for the videos, other one for the default. So as of now it's just given as a default, but we can click on add and create from here, or we can do it later point also. So I'll be creating from the later point. So I'll just go ahead and do all these for now, just to show you for the creation part. Later point it would becomes easy for us. So let's click on tags, review, and create. So this is going to create application gateway. Once the application gateway is created, we will go ahead and configure the required settings for application gateway. Let's click on application gateway and go back to the configuration that we wanted to configure. So in this case, this is the application gateway. This is how it looks, very similar to your Azure load balancer specific configuration, but there are few things are different. So if you see here, the first thing, configuration, this is where you can do the auto scaling. You can go for auto scale from anywhere based on your configuration. That's what you can choose. So I'm not gonna configure anything here. And also on top of here, you can choose the WAF v2 or standard based configuration. And this is where the application firewall configurations can be done, which we are going to do in a minute or so, or maybe end of this lecture. For now, I'll just go back to HTTP settings and listener and the rules. That's what we wanted to focus. So the first thing is the listeners. So listeners, that's what we have created. If you remember, when we added demo HTTP for HTTP protocol, this is a front end. So and the associated rule is videos path. So if you can capture the listener is associated with some kind of a rule which is coming here, so video path. And also HTTPS settings, if I just go back here, within this you have an option for cookie, that's a session based affinity and connection draining. All that can be configured here, and you can override some kind of path also, or HTTP redirection. All that can be done here. So now I'll just go back to my backend pools and I'll create two pools. So earlier we created as a default for video purpose, but we didn't add any VMs. So what I'll do is, so I'll just rename this as the let's see, what is this is a default. So I'll just go for here and say this is for my virtual machine. So as we talked earlier, or in the introduction of this lecture also, or even the overview lecture, we talked about this can be configured, the paths can be configured for virtual machine scale set or web applications, or for VMs, or even for your IP address. So in this case I'm choosing virtual machine, and I'll get all the VMs that I have here. So I wanted this specific one, that's the default one, should go to VM01, and even the path also configured wrong, because my path should go to normal path. So the default path like contest.com, not for / video path. So I'll later point I'll change this. For now I'll just choose here VM01, that's a VM01, and I'll save. So that's going to save, and I'll create another one. This is for only videos. So here backend pool, add a backend pool without targets. No, I just want to add even add the backend pools, wanted to add even the path. So I'll just choose here as a VM02. So in this case VM02 was created now successfully. So it takes a minute or so. So now we created two backend pools, one for the default, other one for the route based. So it might take a minute. Now it has been just created, if you see here, and if it just its other one is installing the progress, just click on refresh, so I can see here. So under videos I can associate the specific configuration later point, but for now videos has been created. Now I'll just go to the rules. So instead of the video path, in the video path what we have associated is the backend as a default. So I'll just change this to backend targets. I'll just change this to VM2 is fine, that's fine. And instead of the target I'll just choose as a videos. So backend target is the pool which we have targeted videos, and the path also going to the videos. So what would happen is, if HTTPS listener is coming with on HTTPS, that's what this is what here we configured on a port 80. So if a request comes, it will forward to videos pool. Videos pool is nothing but VM02 in the pool, and that is also if the condition is / videos only. That's how we configured. So click on save. That would take a minute or so to configure this also. And now if I just go back to my backend pools, I can recheck the configuration of what we have done. The configuration has been saved. Let's go back to the backend pools. Earlier, if you remember, there was path was not there, but if I just go to the default, so now I should be able to see here just for the VM01, that's the 01. If you see here VM01, now backend target also 1, and if I just go to videos, this is for VM02, which is good. And also let's go to HTTP settings, and if the request is on a port IT, I'm not configuring here anything like session based affinity or connection draining options. I'm also not done any kind of host overriding options. the header information host override. And the front end, we talked about the public, and the private was not configured. So the front end is nothing but the IP address that was configured for your appliance. That's the application gateway appliance. So if somebody is try to reach here, let's say that goes to VM02, the reason being within this video path you have an option for backend target as a video. So videos pool is actually targeted. So instead of that, if you actually target to default, that's what we have done earlier. If you remember the backend pool, we created the default as well as the videos. The intention for the video should go only if it is coming as the videos / anything, right? So that's what we have done. So just click on the default, and if it is saved, and if I try to again browse within this the same IP address, if I just go and browse it, it should actually go to the VM1. So I'll just close in a private tab and I'll try to browse this. So I should get it as a VM01. So that's a cache earlier. So it's actually working fine, right? The VM2, it's going properly. Now it's time for us to actually browse. If you remember the path, what we have done is within this virtual machine, that's VM02, we talked about try to browse this path. So how we have done is within this VM, if you try to browse with the local host for VM02, like videos / HTML, that's a page which we created manually. So it should actually go to VM02 or VM02. So now currently it is going to the VM01. So what happens is with the multi-route path, if I just go here, it should actually go to VM02. The reason being it's not going is if I just go to the videos path and in the backend pools, inside your videos, the path was configured to backend pool as a default. We should configure this to actually videos so that it actually goes, because the path is the videos. So I'll just click on here and take this to backend server as the videos, because if you remember the backend, videos will point to that specific URL, and click on save. That would actually save the configuration. So this might take a minute or so for the configuration. Once the configuration is saved, the specific setting, I should be able to browse. Now the configuration is successfully saved and I'm able to browse. So this page is actually coming from VM02, not from the VM. So if I just go here, this will come from VM1. However, if I just put as my videos-test, it's actually coming from VM02. That's how it's going to work. So this is quite useful when you're trying for multiple sites or multiple domains with single application gateway to route with different route paths. You can use this, or a specific content should be coming from a different backend pools. This will be very useful in terms of configuring. Let's also talk about other configurations which is available within the application gateway. Let's say if you look at the web application firewall, this is where you can configure your WAF specific configuration. So like you can go for the standard V2 or you can upgrade to WAF v2. So when you configure WAF v2, you get all the advantages that comes from this rules actually. So you have different rules which are enabled. If you see here, if you configure that WAF v2, you have an options for example attacking on based on the PHP code or maybe SQL injection. If I just expand this, you get the advantage of automated prevention, automated finding or automated threat defense mechanism. Automatically you can get it with the help of WAF. Also you can create your custom rules also when you have this configuration from directly from the WAF. So here you can see here SQL injection, all that can be enabled, and simply you can save the configuration if at all you wanted to configure. That's WAF v2 specific and also standard. Also just the standard rules will be available. However, when you go for here, you need to choose the rule set and all that configuration. So in our case we don't have anything, but if we just go to WAF v2, I should be able to actually choose the default Microsoft given web specific configurations I can choose, and I can apply those specific configurations. Let's say if I don't want maybe SQL injection attack, common injection testing detection, I simply take it out, or if I want I can enable that. So these all are specific to the web application firewall rules. So because this application gateway works for the application web application, so it would definitely require you to configure so that you can secure your entire backend pools. And also if you just go back to the configuration, you have an options where you can actually put your firewall mode into detection or maybe in a prevention mode. So in our case, I'm actually putting into the prevention. That would actually applies all these rules. But if I put into the detection mode, it's going to just log all that whatever it is happening against to those rules. And apart from that, you can also put anywhere the value from request body size anywhere from 8 to 128 kilobytes. So I'll just give here as 8 for now, for 8 kilobytes. Also for the upload limit also you can configure here, so I'm just giving as 8. So this is about the web application firewall settings. So we talked in the beginning of this lecture for the demo purpose. We talked about the backend pools. We created default and videos. For the videos, the / video test, whatever this is coming, that will point to the videos. And the default, if anybody is browsing from here, just the main URL, so it's gonna go for the default path. And HTTP settings, we talked about it, and this is on a port 80, so you can have only one HTTP in this case setting, and that's on specific port 80. You cannot have one more on the same port for the same thing. And also for the front-end IP, we talked about the public IP, and also you can configure even for the private. When you're trying to create the application gateway, you have an option for the both, either public and private. In our case, we have chosen as a public. And listeners, we talked about the listeners where the path, how it has to go for on what port. So the port is IT. It should listen on a routing path which was associated as the videos path. And also for the rules, this is where we created a video path specific rule. Like by default it goes to the demo HTTP listener, but when it comes to the landing page of the normal page, it goes to the default pool as the backend. But if somebody is trying to browse for the videos, it will go to the backend pool for videos. That's how we have given. And rewrites we have not configured. If you want HTML header information to be rewrite, you can configure that. And the health probes, by default it creates. If you want to create custom health probes, you can create the custom health probes. And this is just the properties. And apart from this monitoring section, you have all alerts and metrics, very similar the way you have for other any Azure resources. Similar things you can configure here for the metrics and logs and diagnostic settings. And also backend health, you can check out whether your backend health pool is really healthy or not. You can find out from here. And you can also do the connection troubleshoot for your configuration if you have any issues. So in our case, the health of the backend is healthy, and if I stop any of these service, I will actually get here as the unhealthy. And the connection troubleshoot also, which will be useful for troubleshooting further on testing of your application gateway configuration settings. And this is where you will raise the ticket and other information for further support with Microsoft. So I hope this entire lecture is useful for you. Thank you for watching this. Please stay for next lecture, and we'll catch you in that lecture. Thank you. Hello and welcome back. In this short lecture, we're going to learn about Microsoft Azure Traffic Manager. Azure Traffic Manager is a DNS-based solution for load balancing your application, so it can distribute the traffic optimally to service the global Azure regions. and it can also provide high availability and responsiveness. So basically what happens is with the Azure Traffic Manager, it actually uses in the backend the DNS to direct the client request to the most appropriate service endpoint on a traffic routing method and the health of that endpoint. When we talk about the endpoint, it can be internet facing service hosted inside of your Azure or maybe outside of your Azure. Let's take an example to explain how Azure Traffic Manager works. Let's say you developed some application which works on a console.trafficmanager.net, and this specific URL is hosted in 3 different regions to serve from Azure, and you wanted to improve the availability and maximize the global performance. Then you use the traffic manager. For this, how we do technical steps would be, as a first step, what we do is we create the DNS records as a CNAME records with specific to the EU and US and Asia, because we try to deploy these 3 into 3 different regions. And then we create a profile with the name of console.trafficmanager.net. This is the high level, and we use the performance traffic routing method to across 3 different endpoints. And for the DNS side, we create actually CNAME records so that it actually works. So let's jump into a little bit further explanation step by step. So the first step would be the first end user try to browse the console.trafficmanager.net. So this is where it's actually involves the DNS service, right? Once he tried to open up, what happens is actually it will resolve back because the partners.console.com has a CNAME of console.trafficmanager.net. So what happens is it actually in the backend, it does that DNS name resolution and it gives the proper name. So at the first step, we can say that it's just a querying, and for the second step, it actually getting the records with the help of the DNS specific service. Within this, we use the recursive querying. So what happens is it will just find the console.com, it will just query to the DNS service for the console.com, and then it checks for the partners.console.com. And it actually returns the CNAME records here. At step 3, what happens is it will actually forward that request, that's the trafficmanager.net information to traffic manager. So what happens with the traffic manager is it actually sends the request for the console.trafficmanager.net as a DNS record to the DNS back here, and then it will resolve those specific records. And the traffic manager name services will request choose the endpoint base. So again, the endpoints could be your any of these, like it depends on the health checks, and also it depends on the routing methods that we defer or define. So we're going to talk in a minute. There are 2 different things. One would be the traffic manager endpoint monitoring, other one would be the routing method. So these are the 2 things which we're going to learn in a minute or so, which has a different set of configurations that can be configured within the Azure Traffic Manager when we try to configure as the endpoints, because the end user will have to reach any of these endpoints. So how we reach and how we monitor would depends on the traffic manager configuration. But this is just the high level flow what we are trying to discuss here, how this works. So traffic manager will reach any of this web. So it sends the back information, hey, you should actually go to this web app, and then it will actually request that information and it connects directly if really needed without the traffic manager or with the traffic manager based on the configuration that we configured. So that's how it's going to work, the Azure Traffic Manager. With the help of Microsoft Azure Traffic Manager, you have 2 different options. One would be the traffic routing method, we call it. Other one would be the endpoint monitoring options, and each of them will contain a different method. So if we look at the first one, would be the priority based routing. When we talk about the priority, we can have a our primary service endpoint for all the traffic, and also we can give the other priority for our backup in case of your primary or the backup endpoint service goes unavailable. Let's have a look on based on the priority traffic routing method, where you might wanted to have more than one failover of your application so that you can serve your application for your end users directly. So let's say you can give the primary one as a priority 1, so it try to reach all the time the primary one with the help of the traffic manager. But what if this goes failed, then it will you can give the failover A as a priority 2, and if this also goes down, then it goes to the failover 3. That's about the priority based traffic routing method. Similarly, we can also configure weight based. So you can select the weight based distributed traffic across a set of different endpoints, either evenly or according to your weights, so that you can define the traffic routes based on the weight. Let's have a scenario based on a weight traffic routing method. In the weighted traffic routing method, you can actually assign a weight for each of your endpoints. Let's say you have 3 endpoints here, backside of your traffic manager. So let's say region 1 and region 2, or maybe test A or maybe region B. So for each of them, you can assign some kind of weight anywhere from 1 to 1000 between. Let's see here, I gave as a 50-50. So it should actually go the weight for 50-50 for region A and B. But if it is degraded, you can go for the value for 50 is the highest, so it will just route back to 50 for the region B. And in case if this also gets degraded performance, then it can go to test A. So these things can be assigned. So it's actually very useful in terms of different scenarios. For example, gradual application upgrade, or maybe allocate some kind of performance for your traffic to route to a new endpoint, gradually increase the traffic over time to a specific endpoint to 100%. And also when you're trying to migrate your applications to Microsoft Azure, you can create a profile for both the Azure and external endpoints, and you can adjust the weight of your endpoints to prefer to the new endpoints. Another possible scenario would be if you're trying to migrate from on-premises, or you're trying to deploy on some of the endpoints in the cloud. So you can simply put behind your traffic manager profile here, and slowly you can add the capacity in the cloud by adding or enabling the endpoints, and specify a portion of traffic goes to each of the endpoints. That's where you can use these specific scenarios. And this is very useful in the common scenarios like development and testing, and also application to application communication, or application aimed at a narrow user base that share a common recursive DNS infrastructure. For example, employees of a company connecting through a proxy server. All that scenarios you can actually very well use this weight-based traffic routing method. And also the performance. So you can select the performance when you have an endpoint in a different geographical locations, and you wanted your end users to use the closest one, then this would be the best option. Let's have a scenario based discussion on the performance traffic routing method. With this method, you can actually deploy your endpoints in 2 or more different regions. If you see here, I have endpoint 1 in the West US, and also North Europe and East Asia. So I have at least more than 2 locations across the globe, and you can improve the responsiveness of many of the applications by routing traffic to the location that is very close for the end users. So that's where you're going to actually use. So that's nothing but the closest we call for the endpoint. But at the same time, it's not every time the closest one, because if you look at the performance traffic, because it's not the geographic which is upcoming one, so this is purely based on the performance. So it actually queries and it checks for the how the endpoint is responding within number of milliseconds, and based on that, it would actually forward the request to the closest with the fast response. So it's not all the time the closest, but it also checks for the best performance of your endpoint node, and based on that it would actually send the traffic. And also geographic location based, you can also direct the traffic to a specific endpoints based on the geographic location with the help of Azure, or maybe external, or maybe nested profiles based on which geographic location the DNS query originates from. So this empowers the traffic manager to the customers to load scenarios where knowing a customer's geographic region and routing them to the based on that what is important for them. For example, if you take it complying with the data sovereignty mandates, or localization or content and user experience for measuring the traffic from different regions, geographic option for the route-based traffic route-based method would be the right option. And also you have the multi-values. So total there are 6 different traffic methods. So we're talking about the multi-value now. Multi-value traffic manager profile that can also have the IP version 4 or 6 addresses as endpoint, and when you query to query for that specific received for this profile, all health endpoints are returned. When you select for the traffic routing method for the subnet based, the subnet traffic routing method to map a set of endpoint IP address ranges to a specific endpoint within a traffic manager profile. And when you request it is received, the endpoint routed will be to the one map to that request specific IP addresses. So all of these are the options that are included within your traffic manager profile for the monitoring of your endpoint health and automatic endpoint failover. And you can also look for the endpoint monitoring options. When we talk about that, the endpoint monitoring completely built in within the endpoint monitoring, and automatic endpoint failover can happen automatically, so you don't need to worry about that. And this feature helps you to deliver high availability of your applications that are resilient to endpoint failures, including Azure region failures. So we talked earlier about the Azure scale set, virtual machine scale set, and load balancing in a different lecture, but this Azure traffic manager is completely region failover. Also it can help you out because it's purely works based on the DNS traffic. And when we look at monitoring, you can specify the traffic manager profile based on a protocol. When we talk about the protocol, you can configure either HTTP, HTTPS, or TCP as a protocol that traffic manager uses when probing your endpoints to check its health. And HTTPS monitoring does not verify whether your TSL or SSL certificate is valid, so it only checks whether the certificate is present or not. And that's for the protocol. Now when we look at other options for the monitoring purpose, which would be a port based, so you can configure based on a port, and you can based on a path. So path is valid for HTTP or HTTPS protocols for specifying a path that is required. So providing the specific TCP IP monitoring results path specific, which will check for your HTTP HTTPS protocol, gives a relative path of the name of that specific web page or a file that always keeps on monitoring with the / valid entry. And also you have a custom header settings. This configuration setting helps you to add a specific HTTP headers to help check that the traffic manager sends to endpoints under profile. Also you have the expected status code ranges like maybe 200 or 299 or 300 or 301. All that kind of codes can be configure here so that you know that your endpoint is healthy. And also you can go for the probing interval, so you can give anything from normal probing or fast probing. So you can give either 30 seconds for the normal probing and 10 seconds for the fast probing. You can specify that information, and you can also configure the tolerated number of failures. So this value specifies how many failures a traffic manager probing agent tolerates before making that endpoint is unhealthy. So you can configure this specific setting so that if the range of maybe 0 to 9 between, if 0 means a single monitoring failure can cause that endpoint marked as unhealthy, and you can also configure the value as 3, which is a default value. And probe timeout also can be configured. This specifies the amount of the time that the traffic manager probing agent should wait before considering the check a failure. When an unhealthy check probe is sent, based on that, it actually reports the status as the monitoring option, whether it is healthy or unhealthy. And these are the options that we have within the Azure Traffic Manager. So basically, when we talk about the Traffic Manager, it uses the DNS based, and it is a multi-regional failure can happen, and it works based on the traffic routing methods of any of these 6 methods. Or you can also you can use the built-in endpoint monitoring options to automatic failure methods by using any of these methods, so that you are making your applications always available for your end users. Hello and welcome back. In this short lecture, we're going to learn about Azure Traffic Manager. To proceed further with the demo, I have already pre-configured a few of the things which I wanted to explain to you. So I have 3 virtual machines which are running from different regions. The first machine is EU-VM01 from North Europe, and second machine is from India, South India, and also from West US, 2 other virtual machine. And all of these 3 virtual machines also have configured to allow the port 80 for these machines from the network security group. So I did configure for Europe machine, also for India machine. I'll show you here. Port ID was allowed, and also for the US machine also. Apart from this, I have also done the configuration for public IP. I'll just show you. Before that, port ID is open for these 3 of them. And if I just go to the IP address of each of these public IP of these machines, I also configured a proper DNS name for each of these VMs, directly going to the virtual machines, public IP, and then configured the FQDN of the virtual machine. So this is what I have done. And also, if I just log into any of these virtual machines, or maybe if I try to browse, let's say I want to browse maybe this specific IP, I should be able to get the local IIS, because I did install the IIS on these machines, and also edited the home page with their local computer name. So let me show you here. For the US machine, I'm able to browse. Similarly for India machine, so these are the IPs which we try to browse. We are getting the response. Let's go to the Microsoft Azure and search for Traffic Manager profile, and let's create a profile. So click on add, that would take, and here I'm going to give here a specific name. Let's say PaddyMaddy.trafficmanager.net. And as we discussed earlier about the methods of the routing, so total 6 of them, which we talked in the beginning of the overview lecture, the same options we are getting for the traffic routing methods would be the priority, weighted, and performance, geographic, multi-value, and subnet specific. So let's go to the portal and choose for the time being. You can change these things later point also. So I'm gonna choose here maybe just for the performance based, and I can choose my subscription. I can choose my exact resource group. In this case, it's the Traffic Manager demo. And if you see here, the resource group is located in North Europe. So I'm going to create here. So these are the inputs that I need to give. So this is going to create the Traffic Manager profile. So what happens is, once we have this Traffic Manager profile, we can actually configure all the settings that we have discussed in the introduction or the overview lecture for the Traffic Manager profile. Traffic Manager profile has been created here. So I'm going to actually refresh. So I should be able to see here. So if I just go and browse here, my Traffic Manager profile, I should be able to see here the DNS name. If you're using already Microsoft Azure DNS or your own DNS services, you should actually create here a CNAME which would point your actual solution. Let's say you have a solution, maybe contest.com as your front-end page that you wanted to offer for your end users. That page will have a CNAME to point to this specific URL. So that's how the DNS change we do it, especially creating the CNAME record. Once we have done that, we are good to have configuration. So into the configuration side, since we have taken as the routing method here the performance, you see here you can change any point of time here. So we have taken that performance as the DNS specific, protocol IT, and the path, all that. You can go for the probing intervals that we talked, and tolerate number of failures, and the probed timeout period, all that. And post to this, you can actually configure in the backend about the endpoints. So this is where you're going to actually point your endpoints. Let's say I can add here, and I can choose my public IP address of that endpoints. Let's say I can choose here my IPs of any of these three VMs. Let's say I can go for VM01, and if you have any of the custom headers you can give. So I'm gonna just give here as the EU as the name which I'm gonna give EU VM. This is, and also I'm gonna add one more public IP specific here. This should be again India specific, so IND. And also I can add here one more as the public IP. In this case it's the US VM2. In case if you're not getting actually the VM IPs, even though you configured, it could be actually problem with your naming of the specific DNS name should be created, otherwise you don't get it. So in our case we have already created, that's why we are getting, so I'm just giving US VM. So I'll just simply add. So now we have three different endpoints has been added. So what would happen is if I try to browse the specific URL, I should be able to get the request from anywhere. So I am getting actually from India because this machine is located in India. So the performance is faster when we connect from India because that's the nearest one, and I'm able to browse the specific India specific virtual machine. I did switch back to a machine which is located in US and try to browse the same URL I'm getting from US. Since this is coming from United States, I'm actually getting the response from the US server. So that's good. You can also switch from the configuration side instead of the performance, maybe await based, or even from the geographic specific or multi-value or subnet based or priority based. So if I just choose a priority and click on save, the configuration for the endpoints also gets changed actually in the backend. So you see here you have the priority has been already assigned. So what happens is now if I try to browse, the priority 1 would come and push to the 2 and 3. So these are the priority based. If I try to browse from the India again one more time, this time I'm getting EU because the priority is set as the VM from the Europe. So if I just change this value to maybe something else, like delete and re-add for a different priority, that would actually comes as a different. So this is how you can configure your configuration with respect to the routing methods. So you have total 6 different methods that can be configured here, anywhere from the performance or weight based or priority or multi-value or subnet based, and then based on the configuration here you save, actually it's going to change in the backend for the endpoints also. And you can also enable the traffic view. By default it doesn't enable. You can configure this so that you know the latency information, all that by enabling the traffic view. This can be done. And also this other configuration, like if you look at monitoring specific, so these are the very similar for any of the Azure Blade. So similar options you have, like raising a support case or maybe alerts or metrics to see the performance, and also diagnostic settings, and also for the activity log, what kind of configurations we have done, and tagging, and any of the diagnosing and solving the problems. All that are by default configurations for any of the Azure blades. So similar configuration you have, but here the key point would be the configuration that you actually configure here, and also for the endpoints that's gonna add as the backend. So this is all about the traffic manager profiles. I hope this is useful for you. Thank you for watching this. Hi there, welcome back. In this lecture, we're going to learn about Azure Front Door. And before we learn anything about Azure Front Door, let's understand the foundation of the Anycast methodology, because Front Door works on Anycast methodology. So let's have a look on it. What exactly Anycast? Anycast is a routing and addressing methodology. So it just looks for the, as you know that for the routing, it's not just a single destination. It can have one or more of the routing paths, or maybe you may have two or more destinations. So routes will be decided by selecting the best path based on the latency and also the low cost of that specific route and distance and number of hops. So all these will be decided in the Anycast method, and it uses even the content delivery CDN network. We also call CDN, which is the edge of the service where it actually caches the information so that the end users will pull up that information from the closest CDN network, the information. So now let's understand about the front door. So we know that front door works on Anycast methodology. So it actually delivers based on the layer 7 capabilities for any kind of a global load balancing and the site accelerator services for your web application it's going to offer. Let's understand here site acceleration. So site acceleration, when I say, let's say a user coming from India wanted to visit a web page which is hosted in maybe California server location. So what he does is actually he uses the CDN network. So it just goes to Asia Pacific CDN, and post to that it will actually use Microsoft backbone network. Might be your application from coming from your on-premises or maybe from the cloud. It doesn't matter. What happens is it uses the Microsoft backbone network, so you have very low latency and faster site loading capabilities. That's where front door comes into the picture. If it is your on-premises web application, what happens is definitely that was not hosted in Microsoft Azure Cloud. So what happens is whatever the possible route is there till that point, it uses the Microsoft backbone network, and from there it will route with the ISPs. So still you get the that advantage of the front door, and the web application will be faster in terms of the loading. So in the normal days, what we used to do is we used to have a single web application. That web application, if you want a faster speed, we used to use the CDN network. There's a content delivery network. Now what happened with the Azure Front Door, it actually, apart from the CDN network, it also uses the Microsoft backbone network. So your site will get these faster loading capabilities for your end users. At the same time, the security is not at all compromised, because it's going to work on a layer 7 capabilities, which is offering you, for example, the SSL load or path-based routing. Let's see, we worked with the application gateway where videos should only go to a specific website. All that kind of functionalities can be used within the Azure Front Door. So it's a best solution in terms of using for the site acceleration services and the faster failover and also caching capabilities. All that are available with the help of Front Door, and it is also regional specific. You can go for the multi-regional failover also. So that's the major advantage with the Azure Front Door. And if you look at all other front door capabilities like global web application to get secure and fast delivery network, that's what we talked. And we talked about the gaining the speed of delivery content with a low latency. We also talked about it actually uses the layer 7 for HTTP or HTTPS layer. So it actually backend uses Anycast methodology. We know that what is Anycast methodology now. And it also provides a range of routing models and health monitoring options that are available and this is also securing option like session affinity and configuring SSL and application level security. You are rewriting header information can be rewrite, URL based routing, all that are possible with the Azure front door. Let's also have a look on the pricing. The pricing is purely based on your size of the Jones based bandwidth, because it's a front door. At the end, it's a bandwidth is a matter. Also the routing rules that are you're gonna use and per hour based. So that's the same thing like application gateway where we used even for the routing based. And also inbound data transfer will be charged. So all these, even the first 100 domains as a free, and after that it's going to charge. So these are the normal costs that are applicable for Azure front door. And also you can use the for the security purpose web application firewall WAF with the integration of the CDN. Then the rule based pricing will be applicable, which we learned with the web application firewall. So this is all about the pricing. Let's jump into demo and have a look on it how best we can configure. Before we jump into the demo, we have two web applications which are default, like you just go to the app services and create two web applications. And then once you create the two applications, I have chosen here two different locations, one from the central US and the other one east US. Why we need this is because there are three different steps that needs to be followed when we try to create front door. Let's try to create here front door. So front door, and then it actually asks for the three different steps that needs to be followed in terms of configuration side. If you see here, the front door domains and also the backend pools and the routing rules. So these three steps needed. So the first thing is the front door is nothing but your domain name, but that is the front door where you're actually opening with that URL. And then in the back end you have the waiting, all that configuration like priority and failover, all that can be configured, and also the routing rules can be configured according to that. So I'm going to use the two web applications that were created in the backend pool, but as a first step we are going to actually create the front ends, especially the domain name. So before doing anything, I'm just choosing here my resource group. I'm going back to the configuration. That's nothing but the three steps, and I'm just adding here so that it's actually open up a new blade where I need to give here a name. So I'm just giving here demo example. This name must be available, otherwise it doesn't work because it's a .azureft.net. So I'm just giving ft-demo paddy.azureft.net. So this name can be, again, you can configure your own DNS or Azure DNS to point to a right domain name. And if you see here, you can also configure when you're actually configuring the front-end host, like the session affinity and also web application firewall. That's nothing but a WAF also can be enabled here, and you can integrate that in terms of the security point. So I'm just choosing the default. Later point we can also configure these settings. So once we have configured the front door, now the backend pools are important here. So I'm going to choose here the two web applications that are available. So I'm just going to give here ft backend pool, and here I'm just choosing clicking on. So here you have multiple options. Let's say you have your own public IP or maybe your custom host, which is nothing but your on-premises network specific web application. You can use this, and also for the traffic manager you can use even public IP, API management, application gateways, and storage. These are the difference between the classic and the new. So for the cloud services, so in our case we are going to choose the app services. That's I'm treating as the backend. So if you see here the backend host name, we have the two of them. One would be the Central US, other one would be the Asia, so East Asia. So I'm just choosing the first one as the Central US, and here the ports of that web application, and the priority you can configure, and wait you can configure. So I'm just clicking add so that it's just added with the priority 1. That's the first one. It's going to open Central US, and I'm going to add one more, giving here as the Asia specific. So I'll just choose here web application as the app service, and then I'll just choose here Asia and click on add. So now I have the two of the web applications which are running as a backend. So I'll simply click on add, and if at all you're actually using anything route based, let's say if you have something or videos should only route back to somewhere else, you can also do that with the route based, and you can configure your sample size, all that configuration for the load balancing. And these are the probe specific methods where it's going to check within 30 seconds. So I'm just clicking on add. So that would actually configure my backend pool. Now it's time for me to configure the routing rules where for example I wanted all routes should only route back to specific videos or maybe in a specific website. So that where it should go, or maybe I can give here videos or something like that, so that what happens is it actually goes to that specific front end. So in our case we are actually configuring the default one, so I'll just give here as a rule name default route, which we are just giving here. And also you can actually choose here your backend pools, and also you can redirect the route type and the front end like HTTPS, HTTP, and also match request, and URL can be rewriting, and also you can enable here caching. Caching features also can be enabled, and dynamic compression so that you can save the cache size and all that. You can simply click on that. That's gonna actually gonna create a default route for us. So let's go to the tags. You can add the tags for the billing purpose, and then review and create. So deployment in progress. Now the deployment is completed, so let's go to the resource. Once the deployment is completed, you can actually go back to the front-end host and try to browse the specific URL. So it actually browses, and this specific URL or the web page is actually loading based on the designer configuration that we have done in the backend. So if I just go back to the settings and front-end designer and the backend polls, so here we have given the weight based on this weight. So if you see here, the priority for these two are the same. Let's say I have this specific web page might be coming from the Central US or maybe South Asia. How this is defined is if you give the same priority, what would happen is it actually goes and checks for the latency sensitivity in milliseconds, and Microsoft does that calculation for you, and based on that actually the load balancing would happen, and for the end user it gives the specific requirement. In my case, I'm actually browsing from Asia, so it might be coming from the Asia website. If at all you want to do some kind of a customization and know exactly from which web page it is coming, you can actually customize this specific web page to something else, and then you can easily identify the specific web page or web app. And in case if you wanted to modify this specific web page priority, say let's say I want to configure 2, so that's going to actually configure 2 and update and then save. So that's going to save the configuration for your complete front door specific URL configuration. So this is about the backend pools that we have discussed. And for the routing, you can actually enable and configure here the routing configuration. Let's say you want a specific route should take for only videos content to a specific web app. All that can be configured by here, which is very similar to your application gateway configuration, what we have done in the previous lectures. And also you can configure your cache also, and dynamic comparison, all that we have gone through while we are configuring this or configuring the wizard or for the front door. So similar configuration, you can rewrite or reconfigure the required settings here. I hope this lecture is useful for you. Thank you for watching this. Hi there and welcome back. In this short lecture, we're going to learn about Microsoft Azure Web Application Firewall. In short, we also called as WAF.
Basically, WAF will provide you a centralized protection for all of your web applications from the common exploits and vulnerabilities. And you can deploy this WAF basically on three different things. Either you can go for WAF can be configured for your application gateways and also for the Azure Frontier and Microsoft CDN network. That's nothing but content delivery network. And you would, get the normal benefits like cross-site scripting, Java tags. So it's going to protect you all of these kind of attacks like PHP injection or remote command execution, remote file inclusion, session fixation, SQL injection, or protocol attackers. All these are built-in protection. You can get it for your application gateway or for your front door or maybe for CDN networks. So what we'll do is we will go through each of these features with respect to WAF, how we can configure on Azure application gateway and front door, and also for the CDNs, and then the how it's gonna protect. All that we would be learning within this lecture and followed by a demo. When we try to configure web application firewalls for Azure application gateways, it basically works on core rules of 3.1 or 3.0 or 2.29 from the Open Web Application Security Project. So this is actually managed by like F5 and Cisco and other third-party community, which focuses on all the web application security, and they also comes into the security vulnerability finding and securing. This is an open project, so it basically either you can choose a core rule set or maybe you can use vote WASP or any of the configuration. You can choose it when you're trying to configure an application gateway. And you can see here if somebody is trying to do the SQL injection, like WAF can protect only, and it can only allow the valid request, and it will redirect to your backend web applications. So the advantages side, when we look at web application side for the protection, you get the complete protection for your web apps, for vulnerabilities and attacks without modification. Any kind of backend code can be integrated, and also you get you can create your custom web policies for attaching, and you can also go for the monitoring. When we say monitoring, you can actually integrate with log analytics or event hubs or maybe storage. You can actually log to the storage account. Coming back to the features, we talked about the SQL injection or cross-site scripting, protection against other common web attacks such as the command injection, HTTP request, smuggling, HTTP request splitting, remote file inclusion, protection against HTTP protocol violation. You also get the complete detection for the common application misconfiguration for your Apache or maybe IIS configuration, and also exclusion list lets you omit certain request attributes for WAF evaluations. A common example would be the Active Directory inserted tokens that are used for authentication of the password fields would be automatically excluded. So geo filtering traffic can be allow or block certain countries. All that kind of configuration also can be configured on top of your WAF. With respect to the demo for application gateways, I have already created application gateway, and I'll simply navigate to web application firewall. If at all you have not yet have configured your application gateways, you can check out a lecture on specific to the application gateways, and you can go through that, how to configure that. And this is a specific lecture on specific to web application firewall. So WAF. So with respect to the application gateway, you can actually come back here and configure the ties with WAF, and you can enable the required configurations. And also, if you look at the rules, as we talked within the lecture about the two different methods of rules, what we have here, one would be the cross, that's a CRS, that's a core rule set, as well as the Open Web Application Security Gateway. Any of these two rules or two sources can be used. So if you look at here, you have the option for OWASP, or maybe here you can use your Microsoft Bot Manager rules it also, which is again a newly added as the feature where it's gonna prevent any of the bot specific configurations also, which is quite new here. And you can choose any of them. So in our case, if we are choosing here maybe a 3.1 WAF, so this is completely based on the open source, and you can configure here the rules. So this is where actually all the rules will come into the picture, like as we talked about earlier. About if I just scroll a little bit side, you can, when I expand it here, you can see here SQL injection and the protocol detection or protocol enforcement, protocol attack, all different kind of methods that can be automatically configured here, and which would protect your web applications. So this is the one of the advantages that you have with the built-in rules. And if at all you want to customize, you can do the customization also. Coming back to the firewall mode, you can actually put it in the status as detection or prevention. So when you are actually detecting, you can just detect and you are actually logging, but prevention is the actual uh, enabling the status of your web application firewall, so that it's going to completely prevent all the actions that are coming up. And that's it. That's about the application gateway specific to the web application firewall. Let's go to WAF on Azure front door. So when it comes back to the front door, by using the WAF, when you enable on a front door, you are going to secure your web applications against of the common exploits and vulnerabilities. It also keeps your services highly available for your end users and helps you meet compliance requirements. So WAF on a front door is a global and centralized solution, and it's going to deploy at the Azure network edge locations also around the globe, so that before it actually enters the threads into your network, it's going to prevent. And the WAF enabled web application inspects every incoming request delivery to your front door at the network edge location. That's what here the key here. So it doesn't actually, it comes into your network at the edge location itself. You're gonna block it, all those common problems. So when I say common problems, it's going to prevent the malicious attacks close to the attack source before they actually enter into your virtual network. So you get the world-class protection for your web applications, especially from the common exploits and the vulnerabilities. You also get the global protection at the scale without sacrificing the performance. And again, when we try to configure here as your front door with respect to web application firewalls, you have the custom rules and you also have the managed rules. So when we see managed rules, like we have seen the common rules like SQL injection, cross-site scripting, protection or protection against your other common web attacks, all that are built in. And if at all you want to customly create your own rules, you can also do that with the custom rules. And again, with the front door also, you can enable detection mode or prevention mode, and you can monitor accordingly that. So let's jump into the quick demo to understand how to configure on a front door. We have created front door as part of front door demo. I'm just using the same thing here. And all I have to do is I'll just have to go to the web application firewall and check the configuration that was associated here. So if you look at the WAF, the core thing that Microsoft trying to do is to centralize everything so that they can actually do the configuration centrally for application gateways, front door, and CDN networks. So they are trying to do their best to make from this centralized place. So that's where web application comes into the web application firewall comes into the picture. So you need to actually create a WAF, that's web application firewall, within the Microsoft Azure portal, and then you need to associate this. So I'm going to search for the WAF in the marketplace, and I'm able to see the web application firewall. So if you see here, there's nothing has been created. So click on add or create web application firewall or WAF. So that's going to actually take to a new wizard where I need to choose my resource group. and choose a policy for. The policy is this time, if you see here, the policy we talked about in the introduction lecture. When you try to create even the WAF, it's going to ask you, hey, you want to configure for application gateway or front door or CDN. So in our case, we are going to choose, actually this is for the front door, so I'll just choose the front door. And within my subscription, my resource group, I'm going to give here a policy name. So this is just for front door demo or WAF policy example. I'll just remove the hyphen and policy states, so you're going to enable or you're going to disable. So you can configure later point if you want to enable the state. So I'm just going to enable, and coming back to the polling settings, I can use the detection of my URL and the response status code 4003, block response body, all that, prevention mode or detection mode. So I can configure here. Then you can also choose the managed roles. This is where the managed role set has been already predefined for you. You can configure the default roles, or you can even if you have a solution which is coming actually for your bot specific and you're trying to bot manager rule set, you can create that, or you can bot production specific, you can create, or you can actually use any of the default rule which is in a preview state. Also you can choose any of them based on your requirement basically. So what kind of protection you are looking, let's say you want some other rules that to be not to be blocked, or in that situation you can actually unblock them, or you can enable or disable that specific configuration. But it's recommended that you actually choose the default set which will protect a lot of other configuration, let's say SQL injection or session fixation attacks. All that are covered under default rule. If you want to, you can configure even custom rules which is in the next visit. So this is where the custom rules comes and it plays a key role. Let's say I want a specific country, specific geo or IP base to be blocked. Let's say North Korea specific request, whatever it is coming to your applications, you want to block it. So you can simply do that actually by configuring here. If this is the operation is a specific country, Afghanistan or maybe Costa Rica or whatever you want to allow, or you want to disallow, you can do all that conditions by configuring here, then deny or allow, or you can log it, or you can redirect by saying that, hey, this website or this web application is not meant for your region. You want to do that, you can do that with the redirection. You have all that flexibility to configure WAP policies from the custom rules. And coming back to the associations, you can actually associate with any of the front door host. Let's say in my case, I have already created a front door application, so you can actually choose that and you can associate that. So what would happen is, if I just go back to the front door, this specific policy, whatever we have created, will be available there. So then you can review it and create it. So it's going to actually create that specific policy. So validation is success, then it's going to create that policy. WAP has been created. Let's go to the resource and have a look on it. So you have the activity log, and you also have the and tags, that all the common, and the policy settings. You can configure and manage rules. You can actually enable a specific thing, or you want to disable that specific rule. You can do that here, like disable, enable, or you can configure your specific configuration from the custom rules and assign them for your associated front-end host. In our case, we have associated with the front door specific, and you can go back and check that. So if I just open my front door here, if I just do a quick refresh here, I should be able to see here that FTDemo WAF policy, and this policy contains, again, it's just taking back to that specific firewall policy here, and you see here the same thing which is opening up here, and you can do all the required customizations, custom rules, like we talked about the geographic match, then allow or deny. You can do the condition. It's very simple workflow that you can define with custom rules. So that's all about the front door specific configuration for WAF. Let's jump into other demo, which is a CDN specific. When it comes to the CDN network, you can also configure WAF on top of CDN networks to protect your web applications. Let's say this is the incoming request which is coming, and then it actually goes to your network edge locations, right? That's where the CDN we talk, and that's where you can actually configure your WAF with the CDN, and then you can go for your rules that are configured as a custom rules or the default rules. And you can also set your firewall into the detection mode or prevention mode, and you can also take the action like allow, block, or log, or redirect. These are the same things which we have capability to do it for other two um, configurations for the front door as well as the application gateway. And now let's jump into the quick demo to understand about this, how we can configure for the CDN network delivery for Azure Web Application Firewalls. This is a CDN which I have already created earlier for a different demo purpose. And if you just go back to the CDN profiles, there's nothing here to configure the WAF. So very similar what we have done for the front door. We need to actually create a WAF, and during the WAF creation, actually we need to choose what is the purpose of the WAF which we are creating. Let's see, this policy is for CDN. This way we have to choose as a CDN for Microsoft Azure instead of the earlier we did actually configure for the front door. Now it's time for us to configure for CDN specific, and then choose your resource group and give a policy name. So in my case, I'm going to give this as the CDN policy, and simply click on policy settings. And again, we know that when we try to configure front door, we did actually configure here the mode where we can choose the prevention or detection mode. So in our case, we actually configure again prevention here in this case also. And coming back to the rules, as we talked earlier also, you have multiple rules, but in our case we have only here for the CDN specific default rule set is only available, so you can choose that. And just go to the custom rules if you are trying to configure any of the custom policies to match those specific criteria, and then you can take an action according to that. So in our case, let's say custom rule match. So I'm gonna choose if any of the geolocation or IP address. In that situation, the operation is or is not, and then if the country is this, then you want to allow or deny action can be taken. This is a simple workflow. And also you can configure other custom rule for matching of the custom rule for the rate limits. So you can configure here a simple custom rate limit, like very similar to the configuration of the workflow, but this is purely works on the threshold of the maximum number of requests that are going to be allowed for a limited duration for a specific web application which is going to retrieve, or if it is actually coming from so and so specific geographical location or IP or size or string, all that can be configured. Header request information, based on that you can actually, whether you want allow or deny, can be configured. So this is again one more custom rule up on top of your existing rules. So custom rules comes into the play after your custom rule matches, only this would actually apply. And coming back to the association, you can actually associate with your CDN network. So in our case, we have already created one CDN, so I should be able to retrieve that CDN network. So that's a CDN profile which we created, and we can associate with that. So this is where you are actually associating. And then tags. So tags are very important for the billing purpose. You can add them and review it and create. Policy is created. We can simply go back to the resource, and here you can change the policy settings from prevention to detection the way you want it. And then the rules, the manage default rules, if you want to enable, disable, the action can be taken from here, which would associated from the CDN policy. And this is with the CDN endpoint, which you can configure. If you have multiple CDNs, you can even do configure here. And you can also create the custom rules based on the custom rule match and custom rule limit based on the limit of the thresholds. All that can be configured here. So altogether, this is very similar configuration of what we have done for the front door with respect to the WAF. Similar configuration, similar policies that can be applied here. So that's about the WAF specific. Let's have a small comparison between application gateway and the front door with respect to the WAF configuration. There's a lot of things that we are trying to do in a common when compared with the WAF policies on application gateway or front door, and these are quite similar. And firstly, when we are talking about protecting the solutions on application gateway or the front end door, we are actually talking about the network specific within different regions. So remember that the application gateway itself is protected in terms of region specific. So it's like a single region for high availability, which we talk about the application gateway. So the solution again WAF comes for the regions level, but when it actually comes for the front door, it's a global, because the front door is a global. It uses Microsoft Global Network, global CDNs, all that. So it's a global solution here. And in addition to that, in the application gateway, we actually protected the network, virtual network layer, but here it's going to be the before the traffic actually hits to the CDNs, it's going to protect the front door. And for the common comparison, you can actually get on the both the services, you get the Microsoft Azure managed rules, and your own custom managed rules can be configured in the application gateway specific or front door WAF specific. And also on top of it, it's going to work on a OVA-SP core rule set, all that protocols which are open source, open community, like managed by FI and Cisco, and a lot of different network security options provided by the support for the open web application security projects. So this is basically a non-profit foundation that looks for the security against common threats, vulnerabilities with respect to the WAF. WAF configuration policies can be taken from this OVA-SP specific foundation or rule sets. So that's all about the web application firewalls in Azure. I hope you really enjoy this lecture with demos. Thank you for watching this. Take your time to review the course and the feedback by writing a simple review. Thank you.
Hello there and welcome back. In this lecture, we're going to learn about Azure Resource Manager and what it is and their terminology and how best we can use it, and all that concepts we're going to learn within this lecture. So let's jump into this lecture by looking into the Azure Resource Manager. The first thing is what exactly this Azure Resource Manager. So this Resource Manager is a deployment and management service for Microsoft Azure. So it can provide you a management layer that will enable you to create, update, and delete whatever the resources or the services that you create within Microsoft Azure with your Azure account. So you can use management features like you can control access, or you can lock it. You can go for tagging so that the billing would be easy for you to understand what resources are actually tagged for what billing. And you can also secure and you can organize your resources after the deployment also. Since we have all these advantages with the ARM or Azure Resource Manager, we can also use Azure Resource Manager templates. So when I say template, in fact, we're going to learn these Azure Resource Manager templates or ARM templates in the upcoming lecture. And this lecture is dedicated for Azure Resource Manager, but by using the Azure Resource Manager templates, you can create the infrastructure as a code mechanism. So you will have a consistency within the Azure Resource Manager, because if you look at the design of this consistency, if you see, either you try to create any of the resources from a portal or PowerShell or CLI or even REST based client or SDK, whatever you're trying to communicate, it actually goes and communicate with Azure Resource Manager, which is the interface, and this goes and communicate. I mean basically here it happens the authentication, and later point it actually hand over to the required resources. Let's say you're trying to do some configuration on web app. So what happens is this request goes to Resource Manager, and Resource Manager will go and handle this authentication information to web app. And similarly, if you're trying to communicate or if you're trying to create any of the code or any of the changes you're trying to do either CLI or PowerShell, it actually come back to Azure Resource Manager. From there, it will go and it will work on that specific resources. So this is the major advantage, that you have a consistency in terms of the management layer. So you use any of the tool, it doesn't matter. If you're coming from a Linux background, you might be using Azure CLI, and if you're from a Windows background, you might be using either Azure Portal or maybe a PowerShell. So you can actually use any of these management tools, and it actually go and communicate consistently with the Azure Resource Manager for your authentications. That's the major advantages. So it's not just the CLI or PowerShell or Portal. You also have the REST-based clients. When I say REST-based clients, for any of the development has happened, so you can use the REST-based APIs also to communicate with any of the applications with the Azure Resource Manager for the authentication purpose. Let's try to understand within this infrastructure or within this design of Azure Resource Manager what all the terminologies that you must have to know. So the first thing is resource. Yes, when you talk about the resource, it's a manageable item that is available within Azure. Let's say a virtual machine or storage account or web application or database or maybe your virtual networks. All these are the resources that are the good examples for you. So when we talk about the resource groups, subscriptions, management groups and tags, all these are also, we can take it as a resource. So not just the web app or virtual machine, we can take it as resource groups also, subscriptions and management group, tags, everything we can treat as a resource. Let's try to understand what exactly resource group. So we have done a couple of demos also throughout this course, and that's the first thing, what we create a resource group, because when you try to create any of the resources like a database or web application or virtual machine, we would actually put it into a resource group, because we wanted to follow a life cycle of that application or that specific resources with aligning to resource group. So what exactly resource group? Resource group is a container that holds a related resources for your Azure solution. So as your resource group indicates these resources that you want to manage as a group. Let's say you decide with the resources belonging to a resource group, like you created a project for HR team. So you created a group called HR team, and might be HR team is using HRMS application as a web application, and they might be using some virtual machines or some database as a backend. All these resources can be part of your resource group. Let's say on one fine day you want to retire or you want to delete all these resources. So what you would be doing is you can simply remove this resource group. When I say remove, you can delete this. So when you delete this resource group, all the resources that are aligned within this resource group will be deleted automatically. So it actually follows, these resources will follow the life cycle of a resource group. And we would be creating for every demo almost a different resource group. Later point we would be deleting that resource group. And there are a lot of advantages by having the resource groups. Or let's say you can put all of your project or lifecycle of all those resources in the same group, and you can deploy, you can update, you can delete them together. Let's say you think that these specific servers or XYZ servers should follow into a different business unit or different lifecycle, then you would actually put them into a different resource group, so that you know that these things belongs to a different resource group, and you can manage it. And you cannot have a nested resource groups, and resource group is the top layer, and inside that resource group you cannot have one more resource group. However, if you want, you can move some of the resources. Let's say in my resource group I have, let's say if this is my resource group, and within this resource group I can move my resources to some other resource group, but I cannot have one more resource group within this resource group. That's the design, how we normally do it. When you try to create any of the resource group, you need to actually give the location or the region where it's gonna actually store this resource group. But in fact, every resource will also, we need to specify a region. So in that situation, let's say if I if I choose my resource group as East US, but my resources are from maybe West US, I can create in such a way also. But think about a complaints point of view. You might be have some kind of a complaints that all of your resources must be in that specific region, because if you look at the resource group also will store something called a metadata that will actually contains this location information. So for complaints reasons, you may need to ensure that your data is stored in a particular region. So if the resource group region is temporarily unavailable, you cannot even update resources in that resource group because the metadata is unavailable. So the resources within other regions will still function as expected, but you cannot update them. So make sure that you would be choosing the right resources as well as the resource group into a right region. And also you can apply tags. Let's say if I give here my demo as the resource name, later point when I was trying to create, it will ask for me to add the tagging information. Tagging information will really helps us, and also this information tags do not inherit to your resources that are part of your resource group. And also if you're trying to communicate, let's say you have created one a resource group called HRMS, and another resource group maybe for your employees project 1. Let's say whatever the resources you have within these two different resources, both can communicate. So there is no restriction for the communication. The reason for creating resource group is just to follow the life cycle of a specific resources in a specific group, so that it can be deleted or it can be updated or it can be created by following that specific resource group life cycle. And also I can create any resources, not just the resource, with the resource groups also as a template. You see here, download a template for automation. So when you download this as the template, this is called ARM template. We're going to work these ARM templates later point, but I'm just trying to explain here about the resource group. So let's jump into the PPT and understand about the resource provider as the next terminology. So when we talk about the resource provider, let's see, when you're trying to deploy some of the resources, you may have to frequently need to retrieve some kind of information about your provider. For example, in this case, if you're trying to deploy a data storage, you might be trying to communicate with the storage account. So for that, there is a provider that's called Microsoft Storage. So you can check out the documentation. For every resource, you will have some kind of provider, and that provider with that provider you can communicate and you can retrieve the information. So what happens is, when you do here any of the CLI, PowerShell or REST API, you will actually communicate with the resource manager for the authentication. Later point, within this ARM, you are gonna work with your resources. So in this case, the resource, how do you call, is Microsoft Storage. Let's say if you're trying to work with Key Vault service as other service, so you might have to call as Microsoft Key Vault. So how do I know that Microsoft Key Vault? So I need to go to the Microsoft resource providers list and I can check out. So that's where it's gonna have all the list of resources and the resource provider. So these resource provider offers a resource type called, in this case, if it is a vault, we call it as a service vault or Key Vault services. And name of the resource type is will be in a format like resource-provider and then the type of the resource. So in this case, resource provider is Microsoft. So Microsoft dot maybe a storage, or it can be a Key Vault, all that. So what you can do is you can actually register your resources by doing the registration. The resources, it becomes as a service. So what you can do is let's actually go back to the portal and let me show you here. If I just go to my resources, like I need to just go to my subscriptions. So let me show you the subscription. So I have here the subscription. So within this my subscription, I have all services, which is the subscription, and within this I have resource groups. So I will have all my resource groups. Also, if I look at all the resource providers, if I just click on this, so I will have all the resource providers. Some of them are registered, some of them are not registered. If you see here, if I want to work with the virtual machines, just nothing but you're creating VMs. So since it is registered, I can actually create virtual machines because this specific resource provider is registered. Let's say you might be, at least within your, when you're working as Azure admin, you might get, sometimes the some errors saying that, hey, I did not find this specific service provided, so I cannot work. Such kind of errors you would be getting within Azure portal. In that situation, you just have to come back here for the resource providers and then do that registration. And then let's say if you are working with the bot services, you see here the bot services or blockchain is not enabled for me actually, so I cannot create anything related to the bot services. And now what I have to do is I have to register this by simply select that specific service or resource provider and then say register. That's going to enable this specific resources so that we can use on top of it by using this resource provider to create any of the resources. So that's how it's going to work. As the next step, which is a bigger one actually, Resource Manager template or ARM templates we call it. So we have a dedicated lecture on ARM template. Make sure that you can check out that. And just to give you an overview, when you try to create any of the Azure resources, you can actually create, it actually in the backend it creates a template with a design of a declarative and a customized, a kind of programming kind of thing, which is nothing but actually a JSON JavaScript object notation file that gets actually created that will define one or more of your resources which you are trying to deploy to a resource group or maybe a subscription or to a management group or a tenant. Let's say if you try to deploy here some of the resources, so that specific template would actually consist of your resource group information, subscription and management group information. So it's a kind of file that has all the answers, so that it uses that's a structure called JavaScript object notation. That's nothing but a JSON file that defines all these resources and resource groups, subscription, management and tenant, all that information, and then you can actually redeploy that as the file. Let's say if we are trying to create here any of the resources, let's take one of the resource here. In this case, I have a virtual machine here within my Azure portal and it was created manually, and let's say I wanted to duplicate very similar configuration of my all the resource group or the size of the virtual machine, my subscription, my location, and the naming format, all that you want it to be in a similar format, including the Vnet and the public IPs, specific configuration, or maybe NSGs, all that to be automatically. You can create basically a template kind of thing, so that when you try to deploy this template, you will be getting all this specific configuration of a multiple virtual machine. So for that, you can either create from scratch this JSON file, which we talked about it, which we are going to talk in a upcoming lecture from scratch. And if you're trying to deploy, or if you have already deployed this kind of virtual machines, you can actually have a look on from the automation. So you just have to go to automation and export template, and this is where you have the entire template. So if I just click here, toggle this left side, and you see here this is the template, which is nothing but a JSON file. So I have a schema and my resources, all that type, everything is available here. So I can use this template to redeploy the number of times. So I can add this template file to my library. Later point, I can call when I try to create a virtual machine from this library, this specific ARM template, so that I would be getting very similar virtual machine can be created by using this template. So let's jump into other terminology here within this declarative syntax. So syntax lets you state that here what I intend to create, right? So without having to write the sequence of a program commands to create it. The resource manager template is the example of the declarative syntax what we can take. We just talked about the resource manager template. That could be one of the declarative syntax we can say.
in that file you can define the properties and infrastructure to deploy. So all that actually we are going to talk in the Resource Manager templates or ARM templates. So what we have so far talked is we talked about the Resource Manager and what's the use of the Resource Manager, how this is actually designed technically in the backend, and the terminology that are related to the Resource Manager. And also we talked about the resources, resource group, and resource provider. And also we're going to talk in the upcoming lectures about Resource Manager templates or ARM templates, as well as the declarative syntaxes. So by this time you might have already understand about you can use the Resource Manager for managing your entire infrastructure with the declarative templates rather than your scripts, or you can deploy, manage, monitor all of your resources of your solution as a group rather than handling these resources individually, right? That's where we're going to use the resource group, and you can redeploy your solution throughout the deployment lifecycle and have a confidence on your infrastructure, basically like by using the Resource Manager templates. Like I have just shown you a virtual machine. I have taken similar virtual machine. I can be confidently I can redeploy so that I'll have the similar resources can be deployed consistent state in a consistent state. And we can also apply the RBACs. When we talk about the RBAC, the role-based access management, we can actually apply the role-based access management directly from the ARM for your all the either you can apply this at the resource level, or maybe a resource group, or at your different layer of your management. So that's basically a scope. So when you try to understand about the scope which Azure Resource Manager provides, is we can say that 4 level of different scopes that we can have within the Azure Resource Manager. The first one would be the management groups. So you can create multiple management group, one for maybe IT, one for maybe a sales team, one for different project altogether. And later point, within this management groups you can have more than one subscriptions. Even let's say one of the subscription you just signed up, and so that the billing would happen on underneath of this management group, and you would know that what's happening with this management group and who's gonna responsible for the billing. So you can actually define that logic. So when we look at the higher end from the top level, you can easily narrow down where these management groups are going and what are the number of subscriptions you have, and each of these subscription will have definitely a different type of resource groups, and these resource groups will follow the life cycle of different solutions that you're going to create within Microsoft Azure, like virtual machines or web app or SQL Server or automation. All that would be part of your resource groups. So technically this is how it looks like, and I hope this entire lecture is useful for you to understand about Azure Resource Manager, and we'll catch you in the next lecture. I did talk about a different lecture on the management group along with a dedicated demo. Please make sure that you check out that lecture. This is just to give you an idea about management groups, and which is part of your again Resource Manager, right? So just wanted to give you the high level overview on the Resource Manager.
Hello and welcome back. In this lecture we're gonna learn about ARM templates. Most of the cloud teams that after moving to the cloud, they have adopted agile deployment methods, and these teams iterate quickly, and they do need to repeatedly deploy their solutions to the cloud and know their infrastructure in a reliable state. As the infrastructure has become part of the iterative process, the division between operations and the development has disappeared at this point of time after moving to the cloud, and these teams needs to manage infrastructure and application code through their unified process. So to meet these all challenges, you need to automate deployments and using the practice of infrastructure as a code. So in a code, you define your infrastructure that needs to be deployed, and the infrastructure code becomes part of your project. Just like application code, you store the infrastructure code in a source repository and version it and properly, and then anybody can use it within your team to run that code, so that they can easily deploy that entire solution or the entire similar environment. Like maybe you try to deploy it in a development, later point you wanted to move it to the production, you can deploy as it is with that simple infrastructure as a code. And to implement these kind of infrastructure as a code, Microsoft Azure provides the solutions with the help of ARM templates. So that's where the ARM template comes into the picture, and these ARM templates are purely based on the JSON, that's a JavaScript object notation, that's a file type that defines the infrastructure and the configuration of your project. And the templates that uses the declarative syntaxes, which will let you state what you intend to deploy without having to write the sequence of the programming commands to create it. So in the template you can specify the resources to deploy and the properties of those resources. Let's have a look on template sections. So every template will have few of the major sections will have. The first one would be the parameters. Parameters will provide the it gives the values. We will provide the values, or it will contain the values that will be useful during the deployment, that will allow the same template to be used with different environments. And there also we will have variables, like just like any other script, you also have the variables which will define the values that can be reused again and again, and those values will be hard coded in your template, and they can be constructed from parameter values basically. And also you can define a user defined function. So these functions basically nothing about when you try or when you write your template expressions that can extend your capabilities of your JSON file. So you can customize your functions that simplify your template jobs. And also you have the resource. So resource which you wanted to deploy, let's say you are trying to deploy a storage account or virtual machine or Vnet, we're talking about those resources. And coming back to the output, yes, this output is very similar to any script that you get the output. Similarly, it will return the values of the deployed resources. Let's say you have deployed a virtual machine and you want to get the public IP of that virtual machine. So in the output you can define that, hey, I want the public IP of this virtual machine once you deploy, so please give me that output. You can write that output. So that's the template section side. This is a sample resource specific one. So what happens is when you try to deploy with the templates, it actually converts into a REST API based template. It's gonna convert it, so that would be taken care in the back end, and it actually sends that operation by putting into put values and get values, all that. So let's try to understand the template design. So the templates can be defined as per your entire requirement based. Let's say you want to manage your solution with a single resource. You have a single resource and you have 3 different templates that can be deployed, maybe deployed as a virtual machine and application services. And also this application service was gonna reference in the backend to your SQL server. You can do these kind of deployments within your templates, but also you can also go for nested based templates. When I say nested based, like you have a multiple templates that's gonna actually work as a parent template, and then nested VM template, and then a virtual machine. So this all becomes as one JSON file and you can deploy it. And similarly you also have an option for deploying very similar to a individual template can be deployed, like for one for the virtual machine, one for the web, one for the database to be deployed, and these later point can be interlinked. These SQL server can be linked with maybe to work with the application services. You can configure these kind of things. And now we are going to actually have a look on in the upcoming lecture or within this lecture about how to create ourselves these ARM templates, or try to use those templates and build some kind of resources within Azure Cloud. For now, we'll try to understand a little bit more about the ARM templates benefits and why we choose them ARM templates. So when it comes to deciding factor between ARM templates or any other infrastructure as a code service, you would definitely go for some kind of advantages for exploring. So the first thing would be you can declare syntaxes within your ARM template that will allow you to create and deploy entire Azure infrastructure in a declarative method. For example, you can deploy not just the virtual machine, but also you can deploy virtual network infrastructure and storage and other resources that you may be needed for your solution. And you can use the repeatable results, because when we talk about the repeatable, you can deploy your infrastructure throughout the deployment lifecycle and have confidence on your resources that are getting deployed in a consistent manner. When you try to deploy a virtual machine, it will be a consistent manner, that it will be the same size, same region, and same format of the machine name, all that. So it actually gives you a more confidence and a consistency on your infrastructure. If something goes wrong, you can always rebuild with the help of ARM templates. And when it comes to the orchestration, like when you submit it manually, if you see here, when you submit manually, it's going to actually put calls one by one. Let's say you deployed a virtual machine and web app, maybe a storage, maybe a SQL server, maybe some kind of infrastructure for virtual network. All these one by one have to be submitted if you have done a manual method. That is, there's no code based infrastructure. But when it comes to the template based, so you have the code is ready. So what happens is it will submit all the things in one go. So if there is a dependency, it's going to follow that dependency, but otherwise it's going to put all the requirement to be submitted once and at once, so that you get the faster response, and you can parallel deployment would happen, and it finishes in a faster than the serial deployments, right? So this we can treat as a serial, this can be a parallel deployment, and you can deploy these things with a simple one line command rather than putting in multiple commands. So now let's talk about the modular files. When you see any of the RM templates, you can actually break the code for your templates into a smaller, and you can reuse those components. Let's say I want to use for the admin username for that my template, I can simply break these things, and for the authentication I can break it, and parameters I can break it. So such things can be easily break, and then you can reuse them, and you can even interlink that later point. So it's so easy, and you can build as a nested one, as a great one template inside within one template. Since we use Azure Resource Manager in the backend, we can deploy any kind of resources within Microsoft Azure Cloud. When it comes to the extensibility, you can use your PowerShell or Bash kind of scripts within your template, so that you can reuse them, and these kind of templates becomes as more powerful. And also when it comes to the testing side, you can make sure that your templates follow recommended guidelines by testing it with the ARM template toolkit. That's an ARM TTK, that's called ARM template toolkit TTK, and this is a kit which is available with the PowerShell script, and you can download from a GitHub. And the tool kit will make sure that it's easier. It's basically easier for your deployment and expertise using the template language, but it gives you the recommended guidelines for your testing. And for the preview changes, you can always use what if operation to get changes. What's going to happen if you try to deploy a ARM template. You have an option called what if operation that can be used, so that way you can actually get more confidence on the changes that's going to happen, and you can always preview before it has happened any of the changes. And there is a built-in validation. What does it means is, like, you have a template, and before it actually deploys, it actually validates the template, all the values that has been inside the template. And then if the template really good looking as an infrastructure as a code, then only it will start deploying. Otherwise it doesn't go even the validation process. Apart from this, you can track the deployment process and policy as a code. You can use the policies, Azure policies, and as a code framework to automate your governance process. and also you can deploy by using the blueprints, which is Microsoft Azure blueprints. Those are the infrastructure high level designed blueprints that can be used as a ARM templates. ARM templates also supports continuous deployment and continuous integration as CI and CD supported. And coming back to the exportable code, as we have seen in the previous lectures also, you can actually export the code that you have already deployed. Let's say I have this virtual machine which was already deployed, and if I want to redeploy similar kind of configuration, I can always go for automation and export this template code, or I can simply download this template. It's going to actually download this ARM template as a JSON format, and also you can copy this entire template to your library, and later point you can reuse that template. So you see here I have the downloaded the file, and if I try to open this file, I'll have my JSON file as well as my parameters. So parameters are that need to be defined. You see here within this I have here parameters that needs to be submitted, like machine name to be submitted, and the disk and networking settings, all that. These are the parameters, and the variables, if any of the variables, that also will be downloaded. So I'm gonna actually use these things later point, and I can redeploy this entire template, so that way I can deploy similar configuration of virtual machine. So that way it's gonna help me as an infrastructure as a code. You can try to put it in other way, like if I try to use this Vnet, which is currently associated by some other virtual network, so I can use this specific Vnet all the time for my entire virtual machines, since I did already mentioned within my code. So in this case the code is nothing but JSON file or your ARM template in other ways. So you will be mentioning here whatever the network card or the Vnet name and the subscription name. You see here the subscriptions are already defined here, and the resource group was defined, and the networking and the standard type of your VM size. So I have a consistency of the VM size and the disk name and the disk type and the disk size, all of them. And that's where actually we can use the exportable code. And coming back to the last one, which is the authoring tool, so you can actually author with the help of Visual Studio Code, and you can templates, you can use those templates as the extension, and you will get the IntelliSense of syntax highlighting, all that options. So let's jump into the Azure portal to have a look on quick demo on ARM templates creation. We'll try to create some of the templates, and we try to create some of the resources. And the upcoming lecture, I'm going to talk about where we have all these ready-made ARM templates are available. Basically it will be available in the GitHub, and you can use those GitHub library or the templates, and you can rebuild those things. So which I'm going to explain in the upcoming lecture. But for now, let's try to create our own ARM templates.
Hello and welcome back. In this short lecture, we will be learning about Azure Resource Manager, which is one of the very important tool within Azure. Azure Resource Manager, sometimes we also call as ARM or ARM in short sometime. So do not confuse that if somebody calling as ARM or ARM, like A stands here Azure and R stands here Resource and Manager ARM. So most of the time the Microsoft documentation also refer as ARM instead of full name. So I just gave the title as also Azure Resource Manager, but most of the time we call as ARM. So what exactly this ARM or Azure Resource Manager? Well, one thing that it makes it very important of the services within Azure is it's a single centralized service that can be used for both managing and deploying our complete assets within the Microsoft Azure. So that's made us completely very critical for within the Azure services, because you see here Azure Resource Manager is the middle, and which can communicate with your identity management solutions. It can be ADFS or Azure AD, and it can actually it can be communicated with one of the APIs like Microsoft Azure Portal, or it can be from Azure CLI, or even the developers can start creating their
Azure services directly from Visual Studio. So what would happen is they interact with this Azure Resource Manager in the form of either writing a code in a right format. In fact, it can be a JSON format by declaring those values and properties, and then they would start creating the required Azure services. So not just that creating, they can create as a template, and that template can be reused again and again. So that's all about at the high level of this design side. Let's jump into the complete explanation of ARM or ARM. So what exactly is this? So let's dig into this a little bit more. When we talk about managing our own assets, we are talking about how Azure Resource Manager let us create and update and delete resources, including the ability to do within the ARM templates. So there's a template that can be called as the Azure template or ARM templates, and right way would be the ARM templates. So you create a resource that can be converted into ARM template so that it can be reused later point. Let's say you created with all your configuration a specific service, and you wanted to reuse the similar settings to create in a no time, then you simply have to use that ARM template to redeploy again and again whatever the services you wanted. So it's so easy. Now, in addition to managing our resources like we just went over, the Azure Resource Manager also can deploy our resources, which is really cool. It combines both the services management and development and deployment all inside the same API. And what you mean by deploying our resources is once we have configured everything that we have, let's say we have a virtual machine. Once we have configured that, then the next step is to deploy it, which will actually start up the virtual machine and host it on a server somewhere. The same for the app service plan, which is to host a web app. Once we have configured that and pointed to our application code when we deploy it, that's when our website actually becomes public and everyone can see it. And so having this ability to do both create, update, manage your resources as well as to deploy them, to take them offline when we need it for maybe a maintenance, makes the Azure Resource Manager again your single kind of centralized part for doing all the administration and management activities you need overall for your Azure resources. So now another cool thing would be with the management side. Since when we are trying to deploy with the Azure Resource Manager, we can also add up how the access controls should be done and auditing and tagging of our resources so that it enables us to secure it and organize our resources after they deployed it. With access control, for example, when we say access control, we can set policies so that only certain users of maybe a certain users of in a group that can actually create resources, for example deleting resources, such things can be applied. And with auditing, we have the ability to go back and check logs to see which user actually created or updated or maybe deleted for that case of any of those resources, or maybe deployed that specific resource. And with the tagging, we can apply tags to resources across resource groups and resources so that we can later search by tags and we can see all of the resources being used throughout our organizations based on what we have tagged with them. Just to give you more about the taggings commonly used for the department codes or within your business, especially on the name of, for example, let me show you here in the any of the resources you can give here as the tags, maybe for this resource group which I'm talking. Maybe if I want just for the VM or maybe for a VM, I can give here tags to that specific business unit code, or maybe a cost center code that can be given so that I know
I can easily keep track of my building centers, which resources are being used. And also let's take a step back, and we have talked about the management and deployment aspects of Azure Resource Manager. With the management side, we can both actually create and delete our resources, as well as the effect access control, auditing and tagging across the resources. And we have looked at how we can deploy resources, as well as even take them offline when we need maintenance, all through the same single API that's called Azure Resource Manager, or ARM. Now, we also touched briefly on the fact that we can use templates. So let's have a look on what exactly I'm talking about templates. Let's say this resource, maybe let's take the one of the VM here, and you see here this VM is already got created, but this also have a template format. You see here, this is the JSON format template which is already available for me. So if I wanted to deploy similar one, I can straightforward go ahead and start deploying. So what would happen is the same kind of resource which is gonna create for me. So I no need to again input similar values. Let's say to understand about more, like resource is about virtual machine, type is, so that means it's going to deploy a virtual machine. So similarly, if I try to deploy a website example, this is also same case with the web app. You can check out here web app. This is also getting deployed similar to the website default value. So such things can be deployed automatically. So every resource that we have within the Microsoft Azure portal, that will have its own ARM template, definitely, because that's a middle one, that's the interactive one which we wanted to do it. So that's why we said it's a single centralized service that we can use for both managing and deploying our assets. So it's all about the managing and deploying. So everything will have a template. Let's talk on that templates or ARM templates. That's a big topic, this is actually, and we will look into it in the upcoming lectures. But just to understand at high level, to talk on this specific topic within this course, I'm going to give you all the inputs that are required for this exam. Now, you have here GitHub website, which is a quick start templates. For example, you want to create maybe a single VM with the 2 network cards, or a blank VM. Such things, everything is available here. You can visualize how the thing's gonna deploy. So let's see, this is going to be, if I just zoom it, you might easy to understand. It's going to create a network security group. It's going to ask for some of the variables for the public IP, NIC2 and NIC1, both connected to one of the virtual machine. And this is a storage account, this is a virtual machine. So this is how it's going to deploy. So if I just go back to the previous designer, that's a bug actually, I can't go. But if I just go to GitHub once again, just search as the Azure template in GitHub, that takes all these templates which are available 101 templates. So here, take any of the template. Let's take 1 VM and 2 NICs. So we did visualize that, and if you want to deploy straightforward, you can do it from here. But let's talk and let's understand what exactly this ARM templates. So ARM templates are a format which is in a JSON format. Let's have a look on it. So Azure deploy JSON file. So if I just click on this JSON file, this talks about all the structure format, which is a simple input format file. So let's take it also have, if you see here, it also have the raw format. So this talks about very clear view if you're trying to understand like properties of the IP configuration and the variables for the NIC2. Like this is the type of the network card. If you want to create a network card, it goes to Microsoft.network/network interface. Now, so
these are the templates which are quickly available for us to understand. And you also have the parameters JSON file. So all you have to do is you have to just give the parameters to be passed, like username and the password, and the rest of the things are already available within this template. That's what we are going to use for the Azure Quick Start template, ARM template that can be deployed. So now let's go back to Microsoft documentation. What we are actually trying to look at here is, like, if you just go to the quick start to create a Azure ARM templates by using Azure portal. So let's try to create one of these storage account with this format. So what would happen is you can check out this the template which is coming up here. So let's talk on this specific template for a minute to understand what's going to happen. So here it's going to asking for us to select the resource group. So the resource group is the group which we learned in the previously to as a container, and now the location which it needs as a parameter. You see here it's going to actually ask only these parameters. Later point it's going to deploy. That means when you click on the purchase, it's ready for deployment. After all of these explanation, you should be able to understand the benefits of using Azure resources, because we talked about the repeatedly using all such things. So let's take a close look what Microsoft site says. So if I just scroll down to Microsoft overview page for Azure Resource Manager overview, you have all the benefits listed here. Let's have a look on it. So what we can do is we can repeatedly deploy our applications and solutions, and know that our resources are always deployed in the same consistent way or consistent state altogether. So you're not making any manual errors since you are following a ARM template, because the template will ask only for the declarative values, as we had a look on here. For example, here it's going to just ask for those values only all the time. You see here it's just selecting, for example, you don't want the central years to be taken by the end users, so that has to be grayed out. So simply we will hard code that value into our template, so that every machine or every resource that is going to deploy it, it's going to be in a standard location called central US. So that way it would be beneficial for us. So let's also think about like you're trying to deploy a app service plan or maybe a SQL database or other things like that definitely follow it's a template method that would actually result ongoing things which is going to happen each time, and makes us helpful if we have multiple environments that we might start with a dev environment, make our templates ready, similarly deploy our resources maybe, and then edit our templates until our environment is the way that we want it or that way we need it, and then we can move it to our applications becomes more stable. Then we can move it to, or we can push it to second environment like testing or pre-production, something like that. So think about in that direction, which would definitely help you to bring more value for your management and ease of deployment. This really helps. The way we want our environment is set to exactly the same way every single time, and it makes it really great for us for situations like that, where you have multiple environments and you don't want to do any manual work every time to deploy or set up a new environment. So when we use the template in this way, we are using declarative of approach, and declarative means that we are telling the service how we wanted our infrastructure to end up after templates have already run, rather than going through a set of steps each time to configure our environment in the same way. Rather than using the scripts and kind of procedural approach, these templates let us work with the declarative approach to determining how we want our infrastructure to end up after deployment. And the cool part about the template is that we can even define dependencies between our resources so they are deployed in the right order, which is really cool for us to save, and it saves a lot of time for us as an administrator. We might to see that certain resources need to be deployed after another resource, and we can make it so in our templates. And as your resource manager will deploy our resources in the correct order. Let us take a look at Let's take a look at our overview of creating a template. You can see here, so this template is talking about unique things here, like storage account name, as well as the parameters, resources, all those things. So when we actually downloaded this specific template, it's going to actually talk about the similar structure. So within this file, the structure is a JSON format, and you see here within this you have the following values, especially the resource group and location, account type. All these things has been already prompting. For example, if you see here the location, which is actually coming up, account type and kind and access style, supports HTTPS traffic only. All this is a value which is actually a variable value which is asking us to enter as the input. If at all, if you wanted to go for a hard coding, for example, here a storage account name you want in a hard code, you can put it here so that it's gonna make it as the not the variable, so it's going to be a hard coded the value. But remember that the storage account is a unique thing, so you make sure that you have that name is not taken by anybody. Similarly, if you're trying to create, since we're talking about the storage account here, the storage account, to create that, what we do is the type on a resource we are going to create as a type as the storage account from the Microsoft.storage. So for every type of resource will have a different values to be entered here. For example, here in this case it's just for the storage. So let's have a look on it for another resource. For example, with this specific to the JSON file, again you see here the variable and the resource. You see here the resource type is compute. Under that it's going to actually create a virtual machine. So this is the type you're going to do it. So these things are more flexible when we wanted to edit or we wanted to set it. For example, here it's starting this IP address suffix. Instead, you want to change it, you just have to change a little bit. That would actually go and becomes as a one standard. Or you see here, if I use this template all the time, I'm going to get it the same address prefix that makes my subnet 2 as a standard. So I don't need to input or do any kind of manual mistake with human mistakes when we try to input the data. So that really helps the and gives you more flexibility for us to create anytime with the templates. Once you have the template is ready, all you have to do is you just use the same template. So as I explained earlier, you can use the same template, like you can download this template like this and simply use the template to redeploy. For example, if I want to deploy, all you have to do is deploy, and you can also add it to your library so that you can reuse later point from the library. So that makes very easy for us. To summarize about Azure Resource Manager, it actually provides us a single consistent API and service to use. It internally will call out all the Azure thousands of hundreds of various different Microsoft Azure resources to providers in order to affect our changes on actual Azure products and services that we are using. I hope this is useful for you to better understand about Microsoft Azure Resource Manager, or ARM in short, sometimes we refer as ARM, and how this is going to be a centralized service and how both we can use and deploy for Azure resources. Thank you for watching this. I'll be seeing you in the next lesson. Hi there, welcome back. In this lecture we're gonna learn about how to create ARM templates from scratch. We are gonna use the PowerShell and we're gonna use the Notepad and JSON editor as a Windows text editor. Also we would be using Visual Studio code editor, which is a free tool that is a very useful tool. So we're going to use all those tools and we will try from a scratch, which will be a hard initially, but as we go through it, it becomes very easy because we're going to use the Visual Studio Code, which has the IntelliSense, which will automate your code for writing any kind of ARM templates. So let's jump into that. Before that, what I'm going to do is I'll open up this PowerShell and I'm connecting to PowerShell with connect-az connect. You can use even Cloud Shell also for this demonstration purpose, but I'm just trying to use here in this case the PowerShell, but you can use the same things with the Azure CLI also. So let's jump into the connectivity. So for here the connectivity, I'm gonna use the connect-az connect. That would actually open up a new browser where I need to enter my user ID and password, and once the authentication is successful, it's going to connect to my subscription. So in this case, I'm going to use a new subscription altogether. First thing, I'm going to create a new resource group called my resource group. This is where I'm going to put everything. So I'll use a PowerShell to create a new resource group called my resource group in this case, and it's created this group. Now I'm going to open Notepad, and this is what a template, which is a blank template, which I'm gonna actually explain to you here. You see here the schema, that's gonna schema which is for JSON's format. This has to be in this format, so I'm going to use this schema. And the content version, this can be altered as we discussed in the previous PPTs, and this is where you're going to add the resources. So you have even the parameters, variables, output, and resources and templates also as a functions within this. But for now we are actually trying a template, which is a plain template. I'm going to save this as the JSON file. So that I wanted to show you a simple blank template when we deployed how this looks like. So I'm going to save that. So for this to deploy, if you see here, I'm just going to open up with the JSON editor, which is available with your Windows 10 store. You can use this. So this is, it looks like the same one. And what I'm going to do is I'm going to actually deploy this Azure deploy.json file. So for that, I'm just copying the path and I'll define this into the template. So that's my template. So it has stored that variable, and now I'm gonna deployment as the blank template in my resource group. So I'll open up my resource group and show you. Currently there is nothing inside this, and if you see the deployments also 0 here, the deployments. So that's good. And now as a next step, I'm gonna actually call to blank template. That's a blank template. That's what I'm going to try to do. So it's gonna deploy. Once I click on enter, it's going to deploy a blank template. And if I go back to the Azure portal, it will show me as it's deployed as a blank template. That's a deployment name and the timeline. And if you see, it's incremental. So if you see here, the deployment becomes as 1 in a minute or so. So if it is not showing anything, I'll just do a quick refresh because sometimes it doesn't load. So if you see here, it was successfully deployed as 1. It was showing here. So that's a key here. And if you see here, that's the template name. That's what we have given, the deployment name. So blank template, that's what we have given. And this is what the ARM template that was used to deploy. So oops, it's not because of I zoomed it for your convenient. The text is not showing proper. So let me make it proper for you. Maybe let me unzoom. Yeah, you see here, this is the schema, content, and version. That's what we have deployed. Now what we're going to do is we will use the most advanced tool called Visual Studio Code, and you can just search for this and try to download, and we'll do the quick installation. In this case, I'm going to do the quick installation and show you how this code, which is the Visual Studio Code, will be very useful in terms of automating all this, because you will have, very similar to your Google Chrome extensions, you have the extensions and you can simply have to add your extension. So I'm just choosing here all the checkboxes, and that would gives me the options more. And post to that, I would actually install an extension for ARM template. So I'll just open up that, and you see here I have this code installed now. Within this you have here, if you just search here the extensions, you can search a lot of extensions you have here available. So I'm going to search here an extension called ARM, and you see a lot of them came. So out of this I'm going to actually use something called the second one, Azure Resource Manager. I'm going to use the ARM template Resource Manager. This is the one, and also this one. Let's actually install this one. So what happens is, when you install this, it's gonna once it is installed, when you type as ARM, it actually gives you intelligent way automatically all the required things. And also I'm gonna frequently use this ARM template viewer. What happens is, this actually shows me a proper visualization. You see here, whatever the code I have written, it actually gives me in this proper visualization. So I know that how this is looks like. So I'm going to install this also. So I installed 2 of the extensions. I would recommend you to work basically on Visual Studio Code. So I'll just search and open the Visual Studio Code, and then now all you have to do is click on new file and give the file name. So IntelliSense doesn't work until you actually save a file name with a JSON format, right? So I'm going to save this as a storage.json format or demo.json, so that what would happen is, it's going to actually use all that intelligence automatically which was built on JSON template, because we are going to work with the JSON. So now the intelligence will come. So if I type ARM, so it will automatically gives me all the options. Let me type it here, ARM. You see here it says that resource group template. So if when I type here, I got here my schema, I got here my version, I got my parameters, functions, variables, and resources outputs. So these are the things which we have actually tried in the first demo earlier, last 5 minutes back, about trying to create with a template in a notepad, and also the JSON editor, Windows 10 store based an app. But I would recommend always go for this. So you see here, this is what gives the intelligence way, where you don't need to write the code, it gives as an intelligence way, and you can select there for enabling any kind of parameter file also, if really you have any parameter file. And in this case, what we're going to do is, we are actually going to work with the resources, right? So we wanted to create a storage account. Say, let's say I wanted a RM specific template within this for my storage account. So I'm going to work with my storage account. For that, I need to write for the storage account specific resources. So I'll just type here, I'm going to type here ARM-storage, and you see here the storage related everything got automatically provisioned here. All you have to do is, you have to change your storage account name, and this is for tags name. If you're working with the tag names to be changed, you can do it. And the SKUs, like if you're using premium, LRS or GRS, whatever it is, you can choose it. Even the kind, the storage account V2 or V1, all that can be changed it. So I'm going to change here to a proper name. So in this case, I can give here a unique name that has to be given for my storage account. Otherwise, if that name is already available, my deployment gonna fail. So I'll give here a different name, and I'll just save this, and I'll try to open with a notepad and see. It's actually looks like this, the same thing. And I'm gonna actually give my storage account name as 24p, and I can actually connect to my Azure. If at all I have not yet connected, I'll just connect. I'll make sure that I'll verify whether my template file is already there or not, but I'll just check whether that is stored in that specific template file as a variable. So in fact it's stored, so I'm gonna deploy with the help of that specific variable. Now you see here I'm going to actually use AZ resource group deployment, and the name of my deployment I'm going to give as add storage, and the template file name and my resource group. So that's my resource group and that's my template, the last one. And if I just click on it, enter, it's gonna create a storage account that was mentioned in my ARM template. So let me open up my Azure portal and go back to your resource group. And if you see here, there's nothing at this point of time. And if I just quickly check my PowerShell status, so it has deployed. And if I just do a quick refresh of the page, I should be able to see at least one storage account which was given as the name within our JSON file format. So it has deployed successfully with the LRS, with the premium and V2 version, and that's good. And let's go to, again, I mean, these are the basic things which you can check it. So it looks good and it has deployed. So if I just go back to my tire, all that, so premium, everything is fine, looks good. And if I just go to my resources, I can see here the deployment status is currently 2. And if I just click on that successful 2 deployment states, and you see here add storage is the one which we have just done, and this is what the name which I have given. So it's gonna work, it was actually worked as this. So now I'm gonna actually work with other things like parameters and output in the next 1 to 3 demos. So let's do that also here. So in this case I'm gonna use here the parameters. So I'll just click on enter and type here what are the parameters name. Let's say I wanted here my storage name, or maybe call name, and then here if you see here this that has identified as object, and just click on that. Again, you can enter within that object the properties. Let's say this could be the type of my storage account is, I can mention here it should be a string, and the minimum and the maximum of my storage account name parameters I can define here. Let's say a minimum length of my storage account name should be a 3 example, and maybe a maximum length maybe I can give here, and the colon and the value of that maximum length, so it can be a 24 characters. Let's try to store the storage account name as the parameter, so that it's gonna ask us the storage account name. So in our case, currently the storage account was created as my storage 42p, and what we're going to do is this time instead of that 42p we are actually gonna ask us to create something else, a new storage account name. So here I'm just giving as a tag name as storage account, and I'm saving this post to the parameters, all that changed. So we know now the storage account as the name it's gonna ask us. So let's go to PowerShell and we save this simple ARM template, and let's say click on save file and save that. So that's going to save it. It's not going to autosave, so we have to save it. So I'm going to actually paste this command with the new Azure storage deployment, but this time I'm actually asking to enter the storage account name in the PowerShell, so that it's going to actually create that storage account with a different name. So I'll just enter here. This might take a minute or so to create a storage account. So this time what happened is it was actually asking us the parameters, and we are giving that values. So you see here this has been deployed now successfully, and it was successful, and the storage account name whatever we have given here, this was created as this, the same thing. That's good. So let's go to the resource group and do a quick refresh of the browser. That should be the browser, so that you should be able to see it, because you don't get it on an immediate basis most of the time. So you see here 23, yes, 4 is the same thing has been created successfully. That's how it's going to work for the parameters. And now we can check out these values, like whatever we have given, all that has been successful. And you can actually find even the tags we gave this time as a storage account, and that was actually given properly. Now let's jump into randomizing the storage account name. So what I'm going to do is I'll simply add here parameters, a little bit of, including the SKU. You see here I have added all the SKUs and also the location, and then I'm going to actually use the variable called unique. So I'm going to actually now showing you as a variables. So what I'm going to do is I'm going to actually prefix for my storage account whatever the name I gave initially. Let's say if I give as a store, and it's going to actually prefix with that store with a random ID of a unique ID, which is going to add for my storage account. So I'm actually entering here with the value that should be my storage account as the unique name it's going to create. So if you see here, I gave the SKU which I wanted to as the LRS, and also the storage prefix what I have given as a store. So post to this, it gives a random name automatically and it gets deployed. So that's the value, or that's the use of the variables which you can use within the ARM template. Let's say in this demo we are actually creating a storage account with a variable of a unique value to be append for my storage account. So you see here my storage account got created and it has actually appended. If I just go to my resources and do a quick refresh, maybe I should be able to see here. If I just do a quick refresh, maybe the page, it should immediately load. And if I just go down, you see here store, it gave the name as store, and opposed to that a unique name has been given. So that's the advantage that you have with the storage account creation with the ARM template. So it's not just the one, that's how you can use the variables in most of the places within the ARM template. So it was successful. We gave as a store, and it has given a different name post to the store as the random number or unique number. That's good. Now as a next demo, what we're going to do is within this we are actually going to try to use the output. You see here we wanted to retrieve some kind of outputs. Let's say within the storage account I wanted to retrieve my what's my blob specific output, or my file share, all that. So I wanted to give that information. So what I'm going to do is, so post to the resources, you remember we had the output also section. So I'm going to give the output section here, so comma, and then the output. Again, this is an object, so it will automatically identify here the output storage account endpoint specific. So I'm going to actually get the endpoints from my blob, my everything. So here you don't have anything, so I'm just gonna save as it is. So you might have a question, what would happen if I have the same storage account? It's gonna actually, if there is no change, it's not gonna append anything. If you're creating, since you're creating actually a random thing here, the storage name, it's going to create a new storage account, and also in the output it's going to show you all the URLs that are going to be unique in this case. So you see here just the one at this point of time, and the code should come up here any point of time. You see here these are the endpoints for your DFS, web, blob, queue, table file, and that's the output what we wanted for storage endpoint, and we got that storage endpoint information as the output. That's good. So you got the new storage account also got created. So let's refresh and find out. You see the 5 deployments now. This time we were actually worked with add outputs as a deployment name here, and this is the incremental. So that's gonna actually show you in your deployments also as the add output for your add outputs deployment. So in this case this is the add outputs, and if you see here 11 seconds back it got deployed, and you can check the resources. So that's a storage account which was created, and click on that. So that would show you all that information which was available, and also it is showing the storage endpoints URLs. That's good. So this is how you're going to work with the ARM templates. I know that it might be a little bit of hard initially, but if you look at other lectures, we did actually talk about the templates where you can actually use the GitHub specific template, so you can go ahead and use it. So now I'm going to do it this specific storage account as the template. That means I'm going to actually save this entire template that was created. You see here there's a one parameter which is asking for the storage account name, and everything I'm going to actually add this to my library. So library is a collection of where you can actually save your all of your JSON templates. So you can recall that template to create as infrastructure as a code solution. So I'm going to actually save here by giving a small description, and I'm going to save it, and later point I can go back to templates and redeploy it. So that's gonna redeploy automatically straight from my Azure portal. So that's the advantage that I have here. So I'll just go ahead and search for a template. In this case, I'm gonna actually delete. I wanted to delete this and show you. So I'll quickly delete all these things. So now it should be gone, all these deleted. So that delete function was successful. Now I'm going to actually use a template. So I'll just search as the service for templates, and you see here under templates you have one which we created, and the version, all that, and you can view the template or you can deploy it. When you click on deploy, so it's going to ask what is the resource group you want to use. Since we have already hard-coded as a central use, so it's not going to ask, and it's going to ask the storage account name. So it has generated for us randomly. You can validate that and click on validating, and finally it's gonna deploy it for you. So that's how it's going to work. So once it is deployed, you should be able to see within that resource group a new storage account which was deployed from out of your templates. So templates are useful when you create your infrastructure as a code as this ARM templates, and you can use them. So you have a storage account code created randomly with a random name that was automatically even gave as the output for you, and it looks good. So that concludes this lecture on how to create. We did actually had a look on creating a templates, and also we have gone through the started with the notepad, and then we shifted to Visual Studio Code, which is very useful, IntelliSense, and within that we have added resources and parameters and also variables, and also we tried with the outputs, and for this we also saved as a template, and we use the template to deploy it. So that concludes this lecture. Thank you for watching this. I'm sure that it might be a difficult sometime, but it with more practice. Thank you. Hello and welcome back. In this lecture, we're going to learn about Azure Automation. Azure Automation delivers a cloud-based automation and configuration service that will support consistent management across your Azure and non-Azure environments also. With Azure Automation, you can go for the process automation. When we talk about the process automation, anything like frequent things that you wanted to automate with the help of your Python runbooks, or maybe a PowerShell can be used to automate your tasks, which not just for your on-premises, you can also do it on a cloud and hybrid things. You can go for automation so that you will be getting error-prone cloud management tasks can be achieved, and this will definitely helps you in terms of the operation cost also can be reduced by going for the process automation. And when we look at the configuration management, basically we are talking about the configuration management with the two things. One would be the checking and tracking the inventory information about the assets, and other one would be the DSC. That's nothing but PowerShell DSC, like a PowerShell automation state configuration we call it. And with that, the configuration of that specific machine or maybe specific asset will remains all the way all the time with the same state. It doesn't allow you to change. So even you can track the changes also with the help of configuration management. And when we talk about update management, in fact we have two videos which are covered within this for the Windows updates, for the update management, where you can do it from the right directly from the virtual machine, or you can schedule it directly from the Azure Automation. So this is not about the patch management. And coming back to the shared capabilities, when we look at the shared capabilities, Azure Automation offers a number of shared capabilities like like RBAC, that's role-based access control, and flexible in terms of the scheduling your tasks, which runs automatically on a scheduled time. And also you can control your source code integration and auditing and tagging, all that actually supported in a shared capabilities. And also it supports heterogeneous. When we talk about heterogeneous like Windows and Linux, not just Azure, also on premises, things also can be fully automated. Before we jump into Azure portal to understand about Azure automation, let's understand about the core key components of Azure automation. So we have three core components that are part of Azure automation. The first one is automation account. This is a service account that gets automatically created when you create the Azure automation account, or you can create later point also, and this account will have full rights on your subscription level. Let's say it will have the co-administrative permissions. The reason being, for any of the resources, it will go and interact with that resource and it can do the automation job. Let's think in other way, like you have a SQL server, maybe in your on-premises in the olden days, and to run that SQL server, we used to give the service account to start that service, right? Similarly, you have your automation account that also a kind of service account, which will have the full rights at the subscription level as a co-administrative permissions, and it can go and interact with any of the Azure resources. On top of it, if you are running some kind of scripts, that's again, when I say scripts, what you're going to do is you're actually contains the here, if you see here, automation workbook. So this automation workbook will contain the scripts. When I say scripts, it can be a PowerShell or Python based. It supports two type of scripts. So that will contain some kind of modules and that complete shells, whatever the scripts that are there, that will go and contact your Azure resources, and to run on against on those Azure resources, the automation account will be used. Let's say you have a virtual machine and you wanted to stop that. So to stop that service, the virtual machine, you need to have the account and there should be a script. So the script comes from the automation runbook just to stop that virtual machine, and when it is executing, it will actually use the automation account, and the charges would be applied only for the execution time. So it's a pay-as-you-go model, like only the execution time would be charged for you. And to execute that, you need to have something called a worker, right? You need to have a base where it's going to execute your script, right? To execute that script, you need to have a base. So that's called the automation worker. So you have two types of the automation workers by default. When you're trying to automate any of the scripts with the help of the scripts, when it is executing, it actually uses Azure Sandbox. A sandbox is the backend. Actually, it will have some kind of a virtual machine kind of thing which uses to execute that specific script, right? And if at all you want to have your own runbook worker, in that case that's called the hybrid runbook worker. We call it, you can create a environment where all of your automation runbooks will execute from that place or from that specific runbook worker. So that's called the automation worker. In that, we talked about the three core components of Azure automation. Let's jump into Azure portal and try to create an account, automation account. So when you're trying to create an automation account, all the things would involve. So we are going to do that. Let's jump into Azure portal and try to create automation account. So you can search as automation account. So that's the account that needs to be created. So click on add, so that you can create the automation account. Click on add, and that would open up a new blade. So this is where you have to give a name without any space, and then you have to choose your resource group and location. And this is very important that you can choose the automation account type also. So I'm just giving here a name, automation account, and 01 maybe, yeah. And then I have chosen already my resource group and location as issues. if you see, and create run as account. That's the important one. If you just go through this link, it explains about all the required things and the permissions that has been given. So let's take as yes and click on create. That's going to create a automation account. Once the automation account is created, you would be actually getting here. If I try to refresh or the page, you see here one is created as the automation account, other one is the run as account is getting created. So two things got cleared. That's good. So if I just quickly refresh, I will be getting as an automation account, and within this automation account I have the accounts. If I just go to somewhere in the account, so you see here this is my run as account, and this has all the service principles. So this service principle is important key where it's going to actually create within the Azure AD. When we create any service account, here it's going to actually create in the SPN, that's a service principal name, and also it grants the permissions as the contributor. So that's good. And once we have all granted all these permissions, we can straightforward and go and use the automation account. So for that, I'm going to actually take you along with the complete blade explanation of the automation account. Once we have created automation account, we can check out the navigation within this blade. You see here you have the option for configuration management, which can track your inventory, and this is for change management tracking, and this is what the DSC we call as the state configuration. With the PowerShell, you can monitor a particular state of that resources. If the state becomes changed, you can have a control on that, and this is where you're going to actually use the updates for update management for Windows servers. You can do the update management with the help of automation account, and we have a dedicated link for this. Or dedicated videos I'm going to create, and you can check out the next upcoming 2 more lectures. And coming back to the process automation, this is where you have the runbooks which will be used to automate your tasks. So these runbooks will use your configuration or the scripts that are actually part of either anywhere from the Python packages or maybe from the PowerShell gallery. So you can create and import your own runbook, and these are the default runbooks that has been created for you, and you can use any of them to use it. And coming back to the jobs are nothing but if the task is run, it will give you whether this job is success or not. And this is a collection of runbook gallery. So you have multiple things which are available, third-party people as well as the Microsoft Script Center and the PowerShell gallery. These are the source, and you can import any of the PowerShell gallery based scripts. So these are ready-madely available for you. Let's say I wanted to stop some of the Azure virtual machines, so you can do that directly. So if I just click on it, it's going to tell you, hey, I'm going to do this automation, and you can actually just click on this to get a more view on what's happening on this. So I'll just maximize this and see what happens. So if you scroll up and down, so it's going to actually run the storage account, and then it's running account and connecting to Azure. It is getting a single VM and getting all the VMs, and then merging. You want to stop, it's going to stop, and there's a notification also if it is already stopped. So this is a flow actually, and this was created by somebody else, and you can use this script. So for the creation part, we are going to have a look on it in a minute or so, but this is going to be a little bit of overview within the Azure automation blade. And this is a hybrid worker where we can use this as a base instead of the sandbox. You can create your own hybrid worker group, and you can run it from there. And then watch tasks, which gonna show you a watch tasks will allow you to watch any of the events that actually triggered. You can check out here, and this is where the shared resources, like you can schedule any of the workbook to be run on a specific time zone or specific time, so that that specific script gonna execute on that scheduled time. And coming back to the modules, let's say you're talking about either PowerShell or maybe Python that also needs some kind of modules to run it, right? Definitely. Let's say if I want to work with a storage account, I need to have Azure.storage provider, RM provider, and this needs to be available. So if I have this module, then only it's going to work anything to do with these providers. Like I can create here get Azure storage command, all these commands gonna work if I have this module. If at all these modules are not available, you can import or you can add, you can custom build whatever the modules you want which are coming out of your script. Let's say you created a script and that has some kind of package as a module, you can import it. Actually, you can add those modules so that it's going to work here. And similarly, you can also do the packages. In the Python, we talked about instead of the module, we call it as a packages. So you can actually import or you can add those packages here directly. And coming back to the credentials, so these are the credentials that are going to use it, and later point you can use these credentials to attach for any of the scripts that are going to run. And connectors, this is nothing but your run as connection. That's what we talked about automation account. So what happens is when we try to create the storage account, if you remember, we talked about creation process. Within that, we have chosen as a specific account to be created. So this account in the backend, it's going to actually create the Azure service principal within the Azure Active Directory, and that will have the permissions as the co-worker permissions on against of your subscription layer. And these are the things like jobs, runbook, hybrid, all these things. Let's try to create a simple runbook that will give you an output, and we can test it how best we can actually create our own runbooks. So that being said, you can actually click on the runbooks and click on create runbook and give it some test name for this demonstration purpose, like AZ exam demo, and then runbook type. So this is where you can choose either PowerShell or Python or graphical. So in our case, it's going to be a PowerShell, so I'm going to choose as a PowerShell. So this is where you can directly put your all the PowerShell commands so that your PowerShell commands can be executed, and you can also have a look on your output view. So you see here you have the commandlets that are available. These are the PowerShell commandlets that are available based on the modules that are already available with the help of your automation account. Let's say I want to work with Azure or storage. I can simply click on that and then it's going to actually put all the required commandlets here. And if you see other runbooks, if I want to include, I can do it here. And coming back to the assets like variables, connections, so connections are nothing but your run as account. In this case, all that can be configured here within this script. It's a simple click on 3-4 dots and then simply insert. It's going to actually insert the required commandlets or whatever it is. So in our case, I'm going to write a very simple PowerShell command like write-output with the simple hello world kind of thing, so that I just wanted to show you a sample script that is when you test it, it will actually show the output as the hello world. So just to test this, I can go here and do the test pan so that it's going to actually test. We have not yet actually published. The difference between the publish and the testing is it's still in a draft. Actually, it is in edit mode, not it was not published. So when we publish, it will be available for anybody, can be used, or it is readily available mode publish. So I'm just clicked on the test one, and then this is where it's going to actually show the output. If you see here, if I thought I have any of the parameters or run settings, I can choose here and I can click on start. This would actually show the output here. So let's test that by clicking on the start button. So now it's actually running. If you see here, this is where actually you can run the refresh button to view the output. So in our case, it's actually running in the backend. It takes some time. So this is where actually Microsoft Sandbox comes into the picture for the execution. So it's actually in the backend, it's actually executing from the sandbox. Once this is executed, I should be able to see the output of hello world. So I can see refresh, see I got the output as the hello world. So let's say you have developed some of the scripts, you can actually go back and have the script to be included so that it can run any kind of automation tasks on your virtual machines or on your Azure resources. That's how it's going to work. I hope this small demonstration would be helpful, so that what you can do is you can actually publish like that, and then you can actually, once it is published, you can, if you want, you can click on start to redo the work so that you can do it, and you can link to a schedule so that actually schedule on a specific time. Let's try to add the code so that the virtual machines can be stopped. For that, what I'm going to do is actually I will be using the existing runbook that we have created. So I'll just edit, and if you see here, this is what we have written, and we got the output earlier. Now I'm going to write for the connection. I've written here the simple code as the connection. If you see here, the connection is going to be use the automation account name for the run as connection, and I'm going to connect to Azure AZ Connect. So if I type as the AZ Connect, I need to have the AZ Connect module within my PowerShell or within this specific to automation account. So we'll have a look on that in a minute or so. But for now, if you see here, what I'm trying to do is I'm trying to connect to my service principal name, which is associated within my Azure tenant, AD tenant, with the application ID, and I'm going to actually connect with the certificate which is used in this case. Thumbprint is the certificate ID, and then I'm going to actually connect AZ context and going to use the subscriptions, and then this is where the command's actually going to run. Like I'm gonna run AZ VM, that's a get Azure VM for my resource group name called Azure Automation demo. This is a resource group name. Within this resource group name, whatever the machine's name, select as the name, and this is what the name was selected. And for each of the virtual machine, when we selected the computer names or the virtual machine names for each of them, I'm gonna actually stop it passing a command called stop against to my resource group. That's the resource group name, and I'm actually forcing them to stop it. So that's a command which I'm using. I would actually copy paste this code to you within the resource section of this lecture, and once this is gonna actually connect, I'm gonna actually look for all the resource groups. Within that resource group, whatever the virtual machine is there, I'm going to actually force stop it. So let's test this actually by clicking on a test pan. So when I click on start, it's going to actually show me the test results. It's still running, and this is actually running on the backend of the Azure Sandbox. If at all you want to change it, as we talked earlier, you can actually go for the automation worker, which is again the hybrid worker can be actually configured. But let's jump into the portal to see what happened. So I'll just refresh the job streams, and you see here this has been successful and successfully completed without any errors. So let's go back to the edit mode and say publish, so that it's going to actually publish to the actual version. So this has been changed. If you just go back and see, the code exists now. So I'll just go back to this, and now I can actually link to a schedule. That means when I try to link, it's gonna actually have a schedule. So this is the schedule. On that specific schedule, it's gonna actually run. So in this case, demo VM stop is the schedule what I'm gonna give here. You can give the name that you wanted here. I'm actually giving here as a time, let's say 42, and time zone, whatever the time zone you want to run this. You can also run the recurrence. So in my case, I'm actually choosing the local time zone and click on create. This can actually create a schedule. And parameters, if you have any of the parameters for VM name, all that, because in our case we haven't created anything parameters, instead we have actually hard coded. So click on OK. That's ready for this. Now this runbook is now linked to schedule, so within this schedule it's gonna run. You see here demo-vm stop. It's the status is on. So let's go to our virtual machine within that, and you see this virtual machine already in a stop state. I'm gonna actually start this. Now the virtual machine is in a start state, so let's wait for a minute or so to get that schedule to be triggered, so that we know that this virtual machine gets automatically shut down. Post to the schedule, I should be able to find out here the job status. And if you see here, these are the previous jobs that are 2 were completed and 1 was suspended, and it got failed too, and 1 got suspended. All that information you can actually check out here with the more information. So for us, it's actually we are in the VM stop state, and this is still on an on status, and we are waiting for that schedule to be triggered any point from now. In the meantime, you can actually check the PowerShell module. So in our case, actually we are using AZ.accounts and AZ.compute. These are the 2 modules we are using. In case if you don't have, you may have to go to the add module, or just go to the browse gallery and type AZ dot, and then you would be actually getting the accounts as well as the compute specific. So here you can type this AZ accounts and then simply import this library from here. And also for AZ compute, you can type as a compute, let's say compute, and see you have the AZ-compute, and import this module. And this also has a dependency also. So when you're trying to import, AZ accounts also should be imported first, followed by AZ compute. So these 2 were needed to run those PowerShell commands. So that's why my PowerShell is gonna work. In case if you are getting an error as those commands are not relevant or not found, you have to actually import those modules. And in your case, if you're writing your own script, make sure that those commandlets are actually part of which module, and try to import it. Mostly it will be available from the gallery, but it's not imported all the PowerShell galleries or the PowerShell module, so you just have to do the import of those modules. Apart from that, if you're trying to import any of the existing modules, let's say if I just go back to my runbooks, I should be able to see here some of the runbooks that we created, or some of them are default. Let's say these are actually default, and remaining things we actually created, right? And if we want more of them, which is a ready-made solution, so in this case we actually created this AZ exam-demo, which is used for in terms of the creation for the virtual machines to be stopped, right? But if you just go to the browsing gallery, there are 2 types of the galleries you have. One would be the script center source, other one would be the PowerShell gallery. Apart from these 2, you can actually create your own runbook, right? Let's see what we have here as the source of this. Let's say in a script center, you have here automatically you can actually use start Azure V2 VMs. So if you want to start the Azure V2 VMs, you can do. You also have stop start Azure virtual machines and a schedule shutdown startup. All that workflows or based things already available and written by somebody else, and this has been downloaded so many times, so you no need to actually create it. Most of them are available. Let's say I want to work with maybe something called Intune specific, autopilot specific. Let's say I might have here something related to the autopilot, or if I want something called update specific, I might be already using something is available. You see here turn on VMs and update management specific. So you have here already those specific modules are already available, and you can use them. But make sure that those specific runbooks might require additional PowerShell commandlets that should be part of your module, and you might have to use them. Let's say I want to run update management, turn on VM. So what I have to do is I have to actually use this. So this will be, talking, this is an example script for update management, pre or post actions required for thread. So let's say, before VM starting and shutting down, it's actually using some kind of jobs that actually executing. So all I have to do is import. That's going to import. Later point I can link to a schedule. So if I just go back to my here, if I just refresh here, I should be able to see here that newly update module. You see here, this is just in the update one, update VMs, which is a new, and turn on VMs with the update. So all I have to do is, once I've imported, all I have to do is I have to click on edit and say publish. So if this is actually working, this code, and then you can actually test it by starting, so that, or you can actually link to a schedule, very similar. This is my link account, and I can use the parameters, and you need to know that what exactly these parameters it is asking from the script. So if you are aware of it, that's good. If not, you just have to edit and understand the script, what it is asking, all that, then you can actually use this existing runbook. So that's how you can use the existing things. And also, if you're trying to create your own workbooks like runbook, you can actually create your type of PowerShell or Python or graphical. Even the PowerShell workflow, even graphical PowerShell workflow also can be created. It's been more than 15 minutes now. Let's have a look on it, how this is working. So we did actually test it with the AZ demo, and let's go to the schedules and see this has been expired. The schedule, if you want to reschedule, you can reschedule, but we are not going to do that. But we would be actually looking at the jobs. So you see here in the jobs, there are two jobs that were executed. The first one is the 22nd, which was completed as the welcome output, if I'm correct. Yeah, hello world. And the second one, which we have completed just now with the current timestamp, and you see here this has executed successfully like we tested. As per the similar testing, it has been successful. Now let's go to actual virtual machine and have a look on, so whether this has been successfully implemented or not. So I'm just going back to that resource group and clicking on that specific virtual machine, and you see here this is in a stop state. So it was successfully stopped my virtual machine without any problem. So my Azure automation account was successful in terms of stopping my virtual machines within that resource group. And I can find here the status. If you see here, there are 3 of them are completed successfully, and you can find the same thing from here, 3 of them. Remaining 2 are failed, 1 got suspended. So that's what we got it out of our runbooks. So that explains the same job statistics here, right? And I hope this entire lecture is useful. I know that it's a lengthy, but it would be easy to understand as long as you start some kind of practice within this Azure automation account. And upcoming lectures, you can check out the update management here for the updates, and also you need to have the log analytics services that will be created. And I'll catch you in the next lecture. Thank you for watching this. Hello and welcome back. In this lecture, we're gonna learn about the extensions and the configuration management of your virtual machines. As you know, as of now, we have created multiple virtual machines, and we know that how to create the virtual machines. But have you ever think about how can we go for a standardization of those virtual machine settings? When I say settings, we are talking about multiple things like applications. Let's say XYZ application should be automatically available when you create the virtual machine, or maybe antivirus, or it should be automatically taken care by backups, or your application settings. Let's say a specific settings must be configured automatically on your virtual machines. Also your operating system settings, or maybe your application monitoring and your infrastructure monitoring. All these things, how best you can actually go for a configuring the configurations. So this is where it actually helps us, the extensions, as we have talked a little bit in a different lectures about the extensions. But in this lecture, we're going to actually have a look on the extensions. When we go back to any of the virtual machines and you have the extensions here, when you click on the extensions add, you are getting actually different extensions that can be added. Some of them are actually coming from a third party, some of them are a common things, like you can go for a custom script extension to perform some kind of a script that should be doing automatically, might be a batch or maybe a PowerShell script that you wanted to execute on your virtual machine as soon as it's created, or maybe once it is created, when you're working, you wanted to automatically execute this specific script without actually you log into the virtual machine, or you can run some kind of PowerShell scripts also. So when we talk about these kind of extensions, this will make our job little easy when we talk about any of these kind of settings that to be automatically configured. This is where Microsoft introduced extensions, right? So within these extensions, there is a dedicated extension called PowerShell DSC, or desired configuration. You see here, you have the PowerShell desired configuration. This is nothing but a specific state called desired state, we call it. So within that specific state, the virtual machine always should be available. If not found any of the application, or maybe application configuration or monitoring agent or backup is not configured or anything, it's go ahead and it will be automatically doing that. Of course, for that you need to actually create your script that will actually do all these things. So the script language would be PowerShell. So you're going to actually write a normal PowerShell script, but in a standard format called PowerShell desired state configuration, or DSC we call it. So within this format you are going to create it. But let's talk about the real world. In the real world, we have different extensions. When I say extensions, these are from a different companies like Chiv or Puppet for the automation of any kind of configurations that we talked in the previous slide. All these settings or applications can be fully automated with the Chiv or Puppet. And the major advantage with the Chiv and Puppet would be you can actually do from a single console. Whereas with the DSC, you have to do it each machine layer, and these two are considered as the enterprise. In fact, the DSC also, but we see mostly either Chef or Puppet would be used in our enterprises. Let's also talk about the custom scripts for a minute, about the benefits and the drawbacks. When we go back to virtual machines and the extensions, you can actually use the custom scripts also. This is where actually you are gonna show up the where you have your script. So there's no local domain credentials needed when you actually added your custom scripts, and you can directly use these scripts as it is executing in the backend with the built-in agent which is executing on the specific virtual machines. And the major drawback would be for this would be you must have to enable on at each VM level, and also it needs the internet access if you're using any kind of GitHub or a Blob storage for scripts. You need to actually show up them, and these scripts can be actually pulled from your storage account or directly from the GitHub, and these are relatively slow in terms of the execution when we compare it with Chef or Puppet specific configurations. So you have these options. So let's focus more into the DSC. This is a sample DSC script. That's nothing but again a PowerShell based, like you see here, this is a configuration which is talking about who is doing or what is doing, and then the node which is going to be a local host, and the features which is going to be installed Windows features called IIS, and they will ensure that whether it is present, and the name is web server. So within these features, whether this is a simple PowerShell script that you can easily understand that Windows features, whether IIS nothing but a web server is present or not. So that's what it's going to monitor, and that's what it's going to be ensured that it will check for the present option. Hello and welcome back. In the previous lecture, we learned about what exactly DSC, that's a desired state configuration, and how that works. As we have seen a simple PowerShell script that will actually compile in the backend or in a DSC server. A pull server will be there, so that's where it's gonna compile, and it converts into MOF. That's a MOF file we call it, and that MOF file configuration will be enforced to the virtual machines to find that specific desired state configuration. If the configuration is not found, we can set settings to completely configure not just the monitoring mode. We can say that autocorrect automatically, and also we can overwrite any kind of other modules, and then if really needed that configuration to be completed with a reboot, we would actually force them to reboot also. So this is what we have actually configured, or we can configure with the desired state configuration management. And also post the configuration, we can actually keep on configuring to the monitoring so that the state should be always the same state. Let's say if the state changes, it again gonna apply the configuration and it's gonna autocorrect it so that you always be complaint state. So that's how you're gonna actually configure and get a desired state of your configurations for your resources. Now we are talking about how to apply this desired state configuration. So as I said, there are a couple of ways. The first one would be you can straightforward go to your extensions, and from here you can actually apply a DSC configuration directly. So this is where you are actually applying by going here from the extensions. Just like any other extension, you can actually use the PowerShell desired state configuration extension, and other extensions also can be installed if really wanted. For example, malware, anti-malware, or maybe HP specific, or maybe some other antivirus. If you are looking, you can go in that way and you can get it installed the other extensions. But for now, we are going to cover within this lecture about the DSC configuration. In case if that extension gets failed or not able to provision properly, you would be actually getting like this as a failed status, and later point if you want, you can go ahead and uninstall that specific configuration. So this is the first part, or the first option that you have, that you can directly use extensions to configure it. But as we do day-to-day operations within Microsoft Azure Cloud, we actually work most of the time with the operations blade. Within these settings, you have your configuration management. So this is where actually you're gonna enable. This is the first option. So when I say first option, you can actually enable here directly the desired state configuration, which has a pre-requirements of log analytics services that needs to be enabled, and also definitely log analytics workspace with a region should be enabled, and followed by you have to actually choose the automation account, because that's the key here for the automation account, and that would actually go ahead and execute all these scripts to get a proper output for you. So you would be actually working here in automation account. So this is the first or the second option of what we can enable it. But let's see the settings. As we talked earlier, these settings remain same, like refreshing interval from the pull server and the configuration mode frequency to validate. And are you going to just monitor or just applying settings, or you're going to autocorrect even the settings? So these things, so the major difference between apply and monitor, you are going to applying and also monitoring for any kind of configuration changes. Let's say when you applied, the computer name might be as per your standard, but later point it has changed. So you can simply monitor how many times that's actually not following your standards. And coming back to the apply, you just apply, but you don't monitor that. So the settings, we think that, or we assume that the settings will remains the same state all the time. And coming back to the apply and autocorrect, it's going to apply, even it's going to automatically correct the settings. And if really needed, you can override, you can do the reboot, and also post to the reboot also you can monitor. So these are the settings that you can do it. So as we talked, the first option directly you can enable from the extensions. So either you do it from the operations settings here, or from automation account, it's one and the same. The reason being, it needs the pre-requirement of few things like log analytics services and automation account. So in the next step, what we're going to do is we are going to actually work with the automation account. So what we do is we actually search here and we create the automation account. Like we have here 2 accounts for DSC specific. So any of this account, if I take it example here, I can go to the state configuration here and configure the required settings for those machines or those nodes all together by composing. I can do my own configuration, compile, all that. So this is the idea what we are trying to do it. So the first demo what we do is we would actually cover with the virtual machine add-on directly from the extensions. Here, so once you added actually extension, it will be actually showing you like this as a provisioned successfully. And the next step, we are going to work with the next video. Altogether, we are going to work from the operations and the configuration management. And from here you can check whether how many of the configurations are applied and their reporting status. Let's say if it is consistent, that's fine. If it is not consistent, it's going to tell that, hey, this machine is not consistent. All that configuration, we're going to do it. We have not yet jumped into the configuration of this part. The next 2 videos we are going to cover on these topics, because you can do it in a multiple ways, and we would start with the virtual machine extensions followed by directly from the automation account, or we can also do one and the same within the same video, directly doing from the here, which is the configuration management directly from the virtual machine. So we're gonna work on those things. So let's catch on that lecture. Until then, thank you very much. We'll catch you in the next lecture. I'll use the Powershell script that this is the file which we have, and I'll put it into a folder and then zip it. And this zip file I'm going to actually upload to my storage account under container by creating here a scripts folder, and then simply upload the content. This one I wanted as a blob anonymous read so that I can actually upload and I can read it from anywhere. In normal way, as we talked in the blobs lecture, we talked about private. When we go with the private, it will be required your SAS access keys and other things. But since it's a lab, actually I'm trying to upload with anonymous also. With a blob and create. So this would create a container called scripts. Inside this, I'm going to upload a folder called IIS -DSC. This was got already zipped, so I need to zip and then upload it. So what would happen is the zip file contains your PowerShell script. So in the back end of Microsoft, what it does is actually, in the back end, it's going to be compile within the virtual machine to a MOV format, MOF, and then it's gonna execute whatever the script is doing. So if the script is trying to do the IIS installation, it's gonna actually install that. So that's what the idea. So these steps will be MOV, compile, all other things will be taken care by Microsoft Azure. You no need to worry, but all you have to do is you have to upload in a zip format, and later point take that URL, and this is a URL. So since I made it as anonymous for the blob, so I'm just copying this and keeping it into the memory as it is for now. And later point I would be actually going back to my virtual machine. So in this case I have a virtual machine this is a virtual machine. So I'll just start it, and in the back end what I'm going to do is actually I'll go back to extensions as we talked earlier. Within this extensions, I'm going to add DSC. This is a PowerShell desired state configuration, DSC. And for the DSC, what happens is when you go ahead and create, it's actually going to install the agent, as well as it's going to ask you, hey, what's a module that you wanted to execute with the help of DSC on that specific virtual machine. Let's say if you have already uploaded, you can actually show that. So the uploaded file can be shown from the storage account. So in my case, I have the storage account, the scripts, and make sure that the zip file, whatever you have, you can actually give that. Now, as a next step, what I can do is I can simply give the version of your DSC, whatever is gonna execute. So I'm going to give as the 1.0. If there is any upgrade options, and for the module name, what you will be doing is here you'll be giving the script which is inside your zip file and the module that you wanted to execute. Let's say if I open my script, I have given this as the module name. So this name I should be able to give. So why we have to give this is this code is going to be executed. Let's say you might have another module which talks about file server or maybe some other configuration that you might have to give that name. So in my case, this is the one which I wanted to give it. So I'll just give here the name.
And also we can, if at all we wanted, we can use a PSD1, which is a compiled format or the DSC format, and version it's going to compile in the backend with the WMF latest version it's going to use, and this is a version that we need to give like 2.8.0. 2.8.0 is the latest, so that you can give that value here. This is basically for the DSC's extensions version, so you can give that version, but in my case I'm just giving as 1.0. the reason being, anyway, it's going to be a test, I'm not going to continue further, but you can give as a 2.80 and click OK. So that would actually create the custom extension for us with the help of the script. So this is how you can do it on a single machine point of view. If at all you wanted to directly add even extension along with the your custom files to include for monitoring for the DSC state. Now in the upcoming demo we are going to actually check out automation account with the help how best we can configure this DSC and get more benefited instead of configuring here one by one. You will have a central location of your all the configurations, and from there you can monitor and you can do the configuration. So let's wait for that lecture. Thank you.
Hello and welcome back. This is going to be another lecture on PowerShell DSC with automation. So within this lecture, what we are trying to do is we will be creating one virtual machine, and also if you have not gone through the automation account, how to create, we will go through automation account, and also we would be creating complaint specific scripts to be importing into the automation account for DSC, and also we will use the library or the PowerShell third-party tools or third-party source for DSC configuration, and we will use them to configure the PowerShell DSC. So within this VM we will try to do two things. The first one would be the computer rename, and the other one would be the simply installing the IIS. If the IIS is not found, it's going to install the IIS application. So that's the agenda within this lecture. So let's begin. So as a first step, we need to create a virtual machine for performing the testing. So I'm going to fast forward this entire creation of virtual machine because you might be already knowing how to create virtual machines. So I'll just go with the default options in order to create the virtual machine. And once the virtual machine is created, if you have not gone through how to create automation account, we will be showing you here once again how to create the automation account. So just search for the automation account and click on add. That would actually start the automation account wizard. So within this wizard you can actually give the automation account name and your subscription and your resource group and your location. Also make sure that you have actually selected your run as account here, because with this account help you're gonna actually execute all the PowerShell commands on those machines. So this run as account will have the full permissions on your resources, including your subscription. So it's like a co-administrative account, and we did talk about these in the automation account specific lecture. But within this lecture, if you're not sure how to create automation account, this is the one step how to create automation account. And also in the previous lecture we talked about how to create the pre-requirements to be meet for a DSC configuration, like creating log analytics services and automation account. So just wanted to cover here one more time. So you need to have the log analytics services, and also to store that you need to have the storage account. At the same time you need to have even automation account. So this demo would actually cover the automation account with respected configurations also. So now we have successfully created almost the automation account. Here if you see here, this has run automatically created. Here if you see, as part of the creation wizard, it is actually created a run as account, which is nothing but in the backend as a service principal, because on top of this we can grant permissions for any of the Azure resources. That's why it's a service principal, we call it here. And also automation account has been created. As a next step, I can refresh and find the automation account that was created, and this is just show you here how it looks like. And I'm not going to use this automation account, but anything to do, you actually go to the configuration management from your automation account and select the state configuration for DSC, and this is where you can add the nodes from the nodes section, so that this donut graph would give you the good results related to the failed, in process, or pending, or completed, or unresponsive, all that information. And also you can filter here the status based also. And the later point, you can actually use the configurations to create the configuration and whatever the configuration that you are actually importing. So like, let's say when you compose or when you try to import any of the configuration, it can be a PS1 or maybe a default files which are already created by somebody else from the gallery, and you can use those configurations and they can use it. In case if you created any of the script that you wanted to monitor, then that actually have to go for a compiled configuration. So compiled is nothing but a step where it's gonna actually convert your PS1 to MOV format, MOF. So if you have worked with MOF files, that's good. Otherwise you can learn more about the MOV format files, which is nothing but a managed object format. Your entire WMI provides in the format of MOV files, and it gets compiled and then it gives you as a WMI repository. Similarly, all this, the things which would happen in the backend on a pull server or the DSC server. So you don't need to worry about that compilation or MOV comp or whatever the compiling process. So all you need to know is, yes, that script which is working should be available with you, and then you can import it. So that way you can assign later point that configurates to the required nodes from here. So that's how it's going to work. So as part of the demo, what we do is we would actually import other one which is readily available from the configurations, and that's nothing but the computer rename script which is already available, so that we can have a look on it. And based on that, in the previous lectures we did actually create it with respect to the IIS. So the same script, we are going to reuse it here and try to import and do the configuration, so that the virtual machine, that's a VM post to the reboot of the VM computer name changes, it should actually also have the IIS. So that's the plan. So let's jump into those actions. So once you got this information about the account automation thing, and what I'm going to do is, since I've already covered in detail about the automation account respected in the previous lecture, I'll just skip it here by giving whatever this little bit of introduction like we said earlier. So what I'll do is I'll actually go to the virtual machine of that DSC VM01, and then we can configure from there. But if you see here, if I want to add it like this, I can just go and connect it. So that way I can connect it. So let's go to the virtual machine and do the configuration from the backend. So this is my virtual machine VM01, and what I'll do is I'll simply go to operations. So just wanted to quickly tell you about operations. So within operations you have everything. What exactly operations? So your day-to-day Azure job activities would involve into the operations. Let's say, are we talking about the Bastion services to connect, or auto shutdown, or backup, or disaster recovery, or guest host updates, or inventory management, including the change management and all that, including the configuration management, which is nothing but in this case DSC, and the policies and run commands if you want to run any kind of other commands. So that's why very important the operations tab within this settings, operation settings, all these are very critical. I hope you would be going through it. Now let's jump into the desired configuration state. So as we talked earlier, you need to choose, you can create directly from here also. If you're trying to do the first time, you can do it from here, but if you have already created automation account as well as the log analytic workspace, that's fine. Otherwise you can directly create from here by enabling. So what we are trying to do is we are selecting the location and log analytic workspace and automation account, and then I would be clicking on enable. But let's also understand the agent settings. So coming back to the agent settings, we do have here a refresh intervals of 30 minutes. So within 30 minutes of the time, it's going to actually go and get the policy settings, and also configuration. It's going to check every 15 minutes here, and also here the configuration mode, which is very important here. We are just applying for the monitoring, not for any other settings. And also you see here it's going to be override any kind of modules if it is found, and if it is required a reboot of that virtual machine, we can take this checkbox. And post to the reboot, do you want to continue, or you want to just stop this configuration? So you don't want to monitor. So in my case, I wanted to go for continue with the configuration. That's what I wanted to take it. And you can simply enable this so that you get the consistent configuration settings for your log analytic services. With the help, you can actually get it a desired state of your virtual machine. So we talked about this, and let's also have a look on by enabling this. So it says that, hey, this is not error. Actually, if you look at here, it takes actually 15 minutes of players time, so that once we have that timing is completed, we get a good view, very similar to the automation account view that we would be getting here. So I'll just completed this, and let me refresh here, and I would actually get a different view altogether. So let me show you here, and this is what the configuration management view. Now very similar view, but if I want, just I can apply here for this virtual machine a specific settings directly from here. Else if I want to manage multiple machines, when I click here, it actually takes to the automation account. So let me click on the configuration management and show you here the summary. And if I as soon as I click on that multiple, it's actually taking me to a different automation account that was created when we enable. So this is the automation account, and you see here the node was automatically added. If not, I can actually go ahead here and click on add to different node, and that node also check the compliance level. So because we didn't apply any kind of DSC specific configurations, it's actually showing as a compliant at this point of time. And I can view the reports and the more detailed information. So if I just go to the automation account, so earlier we created this account. Now this account was automatically created by the visit of that virtual machine. So that's good. Okay, but it also created a different resource group. So that's why it's good to create yourself a automation account and then put it into your right resource group. That way you will follow the life cycle of the objects. So here there's no job task, because we talked about earlier different things about the automation account, but within this lecture we will focus to the state configuration. That's nothing but a DSC. So within DSC, what we are going to do now, so I'll explain here the more settings about the DSC. So within this blade or within this configuration, you have a nodes. Let's say I want to add an additional virtual machine. Right away I can do it from my automation account by selecting a different virtual machine. Let's say this was added earlier. Now I want to add this as a new virtual machine. I simply click on add and say connect. That's going to actually connect it. So the current status is not connected. So if I do a refresh in few minutes, it's going to be connected in a minute or so. So click on connect, and this is where I am gonna specify what kind of configuration to be validated. So what we are trying to say is, we are trying to say, hey, you go ahead and install the DSC extensions. That's good, but also monitor with these any of these settings. In fact, we didn't created all these baselines. These baselines were offered by Microsoft for different operating systems. In fact, mine is the 2019. I don't have a 2019 here. If you see 2008 R2, SP2, and 2012 R2, 2016. So it's going to fail if I apply any of them. But that's okay, just for the testing purpose. I just wanted to show you on DSC VM02, because that's purely a test machine for me. And we talked about all these configurations earlier, but we didn't talk about all these two extra configurations, which is also available when we try to add the virtual machine from that wizard also. Like one would be the configuration mode is just to apply monitoring, or just to apply and leave the monitoring, or you want to autocorrect. So this is very important. Autocorrect, what it does is it's going to apply this DSC configuration, and then if the settings were not found, it's gonna push those settings. Let's see, if I look for a computer name as a specific computer name, if this computer name is not found, it's gonna rename to that specific computer name. So that's called autocorrect. Similarly, if I'm looking for IIS configuration on this node, if I don't have IIS configuration, it will simply check here. If it doesn't found, it's going to push those settings. That's what auto apply and auto correct. So that's a setting that's very important here. We can use that specific setting. Node configuration, as I said, if you just use 2016, that's fine maybe, but it's not going to work actually anyway this machine. But just wanted to give you an idea how you can add those additional machines. Once you added these machines, the remaining things are same. So let me click on here, okay, to add. So that takes a minute to add. Here adding is nothing but a connecting. So if I just go back to this VM01, you see here this VM is already connected status, because as part of the wizard we did actually connected. And you see here we were not configured much settings. Let's say the configuration is not forced, not rebooted, appliance just the configuration mode is unknown, and all that. So we want to recorrect this VM01 also. We will be doing that in a minute or so when we actually apply our settings. So I'll just click on a refresh so that it should actually show in a minute or so here. That's fine. And if you see here, if I don't want this machine to follow this wizard or should be part of this DSC, I can simply click on unregistered if I really wanted, or I can click on assign node configuration, and then whatever the configuration we wanted to apply, that can be applied like we did earlier for VM02 DSC-VM02. What we did is we applied this one 2016. We can simply select and click OK. That would actually applies that specific configuration, but I don't want to do that actually. So I'll just cancel these things here. And now if you see here, once we apply here, we can get it here as the in progress. So as soon as I am actually looking here the complaint status, that's why the filter is not showing, but the graph is showing that the pie bar is showing. So what I'll do is I'll actually filter everything, then I should be able to see one with the baseline is applying. So that's how you can actually apply a later point. So that's good. So let's go for configurations, and you see here all these are default. That's why it is compiled. That means it was compiled to MOF format, and it was available with the automation account repository. And if I want, I can click on add and simply add my PS file. So I'm going to do that in the next minute or so. That's the second part of this video. And you see here, whatever the configurations we applied, these were applied for how many nodes are showing here. Let's say this is actually for 2016 server. So that was actually showing for one node. And you have a very good configuration settings that can be used from a gallery. So gallery will offer you a lot of built-in configurations done by third-party vendors. It can be a Microsoft in this case, and it can be somebody else also here, right? So anybody can offer these scripts to monitor a custom configuration. For example, this is for monitoring a state of a domain controller. This is for PowerShell endpoint new configuration. This is for PowerShell endpoint remove configuration. So different guys offers different scripts. So if it is really useful for you, you can go through it. Let's say I want to configure IIS configuration. You can view it and use them. Let's say if that gives you some idea related to the Windows features, you can edit little bit and change them by importing and exporting later point to modify accordingly, and then you can develop that on top of it. So that's very important and very useful, the galleries. So you look at a lot of other galleries or automations are available, and you can use any of them. These all are related to the DSC configuration. So if you are completely new, that's fine. You can straightforward go ahead and use the galleries. But if you're new, you want to do it, then you have to click on compose and then add it, or you can click on add and do it. So when I click on compose, actually this is where also it's going to show you a little bit of configurations. That's a repository specific things which are already compiled and available for you. Let's say this is for Windows feature set, this is for optional features to install, and if you see here, this is where computer rename. So I wanted to use the computer rename option. So let's say whatever my computer name is, I wanted to set a specific configuration of that. So you see here the code also you are able to see. This is a simple PowerShell code which is readily available. On top of it, you can do the modification. So here you think about anybody if it's trying to hide their source code, it would be hard for you. But here with the DSC, the thing is like here, you know the source code of any of your configuration settings, and you can work on it if you know that programming skills or the PowerShell skill with respect to DSC. So all this code is available. So what it is doing is it's simply doing the PSDSC run as a credentials it is trying to do. It depends on that, and it's going to do the rename of that specific computer. Simple thing. It's just renaming the computer on a local. Since it is mentioned as a local, it's going to do that execution on the local computer. I hope it's easy to understand here about this. So if I just log into this virtual machine DSC-VM01, this VM has the computer name called DSC-VM01. So let's have a look on the configuration here. Configuration management, and you see here there's nothing has been assigned at this point of time. So that's good. So I can even apply from set desired configurations also, or if I just click on here, as you know that it takes to the automation account. So I'll just go to the automation here, and it's actually asking here to enter the parameters. So you see here earlier we saw the computer name is DSC-VM01, right? Now I'm gonna give the computer name as here whatever the name I wanted, like DSC-01 example, and this should run with the credentials. Let's say you don't want your run as account to be used, but you want to use some additional credentials, then you can actually add it here. That's a use case of this new credentials, but in our case we are not going to use that because our run as account has full permissions. And also it depends on the computer rename functionality. So click on save. So in a minute or so it's going to be appear here, and it was not showing as a compiled. So that's very important to compile. So just click on that and you see here a button called compile, and it is even in fact try to compile, but it's the queue. So what I'm going to do is I will compile on my own. Let's say you want to export this configuration later point, you're going to export to PS1 or whatever the format, and later point you can import it. And you see here the node was into the green, and it's still showing as a 0, and it is starting, and then if it is going to maybe suspended state, you should be able to do it. So in my case it's in a suspended state, so I want to compile. But while I wanted to compile, I'm gonna give here a new computer name. So this is going to be the new computer name which is going to be applied for that node. So let's enter the name. In this case the same name I wanted to enter, like DSC-01. It's a simple name I wanted to use. So, and this is required. So who has written as a required is by the developer of that script or DSC. So in this case it's required, and we did actually compiled. Now in a minute or so, if I just try to refresh this, and I should be able to see here under nodes count here as the compile. So I'll just refresh. In a minute or so it should be applied. So now it is actually compiled. I'll just go back to my DSC VM01 and I'll try to connect in between and see how the computer name is there, because it's not yet applied. So we have not yet applied. We made the script to be available and imported, and it is readily available and also compiled, but not added as a configuration to this virtual machine yet. So we're going to do that. Before that, I just wanted to show you on this virtual machine what is the computer name. So let's type host name to find out the computer name. So it's a DSC-VM01, and you see here it's compiled now by this time, and node count is 0 because that was never applied. So now I'm going to add, click on add button here, and then select your node and say connect. So you see here reboot, all that was definitely needed for you. As you know that if we rename the computer, you need to reboot the computer to in fact to apply. So I have to change this configuration also. So what I'll do is I'll gonna connect it, and this time I'm going to change, and here it's going to ask me, hey, what kind of configuration you want to apply. You can choose here either the computer rename or something else. So in our case, definitely the computer rename, and the frequency is the minimum is the 30, and here also the 15 is the minimum. You can't do lesser than that, but you can change to the higher value. And applying the monitoring option, I'm going to actually apply this monitoring option, and then 30 is fine and the 15 is fine. Let's go to apply and monitor. Should be actually autocorrect, right? So as we talked earlier, we wanted this configuration that the rename should be automatically autocorrect. If the computer name is not matching, you go ahead and correct it, and if really needed, let's reboot that machine by taking an action. So that's what we're going to try to do. So we're not doing the apply, we are applying with autocorrect and allowing the module to override, as well as the, if really needed, we do the reboot of the machine. And actions for reboot would be continue configuration. So that means post to the reboot, it will actually keep an eye whether this configuration is as per the desired state. If not, it actually recorrect by using these values. So that's what it was there. So click on OK. So it's gonna do in a minute or so automatic reboot of my machine, and I'll just pause and wait for 15 minutes or so, because that's the interval time, and it will pull up those values. And you see here the extensions 2.8 and 15, all that has been changed now after I do the quick refresh. And that's good. So I'll just go to my virtual machine and give a second, or before that I can actually refresh here, and you see here it's already complained by this time, so I think it should be already change the value also of the computer name, but we'll give a minute or so because it has to go through the reboot and other steps. And you see here the count is changed to the node 1, the computer rename option, so that's good. So it's still doing in the back end that step for the VM configuration side. Okay, and that being said, I'll just go to this virtual machine. I just logged into this virtual machine, and you see here the virtual machine name has been automatically changed to DSC-01, and I'll simply type host name also. It has changed, but it does not have IIS yet. So what I'm going to do is I have already created a folder, and inside a folder there's a PowerShell script, with simple PowerShell script, which we talked in the previous lecture about IIS. So the same one, I'm going to reuse it to install web service. So in this case, you see here, it will ensure that .NET ASP 4.5 as well as the web services both should be available. If not, it's going to be installed automatically. That's the idea. So I'll just import this configuration. So for that, I don't need to do even the zip and all that things. I can simply go to Azure portal for the automation account and then import from the configuration. So here I'll just have to select the compose configuration, and then within this, if you see here compose, what we have done is earlier with the rename option, right? Compose, but this time we are going to actually select configuration and add node and then the configuration file. So in this case, I'm going to give the path of my PS1 script, which is mentioning here in this case PS1, and I can give here maybe a description if I really want it, but that was actually imported if I just give the PS1 as a web server. So that's a configuration name which was there within the PowerShell. So if you see here, if I just do a quick refresh also, web server configuration is available, but that was not actually showing anything. So let me refresh. I'm sorry, that was actually overspreaded because of the text zooming. So you see here, it's still the computer name is fine, that's a green, but web server, which is still 0. And you remember, whatever the configuration we import for the PS1, as we talked earlier, this must be compiled, right? So we have to run this job to compile. So I'm going to do the compile. Once I do that compile, in the backend, it's going to create a MOV file. So you see here, I just waited and it has refreshed. It's completed the node configuration. Now that's good. So now I can apply this specific configuration. You see here, there's no errors, but I can apply this configuration by clicking on add node and select my VM01 maybe. In this case, because I just wanted to stick to VM01. And this time I'm going to connect a node configuration. I'm going to choose here web server specific and autocorrect. If not found, you go ahead, override and require reboot. If so, it can do the reboot. Click OK. So that would actually do the configuration for you on IIS. So after maybe a 5-10 minutes or maybe 15 minutes of time, I should be able to get it. So if I just refresh here and see the configuration, which is in this case here, it's a complaint, but if I just do the refresh, I may have to wait. Yeah, you see here web server.local, post to the refresh, and that's good. So what we will be doing is, if I just go to the server, to the same server, and click on manage, add roles. Just wanted to show you here, okay, or you can just go to the admin MMC also. But here, if I try to add, by this time already added web server IIS features. So this explains the advantages of your DSC. So DSC, when it is integrated purely with the Azure Automation State configuration, it is an Azure configuration management service. So this is going to be allow you to write, manage, compile your PowerShell DSC configurations for your nodes. It can be in any cloud or your on-premises data centers. So this service is really helpful in terms of the DSC resources, assigning configurations with the PowerShell gallery, or it's going to give you a lot of features. And this is not just to Azure cloud. You can extend to AWS EC2 instances, or to your on-premises virtual machines or physical machines also, by utilizing all these existing gallery files also. Or you can write based on these galleries. Like you will be getting the known source code, right? So either you are getting from the here, or you can simply import and then edit and write it in a other way of writing. Maybe if somebody wanted XYZ feature, you want to add some other additional features, you can do it, feel free to. So that way you can actually manage the state configurations fully automated. So this is where it's going to use. I hope this entire demonstration is useful for you. Thank you for watching. Hello and welcome back. In this lecture, we're going to work with managed VM images. So let's say I have a virtual machine called VM01, and within this virtual machine, I have installed some of the applications here, and also some of other configuration has been done. Let's say within this virtual machine, I have installed a server role called IIS has been already installed, and within this IIS I have some of the settings has been configured properly for my application. And if you see here, this virtual machine also have the proper IIS has been installed, and I'm able to, when I try to browse this website, I'm actually getting a proper response saying that, hey, my website is opening with a specific web page. So that means I have a working web application which was hosted in this virtual machine. Now within this virtual machine, I wanted to capture this virtual machine for creating as VM image. When we say VM image, we normally create virtual machine directly from Microsoft Marketplace. Instead of that, I wanted to create a virtual machine with the settings that have already created manually and I wanted to recreate this virtual machine along with the same disk so that I can reuse multiple times. So I no need to reconfigure my applications, my VM settings, my maybe web application, whatever I have within that virtual machine. So that way you can quickly spin up as many as virtual machines you have or you wanted. So that's about the managed image. So to do that, you need to have a virtual machine. So in our case, I have a virtual machine, and also I have configured the web application. Let's say that's my custom application that must be exist on all of my managed images or managed VMs in future. So I have already created this virtual machine with this web application. That means the desired settings has been already created. As a next step, I need to actually do the Sysprep. So just open Sysprep. So that would actually open up Windows System32 Sysprep folder. Within this, you have an option called Sysprep. So you just have to select the generalize. So that's going to remove all the generalize option of that hardware binded settings for that VM. So once that's done, you can shut down this virtual machine by choosing this radio button, this drop down called shutdown. So click on OK. So that's going to actually generalize, and it's going to shut down this virtual machine in any point of time. So once this is generalized, I need to deallocate my virtual machine. Once I have deallocated, I need to capture this virtual machine directly from this capture step here. So I'm going to do that. So I'll just wait for a second, or I'll quickly fast forward the video so that you can see what's happening on this virtual machine. Now, if you see here, the virtual machine has been disconnected. That means the RDP has disconnected. The reason being it has actually going to the shutdown state. So once it is successfully shut down, I need to actually deallocate. So I need to click on stop so that this virtual machine gets deallocated. I'm going to deallocate by pressing stop button. So this would actually stop the virtual machine by deallocating the processor and RAM, other things, so that it will free up. Once this is done, I can actually go ahead and capture, and while capturing I should be able to give a name. Now the virtual machine is deallocated. Now let's go ahead and do the remaining steps. In the first step, what we have done is we created a virtual machine and we installed the required configuration and applications, everything working fine, and then we have done the Sysprep with the generalize option, and then we choose an option as a shutdown. Later point we stopped it. Now it's time for us to capture so that this image will be available for us for future utilization. So I'm clicking on the capture button, and I can give here a name of a proper name that would actually suitable. So in this case I'm gonna refer as a VM01 image which was captured so and so date, and the resource group that I'm gonna keep this image, and I can even create a new one if I want. I can directly here and put it there. And also if you take this checkbox, what would happen is it's actually you need to take this checkbox so that it's going to delete the VM01 which we have actually used for capturing. So this VM going to delete it automatically, and once that is deleted, if you're sure, you need to give here the VM name. So in my case that's a VM01. In your case, if it's a different VM name, so you have to give that proper name from here. So that you know that it's going to delete it, and make sure that it's going to delete, because post to this capture wizard, that VM is no more used, no more useful, even because in the backend actually it runs a Sysprep, means the generalize option, so it will start entering or asking for the WOOB experience. So definitely Azure cannot give you the WOOB experience for you, and that would actually useless. That's why we're going to delete that virtual machine, and we are sure that we have to give the virtual machine name also here. So click on create. That's going to actually create, and this process takes some time. So until then, I'm going to actually pause this video. If you see here, it is actually created the image with this name, and also it has deleted the VM01. So if I just go to my virtual machines, I will not have anything with respect to VM01. And you can see here there's no VM for the name called VM01. And if you see here, the virtual machine has been already deleted called VM01. Now let's try to create the virtual machine out of our image which we have created. So this time what we are going to do is, instead of we actually choose from images from the library, that is from the marketplace, we actually use the private image here. So I'm just clicking here so that the private image is my items. I can see here my VM, that's a VM01 based out which we created. It's actually listed, and you need to give the VM name. So in this case I'm gonna actually use called VM02 example, and I'm gonna use my recent virtual machine size, and I can choose here a different account, the password that needs to be given here. So I'll just type here the password, confirmation password. I can choose the required sizes here. If that is not suitable, I can use any of the method, virtual machine, select, and then I'm going to choose a license for Windows Server. If I have, that's fine, otherwise I can say no. And the remaining things remains the same, like anything like networking, all that. And here for the management, so this is very important, like in the advanced, let's say you might have a complex scenario where you wanted to start some other applications to be installed or to be configured once the virtual machine is started, or once the virtual machine is created out of this image. So in that case, actually you would be using custom extensions. Let's say if you just click on the extensions, you have your Powershell custom script can be run, or any of the custom script. This is where actually you can run some kind of a custom scripts. That way you are actually using something to be automated. Let's say you wanted some application to be executed, or a backup to be started, something to be done for your custom images, you can do that. So that is the most used common extension when it comes to the custom images, and you can give the tags, and let's review it. And if really this is okay, then we can actually click on create. So that's going to create a new virtual machine for us with the VM name 02. Now the VM has created, and just for your information that in case if you're trying to create more than 20 at once simultaneously, the custom images are not supported. So just that's the limitation that you have. Otherwise it's the normal, and you can use this file to download and try to connect it. I'm gonna use the connection with the user ID and password that we have given as part of the wizard. And now once I connected my application, that's the custom applications that I have already created, let's say web application in this case, should be already configured and should be ready for us to utilize. So that way the custom images are most useful in terms of having the same consistency of your applications and the settings. You can reuse them as many as VMs that you can create it. So let's open up the IE Explorer, opening Internet Explorer here, and I'm going to click as clicking on localhost. That should actually load my web page with all the custom settings that were configured earlier on my base image. So now I have the virtual machines which was created out of my base image, and that image has whatever the application that is already available now. So that looks good, and I hope this entire video lecture is useful for you. Thank you for watching this. And just to conclude what we have done so far, we created a virtual machine and we installed the required application, and then we have followed the Sysprep mechanism with the generalize option to shut down, and then deallocated, and then deallocated with the stop button, and then captured and gave the name. And then when we are trying to create virtual machine, we used a different name, and when we created, we got all the applications back. That concluded the demo for this lecture. Thank you for watching this.
Hello and welcome back. In this lesson, we will be looking at storage products and services and how they can be used and how they are different from each other. Also, we will be looking at storage, account, and other things, how they can create at the high level. To begin with this, now we can see that within this cloud models, you have infrastructure as a service as well as the platform as a service model.
So within the Microsoft, you have all these possible cloud storage options. When we say disk, file, blobs, and queues and tables, all these are the options you have.
Let's have a look on the disks. So the disk type when we use is, if we have a virtual machine, if we want to attach the hard disk, so definitely it would be a disk type of the storage we would be using. So that means the virtual machine's images will be used or stored for disk type of the storage. And there is a storage type also. We have a premium storage. When we say premium storage, it means that you have the space is coming from your SSDs. So as you know, solid state drives is the higher IOPS, that means input output operations per second can be done in the SSDs. That means you're getting really higher performance compared with your normal disk. So that's where disk comes into the picture. Now when you compare with the files, the only difference is that Azure Files goes a little bit above disk. That means it's not only just for the scaling purpose, it can also store the files as well as the disks. So with Azure Disk, we really are limited towards to the virtual machines, and that's especially for the disk images. But with Azure Files, we could store disk images or any kind of file and folders that we wanted to store. We can store within the Azure Files. It's a full-scale system, and along with that, Azure File Storage supports SMB protocol, which is just a protocol to connect your files and like a share folders across your computers. And it gives you an REST API that can use to access our data in a programmatical way also. And that means the Azure Files is a really great option for any legacy applications that you wanted to lift and shift as it is to migrate to your cloud. It's a best option because it's very common for legacy applications to rely on writing things to file systems or file shares instead of using or having to update your applications as you move into the cloud to have it write everywhere or somewhere. you can have it to continue to write files and shares just to use Azure files to make that file shares available in the cloud. We have disks and file shares which are coming from infrastructure as a service option, and these provides a kind of framework for very low level data operations like saving and mounting virtual machines and the disks and implementing full file systems within Microsoft Azure cloud. Now we also have these three different platform as a service options, as well as we have storage blobs within this. This is called the storage blobs, and also tables and the queues. Now, when we talk about the blobs, a blob is one of the more commonly used storage service, and this blob service or blob storage is mostly optimized for storing massive amount of unstructured data. For example, a text data, it can be, or binary data. So it's ideal for serving some kind of images or documents directly to a browser, or maybe storing files and distributed access, or streaming videos, audio files, or even storing of files or data for backup and restore in case of disaster recovery or archiving purpose. Even storing data for analyzing by an on-premises or Azure hosted services, the blobs are the best suitable things. If you're a developer, you know that you wanted to store some files as the input output mechanism. That means a JSON file kind of programmable structures also can be stored in your blobs. That might be a text file, that might be aggregated reports from other systems. So that's where you would be choosing blob as one of the type that you wanted to store. Whatever your data is, you can store in your Azure blobs. That's what we can as a conclude for blob. But this is different from database when you compare with the database, because in a database you can do a search against to your databases. Since we can't do a search because it's a completely unstructured data against to the blob, you can't do. That's why it's different. You can't compare a blob with its storage. Blob storage with SQL database storage. That's what I wanted to convey here. And it's better for other types of data other than the database. And that's really good at is storing, for example, metadata, images, PDF files that we just talked about in a minute or so. If you want a little bit more granular control over your data that you wanted to serving, will move into Azure tables. Basically, because the Azure tables you can go for a structure kind of thing, a little bit of structure. Why I'm saying is a little bit of structure, because it's a little bit more granular. You have the control over your data that you are saving, and you can move it into Azure tables. And this is within NoSQL database, and actually more closely resembles a real database than your Azure blobs. Let's have a look on it. If you see in this slide, we have a table. The table is a normal row kind of thing where you can actually kind of in a query can be, you can do a kind of in a query, but it's very similar to your relational database in the backend, but it uses a different type of technology, and it's called NoSQL, which represents non-relational database. And with Azure tables, because of this different way of handling data versus how you do it in your SQL database would do it, we get a massive auto scaling capabilities within Azure tables, because we can query for a larger number of data, whatever it is coming out of in a non-structured data. For example, if I take it up a Twitter feeds, which comes as a non-structural, so if something happens in the event, we don't know where to put it in a SQL database, because for a SQL, again, you need to have some of the columns in a proper way, because it's a structure way we call it. But here with a no structure, it doesn't matter what kind of a structure it is coming. We simply put it there, and we can query any point of time from the Azure tables. That's where Azure tables with a new NoSQL database. So that means there's no relationship for the data which is coming. So it can be easily analysis, and it's massively dynamically you can scale up based on the load, and you don't have to worry with any of these files solutions about managing servers or auto scaling of any of that. It's all handled by Microsoft from the Azure side, and our data is always available as quickly as possible to us. Now with Azure Tables, we can also support for petabytes of data, and petabytes in a layer about a layer above also, altogether like terabytes. So that you can think of this in terms of scaling of thousands of terabytes of data or millions of gigabytes of data. There's a lot of room to grow within Azure Table. Just to again conclude, with the Azure Tables, we get more structured data to save our data. And with the blobs, we could have only unstructured data. We could have some images, some PDF files, or some text files. All different sort of things can be stored into the blobs. But with the tables, there's a little bit more structured data can be stored. We define some columns. It gives us an ability to query our data. Unlike blobs, we can actually query any of the columns inside of your storage tables. With the capacity act, it does really act more like a database than your blob storage. Now finally we have Azure queries to be discussed. So let's talk into the queries. So queries is the first time out as a FIFO kind of product. To understand about Azure Queues, actually it provides a cloud messaging between your applications and components. In designing applications for scale, application components are often decoupled so that they can scale independently. Azure Queue Storage delivers asynchronous messaging for communication between your application components, whether they are using in cloud or on the desktop or on your on-premises server or maybe on your mobile devices. Queue Storages also supports a similar flow. For example, anything to do with your storage here, whatever we talk about in Microsoft Azure Cloud, you take as a storage, that actually stores something called an account. So every storage is related, and it will be on top or inside in a storage account. So let's take, you have a big computer normally and you have all the hard disk. So if you ask where's your data is stored, you will say that I have it in my hard disk, which is in this machine. Similarly, whatever the things are you're trying to store, that all goes under a storage account. So the storage account will have different types. For example, here disks, files, blobs, tables, queues, all that are possible with the storage account. Let me show you what I'm trying to talk. So this is one of my storage account which was created. I'm going to show you in a minute or so, or maybe in upcoming videos. But if you see here, this is my storage account. Inside this you have the under containers. A container is like a folder kind of thing, which is you can create. Inside that you will be storing VHD files maybe, and that's where blobs will comes into the picture. And this is the SMB services or file services which we just talked about it. And we also talked about the tables, like in the tables you can create a demo or AZ-900 table, and just give it to your developers, and they would actually feed the tables in a right way. And let's also talk about other one, which is we are talking about. The last one is a queues. So when we talk about the queues, actually you would be talking about to store the queue services. Let's take an example. Before we jump into example, let's understand this process flow. So everything is related or inside your storage account. That's you got it, and inside that you have disks, files, blobs, tables, queues. So now we are talking about the queues. So within the queues, what it's going to do is it's actually can be used to store and retrieve messages, and the queues messages can be up to 64 KB in size maximum, and a queue can contain millions of messages. It's not one or two. It can have you can have millions of messages. Queues are generally used to store list of messages to be processed asynchronously. That means let's take an example. Let's say you want your customers to be able to upload pictures, and you wanted to create thumbnails for each picture. You could have your customer wait for you to create thumbnails while uploading the pictures. And alternative would be to use a queue, because when a customer finishes their upload, write a message to the queue in a programmatical way and say that, hey, now we have an Azure function retrieves that message and says that, hey, queue is now created, and create a thumbnail within this. So now what would happen is each of the parts of the processing can be scaled separately. That gives you more control when it is actually tuning your users. So here, for example, the same thing, like you ordered maybe a customer orders something in his restaurant, and or maybe he's getting some thing that must be on top of it to be printed a label. In that situation, whatever the first comes, it goes to the queues, and then it would printed that label one by one in a right order, and you would be getting that messages can be printed with such kind of numbering, which as a label. So queues are very useful when it comes to the developers, because developers use mostly on the queues, and the when I say developer, DevOps guys definitely use the queues. That's where it's going to used in cloud. That concludes the queues. Now we'll just jump into the storage ties. So what exactly the storage ties and type of the storage ties what you have. So now with the storage tie, that means you're paying some kind of premium if you use those ties. So you have hot tie, cold tie, and archive tie. That means when you're trying to access, actually the storage tie means when you try to access your tie, which will allow you to store in your blob, or maybe in your data, whatever you're trying to store in the blob. So you can choose a cost effective manner. It's not that you just dump it as it is, because you will get more benefited when you actually store in a right way. So that's where you have the hot tile and the cool tile and archive. So what it means actually, hot tile means, let's understand hot tile. Hot tile means it is basically optimized for storing data that is accessed very frequently. So you uploaded the data and you would be retrieving from the blob all the time, very frequently. In that situation, we would consider as hot tile, so that it's not going to charge much. But let's say you have a cold tile. That means optimized for storing data in a frequently accessed and stored for at least 30 days. That means every 30 days you would be maybe retrieving within 30 days tile. That's called cool tile. Then it would be costing less. But if just going for archiving, what would happen is options, it is basically optimized for storing data that is rarely accessed. Maybe let's take for your HIPAA compliant policies, whether that machinery data is stored and is available years of time. So what you do is instead of you stored on your on-premises, you simply move it to HIPAA compliant archiving tile. So it just goes there within your Azure cloud, and there you can retrieve whenever the auditing comes. You can show them that this data is available in the archive tile. So when I say archive tab, it is optimized for storing data that is really accessed and stored at least for 180 days with a flexible latency requirements. That means when you order to retrieve, actually when you're trying to retrieve archive data, it doesn't come immediately. What would happen is they takes at least 2-3 hours or 4 hours of time to make it available, the data. Because what would happen is in the Microsoft, in the background, they put it into the archive in a different storage to retrieve that. It takes some time. So it's a planned information. If you're trying to retrieve it, you can put it into the archive tab, but it's very cheap in fact. But when you try to retrieve, it's going to charge the cost. So whatever you put it there, it might not be charged much, but when you try to retrieve, it's going to charge you. Now you understood hot, cool, archive methods. Now, as I said earlier, all these storage methods are associated one account. So it's not your it's the account, means it's like thing that is a one box. We call it as the account. So that's called storage account. So that means when you log into Azure portal, that's your normal account. Inside that, when you go into the storage, that means the storage account will be there where this kind of data can be stored. So now let's talk about where we can enable this cool and hot tile. So only hot and cool access tiles can be set at the account level. The archive access tile isn't available at the account level. Hot cool archive tasks can be set up on a blob level. So you can set it at the blob levels. And data in the cool access tag can be tolerate slightly lower availability, but still requires high durability, retrieval latency, or throughout characteristic similarity to hot data. For cool data, a slightly lower availability service level agreement and higher access cost compared to hot data, and acceptable trade-offs for low storage cost. So this when it comes to the storage, for the archive storage, it actually stores the data offline and offers the lowest storage cost, but also the highest data rehydrate or access cost. So you should know all this kind of pricing. If you put it into the archive and you frequently retrieve it, it's gonna cost you higher than actually hot tire, because a hot tire is which is useful for data that is in active use or expected to be accessed, read from, or write into very frequently, whereas the even the data that is staged for the processing eventually migrating to cool access tier. That means whatever the data is there, it is slowly can be migrated to the cool tier if you're not actually using. So let's understand a little bit more about the cool access tier. The cool access tier has lower storage cost because you are going to access a little bit not frequently. That means it's going to charge you lower but higher access cost when you try to access compared with the hot tier. And this tier is intended for data that will remain in the cool tier for at least 30 days, because you might be think that you have example scenarios where cool tier can be used, for example, short-term backup and disaster recovery data sets, or maybe older media content not viewed very frequently. Any more data is expected to be available immediately when accessed, actually, or large data sets that needs to be stored cost effectively while more data is being gathered for further processing. For example, let's take long-term storage of scientific data, or maybe telemetry data from the manufacturing facility unit altogether. So then you would be using the cool tier. And let's understand a little bit more about the archiving data. Archiving tier has the lowest storage cost compared with any of these three, but it is the highest when it actually retrieving the data compared with either cool or maybe hot tier, as we talked. And data in the archiver tier can be several hours to retrieve the data. Data must be remain in the archive tier for at least 180 days or subject to an early deletion charge. While a blob is in archive storage, the blob data is offline. That means it can't be read or written or modified, whatever your data stored in archive tier. And to read or maybe to download a blob into a blob in archive, you must first actually rehydrate into an online tier. And then you can't take a snapshot of your blobs in archive storage even. However, the blob metadata remains online and available, allowing us to list the blob and its properties. For blobs in archive, the only valid operations are you can get the blob properties, you can get the blob metadata, or list your whatever the data is there in the blobs, or maybe you can set the tier, blob tier, or copy blob, or delete blobs. These are the hydrated blobs data. You can do it on archiving. Example uses would be long-term data, which we talked about, like HIPAA compliant or whatever the data tier. So long-term backup and secondary backup or archival data sheets. Such situations you would be using the archive tier, or maybe original raw data that must be preserved for a longer time, even after it has been processed into final usable form. And you have some kind of a compliance or archival data that needs to be stored for a longer time, and it should be hardly ever access this kind of data. That's what storage tiers. So So when it comes to accessing that specific data either from hot to cold, because you need to convert to retrieve that data, or you can move data from hot to cold or hot to archive or cold to archive. So what would happen is when you try to move the data, because if you want to move, that means you need to retrieve that data, or maybe you have to write or read. So in that situation there would be charges would be applied. So let's talk on that. When actually blob is moved to cooler tier, that means hot to cool, or maybe hot to archive or cool to archive. In this operation it is going to build as a write operation. Okay, that means you're thinking that it has to be write operation, whatever the size of the data is that would be charged. And with the write operations per 10,000 and write per GB charges of destination tier would be applied. So if you're moving to destination to cool charges will be applied. Here if you're moving from cold to archive charges will be applied for the write operation, not for the read operation. And when you move this blob directly moving from a warmer, this is called warmer tier, that is from archive to cool or archive to hot or maybe cool to hot, the operation is built as a read from a source. That means from here you're reading. So this is where actually the cost will higher, because these are you're retrieving from the archival. That means it's a costly, but the storing data is cheaper, but retrieving is a costly. So it's going to charge for you in terms of the source is in this case cool, archive and cool. So these charges would apply as similar as the read operation of per 10,000 and data retrieval per GB based. So two additional charges you need to calculate when you're trying to retrieve. Okay, let's jump into the replication. We talked about the cool hot archive, but that's gonna store somewhere in some physical location of Microsoft data center, right? What happens if that data center, how it is secure? I'm not talking about this physical security. In case of disaster or in case of something goes wrong, to be really able to get that data, or our company gonna impact. So that's where the replication comes into the picture. So this data can be sent to a different location, like we learn in the beginning of resilience and have a high availability purpose, like different two regions, availability zones, all that can be applied for this storage. Yes, you can apply that. That's called the replication side. So we're going to talk about that specific replication here. So you do have here, as we talked about the premium, it's not just the storage, you also have the replication premiums options. Like again on top of your storage account, you can set it to some kind of premium options, and you do have actually a replication mechanism, something called LRS and ZRS, GRS, and read RA means read only GRS, and GGRS and RAGGRS. So you have this option. So we are going to talk in detail this so that you would be understanding this table end of the replication. So let's understand and let's go back to this table. Also, this table also a little bit tricky table, and this is my table, which I actually called as a cheat sheet. If you're trying to do something related to the replication of your storage account, this cheat sheet can be used, or this would definitely address a lot of questions that comes in your exam also. That's why I call it as a cheat sheet. And this is very similar to this, but it has more information. But let's also have a look on actually the replication side. So now when we look at the storage replication redundancy options, what are they? So the first one would be when we talk about the storage redundancy, what exactly is this? So Azure Storage account is always replicated to ensure you have the durability. Let's understand Azure Storage redundancy. So what exactly this? So Azure, as you know that Azure Storage account is always replicates to ensure the durability and high availability purpose of the data which you are going to store in that storage account. The storage account, what would happen is the storage would copy your data to that is protected from a planned or unplanned events, including chances of hardware failures, maybe a network, or maybe power outage, or massive natural disasters in that case. So it's gonna store into different places so that you can choose or replicate your data within the same data center, or maybe to your journal, or maybe you can store the data within the same regional, or maybe across geographically separate regions, let's say south to north or north to west, or completely different altogether continental. So you can do that with the help of storage redundancy option. So this is very critical. That's why to understand about storage replication redundancy, and you have multiple options so that you can meet your SLAs in case if you face an unfortunate situation. So there are total 6 different redundancy options. Let's talk on each of them. The first one would be the LRS, we shortly call locally redundant storage, which is shortly LRS. So this is one option. So let's talk on more about the LRS, and then we can jump into the second option here, like generalize, and then we can go for geo-redundant, and we can go for read access geo-redundant, and we can jump into geo-zone redundant. And again here this would be the last option, which is a read access geo-zone redundant storage. So as you move from here to this side, it is gonna give you higher redundancy options. Let's move to the LRS. So this LRS is the low cost data redundancy. Why I call it as a low? Because it would be the locally, so it's not gonna take your data to other data centers, definitely. So it's going to be locally redundant, and that means it's going to actually store 3 times your data within the single data center. So when you create by default, if it would be normally LRS would be the normal default one, but when you create your storage account with the default settings, that means the data you create or you store, it's actually storing in 3 different data centers. And you are going to get the higher percentage, that means 99.119 of durability of the objects in a given year. And also this can be used in an example scenario, like if a data center, I'm going to talk on these upcoming 6 or whatever the slides, we are going to talk about in unfortunate situation what you're going to do, and how the data is impacted, and what would be the best solution for that, so that you would better understand what exactly either LR is, or maybe zone redundant or geo redundant, or geo zone redundant, whatever the redundancy options you have. So now in this example scenario, there could be a fire or maybe a flood affected, so that data center itself gone. That means you don't have a storage which can't be recoverable. In that situation, your data is gone. So you should be know this fact actually. This is the same case, right? If you have on-premises also, you lost your data center completely because of an flood. It's gone. Your business is down actually. So you need to think for other options. So with the cloud also the same way, because you are getting LRS as a cheap, and that when you're trying to store the data in LRS, you should be awaiting that, hey, I'm okay for 11 nines in a given year, and also the data center itself, it goes down, I'm okay to accept my data lost. So that's what the agreement you are making with Microsoft. That's why what Microsoft says is, hey, if you're choosing LRS, hey, just try to mitigate this kind of risk by choosing any of these options, possible options. Again, for every possible option, there is a risk associated, but again, the risk when we say risk, actually we are talking about 11s also will increase these 9s also. So let's have a look on how and when data actually writes. So when a write request happens, that means you're saving a text file or whatever the file in your storage, actually it's going to write to LRS account, then returns successfully only after data is read 3 times within a single data center, because LRS means it's a single data center, but it's gonna actually write in a 3 different place. Now, also you need to know use cases to be understand, because as I said, why and the kind of risk, and also use cases we would be understanding about LRS and upcoming all kind of redundant storages. So the use case is if your application stores the data that can be easily reconstructed if data lost occur. You may be opt LRS, otherwise don't go for this LRS model. Now some applications are restricted to replicate data. Even in that situation also we can use, like maybe you can't choose a geo, or the data must not go from that region or from that country due to governance requirements. In some cases you can choose this kind of situations, this LRS option. Again, you can pay regions across with data that is replicated for GRS account, maybe in another region, if at all your governance allows. Otherwise you can simply choose this LRS model. The next one would be the zone redundant storage. So what happens is with the zone redundant, it's going to actually copy to 3 different clusters in a single region. So if one goes down, like north, east, south, within one region, if you have 3 different clusters, it's gonna you have more redundancy in terms of within that region. So failing a region is highly not possible, but it is possible, yes, definitely. But you have the high redundancy compared with LRS. When you compare with LRS, ZRS or zone redundant storage is more redundancy. So what would happen is each storage cluster is physically separated, because we're talking about 3 different. So these 3 different clusters are separated, and there is another one would be the availability zone, AZs. So it's availability zones and ZRS clusters within it. So it is autonomous, includes separate utilizers and networking features. So it's not easy that it can go down. Now if you think about how it's going to write, the writing would be happens actually on 3 of them, then only it gets replicated to the 3 different clusters. So once it is written, it's going to give us a confirmation as, hey, I have written the data to 3 different clusters. So when you actually store your data in the storage account using ZRS replication, you can continue to access and manage your data files if any availability zone becomes unavailable. So because we have 3 different clusters, and each of them placed into different availability zones, so it's not so easy to go down. ZRS provides excellent performance and low latency. ZRS offers the same scalability targets to the LRS. You may have to understand what happens when a zone redundant becomes as unavailable. So when GRS or ZRS goes down, what are the situations you can say that ZRS is not replicating, or maybe you don't have unavailability. So let's understand that. So the data is still accessible for both read and write operations when if a zone becomes unavailable. Or within the zone, if it becomes as unavailable, still it is available for read and write operations. Microsoft recommends that you to continue to the with the best practices for transist fault handling. These practices includes implementing retry policies within your application, so that if one goes down, automatically it would take the it would actually there would be a latency which will say that, hey, it's not available. So within your code there should be a retry mechanism, so that it's gonna actually retry, because we're talking about a zone is becoming is unavailable. That means the zone undertakes the networking updates. So that means there is a DNS which is involved in the background. If one zone goes down, or one becomes as unavailable, another zone should take over in the between, in the milliseconds, or maybe in that seconds of time. Your DNS within the Azure DNS might have to be replaced or do reporting properly. So your code might have to say that, hey, you have to give it a retry. So that's how the DevOps or the developers has to consider to develop their code. But these updates may take your applications, if you are accessing your data before the updates have actually completed. But it is high luckily it can not happen actually, these kind of situations. But generalize may not protect your data against regional disaster when multiple zones are permanently affected. Let's say for that entire region there's a huge cutover of internet, or maybe power, or maybe resources are down due to greatest flood that was never affected. In that scene, that entire region becomes as unavailable. In that situation, you might have to look for other recommendations, especially GRS, which is nothing but a zone redundant storage. So for protecting against any of the regional disasters, Microsoft recommends to you may have to go for the geo redundant storage. That's what about the zone redundant. Let's move to other one, which is the geo redundant storage. So GRS, we talked about the GRS is the recommended method. So let's look at a geo-redundant storage. So what would happen is geo-redundant is designed to provide you 16 nines durability of a given period of time within that year. So replicating your data to your secondary regions is a hundreds of miles away. So we're talking about within the same region, but here now it's going to be cross regional. That means hundreds of miles away from your primary location. So if your storage account has GRS enabled, then your data is actually durable even in case of a complete region outage happens of that entire disaster. Let's say there was all of a sudden there was an attack on one of the country, even though that entire region data is available for your customers, so it's not going to affect the entire region. So that's where you can go for geo redundant storage. So this is kind of in a situation where I would recommend if it's required. In fact, if you're choosing for the complicated and critical data, but there could be situations we never know, the geopolitical issues, and then they kind of war kind of situations. The best option would be the GRS, because if something goes wrong, also you have other data center which is already available, and it's gonna service your customers, so there's no business down. So if your storage account has a GRS enabled, then your data is durable even in case of a complete regional outage or disaster in the primary region isn't recoverable situation. So if you opt for the GRS, you have the two related options to choose. One is here GRS replicates your data to another data center in a secondary region, but the data is going to be available to read only if Microsoft initiates a failover from the primary to secondary region. That means it's the action taken by the Microsoft, not by you. So because Microsoft also have an SLAs for that entire region, since that entire region is down, they can push the data to take it from the secondary region. In that situation, you can get the data. But here there is another option, which is you have your read access geo-redundant storage. This is another type of GRS, which is read access. So what would happen is GRS in this situation, read-only access GRS replicated your data to another data center in its secondary region. So that means it's going to provide you with the option to read from a secondary region. You can read from a secondary region regardless whether Microsoft initiates failover from your primary location to your secondary region. So there's no dependency on the Microsoft. It's automatically the data is available. So this is more costly compared with normal GRS, definitely. So let's go back to other options, which is again building high available Azure storage applications with your zone a redundant storage, which is a geographical based zone redundance. So in this, it actually goes for the high available compared with the ZRS, because in the ZRS what we talked is here zone redundant is just the normal one, but here you have an option to actually go for geo redundant, which also contains your storage account would be replicated with Azure availability zones in the primary region, also replicated to the secondary geographical region for protecting from your regional disaster. Each of these Azure region is paired with another region within the same geography, so together, so that you get higher availability with this kind of things, with this kind of pairing actually. Geo zone redundant storage account, you can continue to read and write. Operations can be continuously can be done if availability zone becomes unavailable also, or maybe if it goes even unrecoverable situation also you will have, because it's coming from other zone altogether, and it is paid all these geo redundance to another geo also. So additionally, your data is also durable in case of complete region outage or disaster. This is very similar to the previous one if you see here, GRS. So if that goes on also, you have this option. And also you're going to get the same kind of 69's durability of the objects in a given year, and it offers more scalability comparatively LRS or ZRS or GRS or read-only GRS. So you can optionally enable read access to data in the secondary region with read access geo zone redundant storage. So this is the highest level. And you can Microsoft, what they are recommending is, this is the highest level what they are recommending for any kind of applications which you need a consistency and durability, high availability, excellent performance. Then it comes to the resilience of your disaster recovery. This is the best option. If you're looking for how the data is actually when the data is getting replicated, or once it is written. So here you have the three availability zones. Once it is actually written into the first place, then it's gonna replicate to the secondary regions, or secondary regions which is in hundreds of miles away. When data is written to the secondary region, it's further replicated synchronously to 3 times within that region locally, redundant storage. So you have multiple times the data in a multiple places you have the data, so it's highly impossible to lose the data. I hope this makes easy for you about the storage and the storage redundancy options and storing the data in a different places. So let's go back and check for our sheet which we talked so far in a cheat sheet. So let me jump into that slide. So if you can look at here, this sheet actually talks about how and what kind of replication options you would get it when you try to create a storage account. So let me go back to Microsoft Azure portal and show you here how this sheet would help you out to better understand. So as we said earlier, once you have created the storage account, you have an option for your kind of data you want to store within any of these formats. That's true. That's the option you have for almost with every possible storage account. But let's create a storage account. I know what kind of options it's going to ask you. So I'm just clicking on my all services here and going back to storage. In the storage, you have an option called storage account. So this is where all the storage specific information so far we learned it's gonna create and store. So here I'm gonna give my resource group as AZ900. Now I'm going to create a storage account here, AZ900. You see here, as I give here, it says that the red field is coming up, and it says that you can't give as a capital letters, and only lowercase letters and numbers are available or should be used. And this is also, you can't use a space, all those, because this is actually AZ900. I'm going to give here in a short. This is the unique things has to be there. So you see here somebody has already taken AZ900. Now I can go for AZ901. So let's see, the hyphen is not taken here, so I've just taken out that, and now it's taken. So this is accessible uniquely in the background with a fully qualified name in the background. So you need to give a unique name of your storage account. So I'm just giving here as AZ-900 demo. Okay, and this should be available. Oh, it's also taken by somebody, so I'm gonna give demo 1. So that should be available. Yes, it's available. So I'm gonna my storage should go for any of these regions. So I can choose here my data shouldn't go for from my Southeast Asia or maybe from US West to something like that. You can choose it based on your compliance policies and governance policies. You can choose it. So I'm gonna actually choose here as first US 2, and this is where I'm gonna talk actually about storage type. Is a standard or a premium? We talked about the standard and premium. Standard means it's a normal SATA. When you choose a premium, actually you're getting a higher chances of data read and write. That means IOPS, you're going to get it higher IOPS. So you see here, when I choose your premium, not all the options are available, or whatever the options which are coming in a standard, which are not available here with the premium. And same case when you choose even cool and hot also, like if I choose premium, I don't have an option to choose a cool or hot mechanism. So now here, I just wanted to show you here the replication. What we have talked about, all this LRS, ZRS, or whatever the zone replication, all that geo, all that has actually talked within this specific one. You see here with the premium you don't have all of that, so you have only LRS. So if you are maybe that's interesting to learn but all of these to implement, but you have an option only for LRS, not for the zone or geo redundant level. So when you choose a standard, you are actually getting almost everything, or every possible information, or every possible type of redundancy. But with the premium you have only LRS. So that's one other point you may have to take a note on that. Now this is what the account kind. So we talked about the storage types. If you can remember, disk, files, blobs, tables, and queues. So we talked all these things, but with this what happens is with the kind of account means, so what kind of account you're going to use. Are you going to use only for the blob purpose or file storage? And this is where the storage v2 is the latest one, version 2. So this is where it's gonna, so we use the storage v2 normally in general. So let's go ahead and create this. It's gonna create if you're looking for the replication for other things, so you might have to compromise on the standard one for the performance, and then you can choose whatever the mechanism you wanted here. So I'm going to actually choose the LRS because it's cheaper, and I'm okay to accept that 99 point whatever the nines we talked in the previous slides. So let's review and create. It's going to actually create for me an account. Once I have the account created, I should be able to go back and check for this specific storage account. So I can go back to all services again. To view it, my storage account, I can simply click on storage accounts. Those that would actually list me all my available storage accounts within my subscription. So if you see here, the filter is already applied here for my subscriptions. If you have more than one subscription, make sure that you are working in the right subscription, otherwise you are going to create that specific resources in other subscriptions. So in this case, I'm in the right subscription, and I can see here the new account type has been created, which is the storage account here, AZ-900 demo 1, and simply click on that. So you have all these information. So when you go to the containers, this is where you have the blob services. If you see here, this is where you can create a container is a level of the top level, like in a folder. So you can say VHDs. So this is for just the VHDs. So you need to again mention in the small letters only, and then click OK. That would actually creates here one of the VHD, and inside this you can move whatever the files you wanted to move. You can upload directly from here, but people will use anything to do with the storage account. They actually use something called a storage explorer. You see here, this is the one which is comes from the Microsoft. This is a tool actually. Storage explorer also comes as a tool for you, and this is where you can use use as a tool, but now they are actually integrating this tool to within your Azure portal also. But let's actually download the tool and have tested storage account specific one. Storage Explorer is a tool which should available from Microsoft site. You see here Storage Explorer, which is a cloud management tool, and you can download directly from Microsoft Docs. This is where it says that this is a tool. It looks like this, and once you have installed that, you can download directly from here by going this. That's Windows, not only just for the Windows, it's also available for Mac and Linux and different other operating systems, because we're talking about cloud, and it's most compatible with almost all possible operating systems. Now once it's done, I should be able to install this tool in a quickly without any issues. Since it's just installed, I'm just launching the tool, so that I can show how it actually looks like. So this is the tool. So you have this one, and this is where you can access with your storage icons, like you want Azure China government or used government, or a new environment which is a private isolated environment you can choose. So now it's just the public cloud, so I can choose an account. This is where I can add my account. So in my case, I can add here the account which I use. Once it is connected, it will actually pull all your storage accounts, and you can actually, I'm just applying my subscriptions. That's a filter and the layer of filter. So within this tool, you see here all your storage accounts has been listed here. So within this, my storage account is AZ-900 for this demo, and I can see here my containers. So within this, I just created as VHDs in Microsoft Azure, and from here I can actually straightforward upload the required files, or maybe a folder if I want I can upload, and I can play with my tables or queues. For example, I can create a new table and say demo example, and I can add here import the specific values, or you can add the information like primary key is this value, maybe a test, or this would be a demo, something like that, and you can insert this information, and within this, whatever the data is coming up, that can be added here. The values, add another property, and then insert that value. So this is if you're trying to work manually for the tables. And similarly the queues also, if put any of the queue inside this, and you can play with that queues and you can work. Similarly, file storage. So within this, you can actually create a different type of storage files, like you can share any of the files. And let me close these things. It comes as a option here. You see here there's nothing is there. You can create a shape folder, like folder. There's no restriction. It's like your own SMB server or file server. So a folder, this is one of the folder which has created. So it must be lowercase. So let me give you that format. Then later point, within this you pull any of the data, or you can upload. Like I want to upload one of the folder, maybe I just go to my upload my disable one of the registry key information. So I can simply now upload this entire folder of selected folder. So all the contents within that, for example, there's 2 files which is going to upload it in this. So you can check out it's just comes that. So this is the interface if you want to work for a larger files to be updated. Otherwise you can use the PowerShell, also you can use the browser based mechanism also, but most of the people, 90% of Azure admins, they use this method with the Storage Explorer. And also for the HDD VHD files, also the same case. You would be normally converting all that stuff, would be doing from here, and you can upload from here. When you start uploading from here, you can directly upload like the similar file method what we have tried, and also you can copy it as a direct file so that it can directly share that file, so that any of the admin directly can open, like I can open up in a browser that would redirect to my storage account. Such things can be done directly within the Storage Explorer. And also within the Storage Explorer you also have SAS, which I'm going to talk in a minute, directly from the Azure portal. That also can be done.
So all the things which are possible or not possible from the browser also is possible now with the Storage Explorer. That's the greatness of the tool. I hope this tool you will be definitely using it. Let's move and understand about the SAS. SAS is the shared access signature. It means, for example, you wanted to grant explicitly some kind of permission against to your blob, for example. So what you wanted to do is in the blob you wanted to allow for only read-only permission, for example. So what you can do is you can simply select on what date to what time you wanted that specific permissions to be granted for that specific user. Let's say from 11 p.m. to 11 a.m. That's wrong. Maybe you can give as the AM to PM. That might work. Yeah. So here you can give such kind of configuration, so that what would happen is actually this would actually sets the permission so that from this specific key only, like key 1 and key 2 in combination, so you can grant the permission. So in my services I wanted to access for the grant for the object level permission I wanted. So if I just click on that, it's going to generate this lengthy of the connection string. This can be used by the programmers or maybe even Storage Explorer for that matter, which we have tested. If you can remember, we try to upload here the content and all that has been done. So here also you can go ahead and connect from here. You can start connecting with the SAS based URI if you want, or storage account key and the key based. Like when I say key, actually it's gonna ask for a key also. So this is for the token. Let's continue with the connection string and the token, and for the single URL. So this is the direct URL kind of thing, and you can actually access the services, but when you try to access it, it says that hey, it's not going to work, and it's going to only work from that time to that time, specific time, not now. And also on top of it, XML format, so you can't do it from here. But at the end you can actually access it from Storage Explorer or from a connection. If you use this connection string, any of the developers, they know that how to connect this, and they can write the data into that blob by using the connection string. And if they want to just the explicitly access token, this is a token. Even in fact this token also will be part of here in the somewhere in the lengthy of this, and if you see here somewhere here it would be there. But you see here this is the value is which is coming up, and this can be used actually, but the problem is connection string will be easy for the sometimes for the programmers, sometimes only for the SAS is useful. So this is how you give the permissions explicitly on type of the storage that you wanted to grant the permission and type of the object you wanted to do it. And also there's something called the keys. There are two types of the keys, would be the primary key and the key 1 and key 2 we would call it actually. So whenever the key 1 is there, if it is compromised, for example, now I make it as available, you're able to see. So in case if I don't delete this account, you should be able to upload anything by using this key as much as data you wanted, and I would be paying for that. So in that situation it would be a costly cost effective. So these keys will not be shared with all the people. Instead what they do is we would actually change it. So if you just do it key 1, it's going to actually regenerating the key. So it's just regenerated. Once you regenerate it and replace the code, before you regenerate, actually you try to put this key, if you used somewhere as a key 1, replace that in your programs with the key 2, and once a regeneration is happened, you can replace with the new code within your programming or program, so that you are actually securing and you will not be seeing any loss of connectivity just because of the key has not working or something like that. So this is very important in terms of securing key. This is heart of your data locked with some kind of key. So if somebody, or if it is compromised, we're gonna pay a lot because of that. So we need to make sure that you regenerate. Before regenerate, either replace with the key 1 or key 2, vice versa, so that your applications will be in sync and it will be continue to serve for the business. And later point you can change with the new key. So in case if new admins comes up and old admin leaves the company, make sure that you replace or change these keys, so that
and also make sure that it's document wherever you use these keys. And that's how it's going to work on the storage access side. And the replication side, we talked about the geo-replicant in case if I want if because it's just the LRS, so I can view very clearly here it is just for this this is where my data located. But if I want if I have somewhere else also, I can actually configure to replicate to other regions, so that way data can be replicated and I can easily visualize where is my data. And these are the things which are important. And in case if I just go for GRS based replication and save it my account, so it's gonna actually updating my entire account to GRS specific, and I'm not changing anything else. But if I just go here, I can see here now it's a new secondary location has been added, which is in a West Central. So whatever the data I'm putting here, it's going to actually put it there also. So these are the values for storage account endpoints, which are configured with this name. So every time if the blob, it will represent as a blob, and then this name if it is a file.co.windows.net. So these name co.windows.net is remains same for everyone, including here if it represents as a blob, this is a blob, this is for file, this is for queue, and similarly table and DFS represent the ADL as a file systems, and static website would be this. So if you're trying to or remember, this is at least one of the question definitely in the AZ 900 series or the higher level series. At least one of the question would normally comes based on how do identify. So we can say that blob or file or queue, and it will end up with code.windows.net. That's it. That's the answer that they might be looking into it. So this is my secondary location. It has how automatically configured. So now you know how it's gonna happen. So if you're integrating your identity services with Azure AD, you can configure that, and this is going to be read-only access for geo-redundant. That makes more sense for me to configure if I just want it for a read-only access purpose. So this is where you are going to configure a hot, a cold, all that specific options which we talked again on top of your storage account. And also you have here, instead of paying to somebody to host, you can also host your storage based websites directly from here. That's a static website, and I'm not going to save that. So these are the again the direct URLs or the SaaS or whatever the URLs, so that you can directly connect. And I hope I made it easy. And this is where the lifecycle management, you can create a rule when your data will be moved to which location, when you want to delete that blob, and when you want to delete the snapshot. This is where you do the actions against to your first set and second set, and then you can review it based on your life cycle of your data management, so that you can save the cost. And on top of it, there's something called advisory. So this is advisory is a service which is almost freely you will be getting from the Microsoft. In case of any of the security issues, they would actually tell us there's some improvement areas, this is where you can do, or something like that. You would be always getting it. So in my case, there is recommendations are been added. It is inactive. The following recommendations will be available. If I just go to enter my subscription level, I should be able to get the improvement area. So these are the things I can do it. If not, what I can do is I can postpone these recommendations. If not, I can just go ahead and implement all these best recommendations which are useful as the entire Azure improvements and recommendations for the entire Azure specific. Now I think I should be able to conclude here by stopping on the storage specific, and I'll see you in the next lesson. Thank you for watching this.
Hello there, welcome back. In this lecture, we are going to learn about how to create storage account. In the previous lectures, we learned about the type of the storage account and data access types and the storage account concepts within that. So it's time for us to create how to create the storage account. So let's go to the storage account within this blade, most of the time it will be available within your Azure blade. If not, you can search here as storage account and you would be getting. So make sure that you are selecting the storage account, not the classic one. Classic one will be getting retired mostly in the upcoming years, but for now we always learn of the storage accounts because these are based on ARM templates altogether. So I can simply go here and create one of the storage account like here and select the right resource group. In my case, I have already created a resource group. If not, you can create here one resource group and give a storage account name. This must be in a low cases all the time, and it should be anywhere from 3 to 24 characters long, and it should not contain any spaces, any capital letters, and it must be unique. When I say must be unique, if I try to create with my name, might be available, might not be available because somebody else have already taken. So if I say like IBM example, this might be already taken by IBM or somebody else. So I should be give a unique name. In this case, I'm going to give as AZ Learning 001 example. If it is available, it will take. If not, it's not gonna work out. And you see here, if I give as soon as the capitals, it's not taking, so I'll just give as the small. And you see here I have an option as Learning 001, and I can create the location. So this is where within our Azure storage account gonna locate. That means all the information that we learned so far, like we talked about the containers, we talked about the files, we talked about the tables, queues, or whatever it is. It could be blobs or anything. That's gonna put it into this specific location called East US. So in our case, if you're okay, we can select that location. If not, we can choose other region altogether. So in our case, we can select East US. And again, performance tier, we have talked about the standard and the premium. So when we go for the premium, as we talked earlier, we don't get it everything like GRS, all that options. We are not going to get it because these are limited actually for the replication side. So if you choose as the standard, you get even the storage account version 2 also. At the same time, you can choose here zone redundant or geo redundant. You can go for these methods. So I'm going to choose here as the normal standard account, and I'm going to choose even my blob tier access also. So here kind of account would be the general purpose too, and along with that I'm going to dedicate it for LRS. I don't want to go for GRS, let's say, and then later point I can convert LRS to GRS or zone redundant. I can do all that conversion. And I should make sure that either the data is going to be saved as a hot or cold. So we talked about hot and cold, how frequently data is going to access, and that's what decides by hot or cold. And coming back to the networking, so this is very important that in the upcoming lectures also we're going to talk about it. So how this storage account is going to access. So if you choose as a public endpoint, it's gonna available for everybody. That means over all the network. It could be your Vnets or external public IPs also. It can be accessed. Of course, you will have some kind of storage account keys and SaaS access policies, or you would be allowing from Azure AD authenticated users only by creating some kind of Azure app registration. All that can be done, and we can talk on that accessing later point. But are you opening your storage account to the front end for the public? Yes, no, you can choose here. And if you don't want, what you can do is you can select the public endpoint as specific selected networks only, or you can choose here and create a private endpoint, which is nothing but creating your own Vnet, and you can associate within that Vnet. So Vnet is nothing but your IP subnets. You can take it as, and if you have not gone through the Vnet lectures, you can go and check out that lecture, but think that that's your subnets. So within that subnet only the storage account gonna work. So if you choose the private endpoints, and also you can go for the Microsoft routing or internet routing also you can choose. So in our case we are actually going to choose as a public, and I'm gonna choose the data protection. So why we want to secure our data within the storage account is really important for us. The reason being, let's say whatever the information you are putting, the company's critical data, you're going to store in your storage account. Storage account is a kind of bucket where you put all your things within that, like your files or your VHD files, or maybe your snapshots, or maybe your queues or your tables. All that information you're actually storing on your storage account. So this is a big bucket, and you have a separation within that bucket, like if a dedicated shades, like a file SMB shades, or maybe tables or queues. Such classified things are available. But how do you secure? So you can secure by turning these things. Let's say if you deleted a file, you want to recover that, so you can enable this soft delete. So after 7 days, till 7 days, you can actually recover that. And these options are you can actually enable under data protection. And turn on point in time restore for containers. So if you're using a containers, you can choose that point in time for the 6 days, and soft delete for the blobs. And also you can use the turn on the soft delete for file shades also, which is new here. Again, tracking for the versioning for your blobs, you can do that. You can enabling the blob change feeds, so that you can create, modify, delete, all that can be tracked when who was done and when it was done. All that changes also just for the tracking purpose. And coming back to the advanced, this is where you can say that, hey, do you want to enable only secure transfer? If so, it's going to use the HTTPS and over the HTTP also. And coming back to the blob public access, do you want to enable blob to be accessed over the internet, or you want to disable that? You can secure that. And the minimum TSL is 1.2, and that's the securing accessing method. And as your file share, you can enable disable for the large file shares. And the table queues, by default, these are things are disable for encryption, but you can do that later point when we go for encryption with our storage account with a combination of key vault services. Later point we're going to do that. And tags are very important in terms of to understand what applications are going to store this storage account. Let's say app colon here, I can say that app is maybe web app specific, I can say, or owner equivalent, so that I can easily find out the owner is maybe SQLDB. Okay, I can easily give these kind of tags to identify who's gonna use this, who's the owner, and when you want to take maybe a service to be done or something like that. Or even it's in fact it's very easy to understand in the billing point of view these tags when you filter. So let's go ahead and review that and create this account. So let's click on create. This will create the storage account in a minute or so. So now we have a big storage account. You can put all the data within that storage account. Now we have the storage account created. Let's go to the resource of that specific storage account, and you see here you can check out the location and the subscription, and whether it is a standard or hot or cold, and the type of the replication which we have defined as a LRS. Later point, if you want to change, you can do that. And to access the storage account, you have an option for access keys. These are the two keys which are available. So one would be, we call it as a key one, which is a primary, and the key 2. So by using these storage account keys, this is like a password, okay, for your storage account. You can access this along with this key, and you can create, if you have this key, anything, and you can do all the things that you can do it within this storage account limitation. When I say storage account limitation, like you can create your containers, you can add your blobs, you can go for your tables, queues, and files. All that can be done with the help of these storage accounts. So this is like your password for entering into your storage account. Of course, I did logged in with my account, so I no need to again use these keys. But if I wanted to do anything programmatically, or I wanted to access from a computer, with some kind of tools, then I might have to use any of these keys. Okay, so how do you access actually from your computer? So there is a tool called Storage Explorer. So this is a tool, currently it is also embedded within the Azure browser, so that you can actually browse like this and find out if anything is available within the storage account. Or you can go ahead and download the storage account specific Explorer. That's nothing but a Storage Explorer. You can download this tool and get it installed on your computer from here, and then connect to that storage account by using these keys. So these keys, we talked about the storage account keys. So with that keys, I can actually work and connect, and I can do anything with that storage account by using these keys, which we are going to talk in the upcoming lecture. And also, if you look at if you want to know what if you don't want to give these entire key, because as we talked earlier, this key 1 and key 2, the primary and the secondary keys are have the full control. I don't want to give the full control for my programmers. I just wanted to give a specific thing. Let's say I just wanted to grant permissions on maybe only files. So what I can do in that situation, I can simply take out and select only files from the allowed services directly from the shared access signature. Sometimes we also call it as SAS. Sometimes we refer as the SAS. So SAS is a URI that grants restriction access based on the access that you're gonna give. Let's say we talked earlier files. On top of files, you want to give the access here, file shares. But this file shares, you wanted to generate a specific token, a kind of a password for writing or reading or deleting or listing or creating. You can grant a different allowed permissions. So in my case, I just wanted for read example. I cannot even create, and from what time to what time, and what is the time zone you wanted to allow the end user. I can select even future date. Let's say from maybe this specific engineer, maybe which I'm going to create a generation key. Once I've done this, so I will have the key. So with that key, my engineer going to work maybe on upcoming Saturday. He's going to work till maybe Saturday from maybe 11 a.m. to, let's say, he's going to work up to maybe 1 p.m., something like that. So what would happen is within that time only this specific key will work. Even though you shade now, it's not going to work because the time is not yet active. So that's how it's going to work. So let's generate that specific key and how it looks like. So now once I've done this, I can even select here the allowed IPs only. If I know that my end user who's going to perform this change or who's going to access along with this SAS key, I can give here their public IP address also. So far we understood that we can use any of these keys, and we can rotate these keys in case of any admin changed, because he might know these keys, and this is a key of your entire storage. So you can perform any kind of changes with the help of these keys. So now what I'm going to do is I'm going to actually use a tool called Storage Explorer. This is actually also in a preview to view the same thing, which is also can be done from the web. So if you want to download and use as application, you can always go here and try to download or search for Azure Storage Explorer. You'll be getting that tool. Once you install it, the installation is straightforward, and once it is installed, you will be getting very similar to this. This is where the power button, there's a connect button, so you can choose any of these. So if at all you haven't yet signed in, you can choose here and try to sign up. So this will take you your account with the Azure, or you can actually choose another method, like if you see here Azure AD based, or you can use something like connection string. And you also have SAS, which we just now talked about, the SAS. So by using those keys, you can connect it and use the storage account name and key, and also local emulator, which is kind of a simulator for you. You can use that. So now I'm gonna use any of these method, right? So I'm gonna use the SAS method, or maybe storage account and key. Let's say if I want to connect to the storage account, so I'll simply click on next along with the key. The key is nothing but a primary key. The two keys what we have
told earlier, like access keys. So we can use that to connect. So I'll just say next, and I'll say display name and the account name, and this is the account name, and this is account key. So I'll just go here and look for my storage account name. So if you see here, you can actually find out your storage account name, which is available, which was we have given as the unique, if you remember, when we try to create the storage account. So that would be your actual account name. In this case, this is the storage account name. So I'll just copy this, I'll open up my storage explorer, and I'll say this is my account name, and I'm gonna say that this is my the same name I'm gonna give here, and here I'll simply go ahead and connect it by using any of these keys. So I'll simply copy this key and I'll simply paste this key and click on next. That's going to actually make a connection by using this key. So this key has a full permission. Let's say connect. So it's going to explore everything here. If you see here, that has everything, and this is where we have the storage account, and you can see here our storage account, which has all of the access. Now within the storage account, I can actually create here a file share if I want, or I can work with my queues and tables and my blob containers. Even I can create a blob container, and let's say VHDs. This is maybe so if I just give as this is for VHD, I can give as a VHD. So if the files are nothing, it doesn't show anything. So let me upload some of the files. Let's say folder itself I can upload if I really need it. So I'll simply browse and say that hey, you go ahead and open up some of the files to be uploaded. Let's say I want Windows PowerShell to be uploaded, so it's going to upload all the content within that folder. And this is the best tool. Why? The reason being, you can actually work very similar to a copy paste kind of thing. You can do it here with the upload. Otherwise, if you want to do anything, you have to depend on a PowerShell commands like AZ copy, all that command. So it would be difficult in case if you're not working with the PowerShell commands. So this tool makes easy for us to, in terms of any changes that we need to simply have to do. So if you see here, this got uploaded, but that actually does not have anything. So if you see here, this is a command, it was try to upload. So if I just go to notepad and type the command which was used, AZ command, so it actually running all this command, and then it is actually downloading. So there was no files. So let me upload some of the files simply within this VHD. So I'll just go ahead and choose some file. Let's say this is a file I wanted to upload. So now the file gets uploaded with a command. So in case if you want to change anything, you can always do some kind of a change. And now you can see here. So what happens is, if you are trying to upload any of the empty folders, remember, it doesn't show here in a visualize. So that empty folder should have some objects, some files should be there. Otherwise it doesn't show. That's again a tricky part if you're working with your storage account. Let's review what we have learned so far. So if you want to create a storage account, we know now how to create a storage account, and this is going to be your storage account name. And anything you want to grant an access, you need to have keys. So there are two different keys. One is a primary, other one is a secondary key. So these keys can be rotated like this. So if I just do this, so the key gets changed, and you see now this is a key got changed. Similarly, if you have another engineer who left, maybe who knows this key, we can actually simply rotate the key, but without disturbing the existing applications, you can give for some time the key to, and then rotate it and change the key. And coming back to the configuration of any of the storage account to be changed, you can go to the configuration and change it if there isn't a possibility to change, like cool to hot, or maybe from LRS, that's a locally redundant storage, to geo redundant, or read access geo redundant. And then these kind of basic configuration of your storage account can be done from here.
And if you're using identity based access, then you can enable this configuration so that it's going to use the Azure Active Directory Domain Services, that is the ADDS specific configuration. And also any of the containers. So if you want to create any kind of containers within the blobs, you can do that. It's nothing but a folder kind of thing within this. And for the encryption of the data, because this entire storage will have the data that will be managed by Microsoft, right? So you need to encrypt that. So by default it also does the encryption from the Microsoft managed keys by using, if at all you want to do it by customer managed, in fact we have a dedicated demo. So what we will be doing is we will be creating a key vault services. So if you have not gone through the key vault services, you can go and check out that lecture on Azure Key Vault Services. Key Vault Services is basically securing your all passwords, all your keys in one vault services, and you can recall from there. Instead of you remember or instead of you write it on your code, you go and your application go and communicate with Key Vault, and then it will be used. So similarly here the keys will be used for the BitLocker BDM managed keys will be generated, and that keys will store in this Key Vault services. So we have a dedicated demo on this. In fact, you may check out, there could be 2 demos also, one with the CLI based, other one would be the PowerShell with a combination of how to create from the Azure portal also. And coming back to the shared services, so we know that if you want to give explicitly permissions now on a specific storage services, either blob or file or queue or table, we can select it and we give the exclusive permissions. So either you want read, write or delete by the user. So it actually generates a key. So with that key we can actually give the permissions, and that permissions can be work based on the timing, also maybe a future date or current date, and we can set it the expiry also. And also to secure, we can also give the some allowed IP addresses also, we can do that. And coming back to the firewall, this is very important. Again, you wanted to manage your storage account with the firewall, because if you want to secure your storage account, definitely it would be either you want to expose to the entire networks, which includes even internet and intranet, or you want to include this storage account for a specific Vnet or virtual network. So you can define that here by selecting a selected network. If you choose all networks, it's going to be including internet. Everybody can access. Of course, they need to have the either access keys or SAS keys. That's nothing but a shared access signature. So one of them is needed to access your storage account. That's the access side. And also coming back to the private endpoint connections, you can also configure your endpoints so that you know that it's going to actually connect with your endpoints within the same region of your virtual network, or different private links can be configured. And we have a dedicated link on a private endpoints, so I'm not gonna talk on here and more on this. And if you want to do manually transfer data, yes, you do have to use the AZ copy command. You see here AZ copy command with the PowerShell, so you can use, or otherwise you can use the Storage Explorer. And for accessing, again, you can use the AM, which is Access Management Control, where you can go and do your role-based access management. You can do it here. And coming back to the custom domain, see, we have been talking about so much on the storage account, but we don't want our blob or our queues with the default Microsoft naming format. We wanted that should be actually routed with our own custom domain name. So in that situation, you can actually create a CNAME record and point that specific record to your website. So when users try to browse with your domain name, for example, contestro.com, it will be directly pointed, since we have a CNAME record which was created within the DNS provider. So if you are using maybe Namecheap or GoDaddy or Microsoft Azure DNS services, you may have to create all these CNAME records so that it would point it, and that's how the custom domain can be used. You can use the lifecycle management in terms of creating a different rules with the if condition. If let's say if this is a block and you want to delete it, so automatically with the lifecycle you can use the if condition, or then do you want to delete it or do you want to move it? All that can be configured in terms of the lifecycle management of your storage, because you don't want to keep everything stored forever, right? You wanted to maintain the objects lifecycle. In that case, you are going to use the lifecycle management within the Blob services. And we're going to actually use the CDN also if you are working with any kind of a content delivery and where you're storing your information, then you can actually use the content delivery options. And soft delete and the file share services, tables, queues, these are separate services which are coming from Microsoft storage account, Azure storage account. You can use it and you can configure the diagnostic settings in order to know what's happening. And if you want to using some kind of automation, you can go ahead and create your automation here. So this is all possible, and this is how storage account would be used. So I gave you a clear idea on a high level view. So in the upcoming lectures we are going to deep dive on few of the specific topics, and then we are going to learn more in depth of the storage account. But for this point of time, I hope this is useful for you. Thank you for watching this, and I'll catch you in the next lecture. Hello there, welcome back. In this lecture we are going to learn about storage account connectivity. When I say connectivity, I'm not talking about the access details. So I'm not really talking about the access, how you're going to apply the security permissions for your storage account files and folders, or maybe queues, tables, or blobs, all that. What I'm talking is how you can access the storage account containers or its files, or maybe queues, tables, and all other things. So definitely there are three possible ways you can connect. The first thing first, public endpoints. When I say public endpoints, when you create within the storage account any of the files, that can be publicly available if you want to configure in such a way. Let's say you configure public endpoints, that means you are making your entire storage account files, whatever the files, or maybe a VHT container, or maybe other container inside, whatever the files, all are publicly available so that anybody can access from anybody have internet. Let's say I can access, even you can access, or somebody else can access. So that's about the public endpoints. And when we talk about firewall, in between you are going to configure firewall. So behind the firewall you have a storage account. So first the connection goes and hits to the firewall, and if you allow, or if you have a firewall rule to allow, it's gonna go in contact with your storage account. So that's more secure way of configuring behind the firewall your storage account. And other one would be the network integration, where you can use the service endpoints or private links. So instead of your storage account traffic to route with different ISPs, you can use Microsoft backbone, so that you get a higher speed connectivity, and also the traffic is going actually in a secure way. All the traffic uses Microsoft internal backbone to connect to your storage account, so it's more secure. Now it's time for us to understand what are the storage account components that you have. So we talked about blobs, files, queues, and tables, but how that actually looks like. Let's say you have not registered your storage account with any of your custom domains. When I say custom domain, maybe you have a company called xyz.com, and your storage account was not registered with a CNAME to your xyz.com, then it would be a different name you would be getting. So by default you actually get all these names. Let's say if I'm talking with the blobs, so storage account name .blob.co.windows.net. Similarly, if I'm talking about the for the Azure files, it's going to be my storage account name .file.co.windows.net.
So similarly for queues and tables, it's going to be the queues and tables dot core.windows .NET. I'm sorry, there's a spell mistake, but windows.net. So similar to this. So you have these options. Why we are talking about all this is, let's say you created a container and you uploaded a file and you try to share. So how do you identify whether it's a blob or a file or a queue or table? So you can actually identify based on the name of the service that you are actually trying to browse. Let's say if it is coming as a blob in between, so you're talking about the blob, and if you are talking about queues, so in between you have the after the storage account name dot queues, so it's going to be a queue. So that's how you're gonna identify. So let's jump into the Azure portal to understand more about how to actually create or make our storage account for public, or how best we can secure with a firewall configuration and network integration. All that we can jump into the lecture and do the quick live demo. This is a storage account that we have created with one of our previous lecture. So let's jump into the same storage account, and you see here, as we talked earlier, we have 4 different services that are offered by Azure storage account. One would be the container and the files and tables and queues, and we talked about when to create all these different type of storages. So let's say I'm gonna actually do the first demo with the containers. Let's go to the containers, and you see here you don't have any container. So container means like you can create a folder. So let's create a folder. Let's say I can say this as my VHD example, and I'm gonna create. But before I create it, so I have actually a VHD container, so I'm gonna give here as the VHD hyphen, let's say demo, and you see here there is a public access level. So this is what we are talking, actually we are talking about the public. If you are talking about the public endpoints, do you want to allow the specific container anonymous access? That means anybody can access if they have just the internet connectivity. So if you want to stop it, you can make it as a private, or you can actually enable completely anonymous, but it's again a security point of view. So it's you are going to decide this whether you want your containers to be completely secure or not. So in my case, I'm just gonna demonstrate about the public endpoints, that is nothing but enabling the anonymous access for anybody. So it doesn't ask for any username and password. So I'm gonna choose here container as well as the container specific blob and all other files also inside. So I can simply click on create. So that's gonna create here. That would actually create a container, and it will be enabled for the anonymous access. So this is a container, it got created, and you see here the public access level. It's a container, complete container is publicly available for anybody. Let's say if I just go to under VHD hyphen demo container, and I can straightforward upload any of the files. So let's say I want to upload a text file called test file, and when I upload this file, by default this is available for anybody. Let's say if I go to the properties of this file, I'll just close this file and do a quick refresh, and I should be able to see here file. And if I just go to the properties of this file and copy this URL specific, and if I open a new tab here, completely cognitive mode, and then if I try to browse this file, I should be able to see the content of the file also. Say this is the test file, that's what it was mentioned within this file. So I logged as a guest, so there's nothing has been signed in, still I'm able to see. So if you wanna try, you can try, but I'm gonna delete this complete, so later on you will not be able to see it. And this is unsecure actually, right? So how do you secure it? So when you try to create a container, you should be able to say that, hey, I want this container, let's say this is a demo, I don't want to allow for anybody, let's say private, no anonymous access. So what would happen is if I just create this with a demo container, and since it is a private, if I go inside this and upload any of the file or the same file, let's see, and if I try to
browse the same file, it says that, hey, you don't have the access level was not granted because this file is, or this container itself, not enabled for anonymous access. So let's go to the same browser and try to again copy paste this, and you see here I'm getting actually error. It says that this XML does not appear to have any style information associated with it. So it says that this specific resource does not exist because we have not enabled, and we said that it's going to be private. So we talked about the public and also we talked about the private. Now let's talk about something called firewall specific, how best we can protect. So when you go to your storage account, and within this you have a firewall and virtual net. When you click on that, you will be actually getting the firewall configuration thing. So here two key things. The first one would be the all networks. What does it means is you are allowing your firewall to communicate. That means anybody can access from anywhere, like from any ISP, like from your home network or office network, anywhere. But when you choose as soon as the selected network, it means whatever the VNets, virtual networks that you create within your Azure network, that only will have the access. So that's how you can configure. So you can limit, you can minimize your storage account exposing to other networks. Instead of complete public network, you can choose to just communicate for your existing VNets, or you can create a one and add them. So what happens is within that VNet, whatever the web apps or maybe your virtual machines, all that can communicate with your storage account. So you have any program that is storing within your blobs, that is allowed, but not from outside. That's the difference. And second point is either you choose regardless of all networks. When you choose all networks, and you're actually allowing for everybody, right? But when you choose as the selected networks, if you have the VNet, that's fine. But what if you don't have any VNet but you wanted to restrict? So what you can do is you can actually go to the firewall. This is where you can specify the IP address or CID or ranges, so that it's going to only allow that specific IPs. Let's say if by default it's going to actually show my IP address, and I can simply take this checkbox here so that it's going to add my IP address for the firewall role. So I should be able to access it. If I don't have this and simply I try to save this, it's not going to work. Actually, it's not going to open my files that have actually earlier shared. Let's say earlier we try to open up the file shades from the container, right? So let's go to container and try to browse the same file. It might not work because we didn't enable the our firewall to be allowed. So if you remember, this is a container which is available for the public, right? So we'll just go inside and try to, you see here it says that it's unauthorized. So you don't have an access for this firewall, and you have to wait for some minute or so. That's what we are getting an error altogether, and should not be able to even access. The reason being we didn't actually allow. So let's go back to the configuration of this storage account and the firewall options. Within this firewall, what we're going to do is this time we are actually enabling this add my IP address as an exception. So what will happen is, now once this is saved, and let's give 30 seconds or so, because in the backend it has to be replicated, right? So now let's go to your container. In this case, this is the container. Yeah, we saved it, so we'll just go to the container, and this is a container. So I'll just click on this. Now I'm able to open up, right? So I can actually go to the properties and copy this URL and try to browse in another page. I should be able to see the content, but as soon as I take out my IP address, let me go back here, and in the firewall and networks, I'm going to actually take it out my IP address by deleting here, and once I delete it here, I'm going to save this. So what would happen? So once this is saved, I'm going to actually refresh the same thing by waiting another 5 or 10 seconds, so that
this should show as you don't have an access. So I'll just refresh this. Still I'm able to see because I didn't wait it. So now you see here, after waiting some time, it says that you're not authorized. So there is no authorization to access this. So that's how you can actually secure when it comes to the firewall. So let's also talk about other exceptions that can be applied when we configure this firewalls and VNets within this Azure storage. So for the connectivity side, when you're within your Microsoft Azure, you have different resources that needs to be communicated with your storage account in the backend. So by default, you can trust them so that you don't need to explicitly configure some configuration for that. So within the Microsoft Azure resources that are within your resources, you have an access that can trust and that can access your storage. That's what this first checkbox. And coming back to the logging for the read access, you can enable this checkbox so that anything happens for the reading of your access related can be actually logged in your storage. And coming back to the storage metrics, also you can allow them to read the access. And coming back to the network routing, this is again a key thing that we talked about earlier about the either service principal or anything like network integration part. Let's say you are trying to browse this file, right? You try to browse this file. So what happens from your office network, it goes to a different ISPs and finally it will reach the Microsoft cloud, and then from there it actually opens the storage account, right? So in between you are actually routing with unsecured ISPs also. If you want to force that should only route within Microsoft network, what you can do is you can take this checkbox, which is very much recommended, so that you get the most secure, and also there's no much latency for your applications. So you can configure that Microsoft network routing. So the routing would happen on a Microsoft backbone networks. So instead of on your ISPs, you can actually force to happen from Microsoft network routing. This way you have lesser latency and higher security also, because you're actually using Microsoft backbone. And coming back to the private endpoint connections, I did created two other lectures on specific to Azure Private Endpoint and Azure Private Link Services. One would be with the overview, other one would be the Azure Private Endpoint and Private Link complete demo. And also there is another just the documentation, which I have created another lecture for what's the major difference between Azure Service Endpoint versus Azure Endpoint. That also we really talked about it, so you can please check out that lecture. I hope this entire lecture is useful for you. Thank you for watching this. I'll catch you in the next lecture. Thanks for watching this lecture. Hello and welcome back. In this lecture, we're going to learn about storage account security with respect to the access controls. Yes, we are talking about how best we can secure our data layer and the management layer. So that's where we're going to talk about it. So when we talk about storage account, there are two major things. One would be the data layer. That's where your Azure files or maybe queues or whatever the Azure services that you are talking about, the entire data will be inside your data layer. So let's say a user is storing some files that's going to saved inside the data layer, and also your applications that are actually working with the backend by connecting to the data layer. And when it comes to the management layer, what exactly management layer is? Management layer means like you are trying to access, and that's where you're going to actually doing some kind of control for changing the account permissions in order to grant, let's say, for access, or maybe checking storage account properties, or changing the permissions to the storage account, or performing any kind of administration tasks on your storage account would come into the management layer. So there are two layers, as I said earlier: data layer, which can which we can consider as the user access to some of the files or folders, or maybe your web app may be trying to access some kind of images or objects which are inside your storage account, or your applications access. If you take it as the queues example, that application is sending some kind of messages by using some kind of queue services within your storage account, so that will be treated as a data layer. So now you know that data layer is what exactly, and also the management layer. Now let's talk about how best we can actually secure with a combination of data layer and the management layer. So the first thing first would be the access keys. In the previous lectures, in fact, we talked about the introduction lectures also about the access keys. So that's the access keys, like you have the full key, where are the two keys you have, one is a key 1 and the key 2, that will have full permissions. When I say the full permissions, with respect to the management layer as well as the data layer, so you have the full permission. So it's only recommended for admins who wanted to control the entire storage account, so because it's a key, primary key, right? And when it comes to the object level of permissions, let's say you have some kind of queues only to be granted, or maybe a file shares to be created, or with a specific file share folder to be granted read-only, write, or permission, such things would come into the access signature, or something called shared access signature. That's also in short we called SAS. So we call it as a SAS most of the time. So SAS is another type of access key. So if you are looking for a granular level of control, then we go for SAS. We never go for the access keys. And also it is a habit that if Azure admin has changed, we would always changes or rotate the keys that we have for key 1 and key 2, and wherever it was referred within your program, that all we would actually change it. And coming back to the RBAC, or role-based access control, we have a dedicated lecture on this specific topic. This is more about management layer, but it also a data layer also. So it's a combination, I would say. And this is where you can actually access, let's say there's a user who wants to have an access on a storage account, we can grant the permissions to manage that, or view only, and all that can be granted. So it's very similar for any other Azure services that you are working with. RBAC, similar thing, you can have the role-based access control. So it's like granting the permissions for specific users. And apart from this, you can also go for Azure managed identities can be configured, and Azure AD access can be configured for your storage accounts. So let's jump into a quick demo to understand about starting with the access keys, and then followed by shared access signature, or nothing but a SAS, and also a little bit of the role-based access control. So I'm back to my storage account that we have been working within this demo. So within the storage account, you have a keys here, access keys. So when we talk about the access keys within this lecture, this is the access keys. So this is represents here the access keys, and with this access keys you have two keys. Normally we won't show you here, because we try to hide it, because these keys are the complete control of your storage account. We can delete any files, we can create any files, we can upload, we can do anything with any of these keys. Let's say if I have this key, I can connect with the storage account by using a storage account explorer, which is the storage explorer tool, or different tools can be used with a combination of these keys, and we can connect it and we can do whatever we want to do it. So this is very high level of the key. But when I say high level, actually with this key you can actually work with the blob services, you can work with file services, you can work with table services and queues. So any service that can be accessed. But what if you want to change the keys? Let's say there was an admin 1 and he left the organization. When he left, he knows this is a key, and if he written somewhere or he saved the key, so you have an option to rotate the keys. But remember that this key, if it is referenced anywhere within your applications, you also have to change the key of this specific key. So without any downtime, what you can do is you can reference the key to as a first point, and then you can click on this simple rotate key. So this would actually regenerate the access keys, and if you see here, this is getting regenerated now, and the new key got there. So this key can be again referenced into your application later point. If you wanna, you can rotate this key too. So this way you will not have any problem in the applications downtime side. So with the access keys, yes, you have a full control on your file services, your blob services, queues and tables. But what if you want to grant a specific permissions? So that's where actually SaaS comes into the picture, and you can grant a specific permissions on a specific services. Let's say I want to grant access only for Blob, and let's take out all these other storage services like file and queues and tables. And I can say that in the Blob, I wanted to read and write, but I don't want to allow the users to be delete. And I'm okay with the list and add and create, let's see. And I can do this permissions, and I can say that in a future date, this permission should be allowed, or maybe a specific certain time, maybe within that change window time between this specific time, like 8 p.m. to maybe 4 p.m. between, or 4 a.m. between, only allowed this specific action, that is read, write and list and create on a specific date and time. And with the time zone also you can specify, let's see, this can be UTC time zone you can choose. And later point, you can also secure, very similar to the way we secure with a firewall, you can add that public IP address, so that only that specific IP address only will be allowed, not any other IP address can access this specific blob service. So you can do that where you can more secure it. And let's take this and try to generate this also. So what I'm going to do is I'm going to actually take as a blob and as a service and container and object. These are the resource types that I wanted to allow on a specific time window. Let's say from a 16th to 17th between so and so time zone. And I can give some IP address if I really wanted, and I can say by using a key one I can use and generate. So that's where actually you have the key one and key two. So it uses the key one, but you are actually limiting the permissions just to a specific allowed services and type of that specific resource with a granular level of permissions. But unfortunately, once you generate it, you cannot stop that actually, or you cannot delete that granted permissions, and if at all you have already shared. So let's review it, what best we can do. So I wanted for the blob and the service and container object, and also permissions, full permissions, except the delete. And I'm going to actually take it right away to till the 16th, that's till tomorrow. And then on the time zone I can choose, and as I said, we can go for the IP address based restrictions, which I have not done. I'm going to actually generate this key. So what would happen is in the back end, it actually generates this key, and I can copy this SaaS URL. Let's say copy it, and I can connect it by using Microsoft Azure Storage Explorer. So this is a tool which needs to be downloaded and installed on your machine in order to work with your storage account, or else you have to completely work with the PowerShell, but it's more difficult. If you think, then this is the best tool that we use it. In fact, this tool also hard-coded coming up into your browser. That's a Storage Explorer here, if you see. And if you want to download, just go to the overview and open in Explorer, and you can download here. This is if you click on it, you can download this tool. Later point, install, and this tool will be open. Later point, you can click on connect, and you have an option here as a SaaS URI connect. So click on that and simply paste the URL. Automatically it will detect that URL, and it will differentiate what to be done, all that. And you can simply choose. If you see here, this is a blob specific, that's a blob end based on the previous lecture. If you remember, it will be always storage account name.blob.co.windows.net, and this is the display name that's going to be hard coded here. So I'll just say connect and connect. So now this blob container is connected, and I'm able to pull up all the containers that are available. So as part of previous demos, we did create a demo, VHD and VHD demos, all that are available, and I can upload here any of the file. Let's say I want to upload here some files, so I can simply upload and choose here by 3 dots. You can upload this file, example upload. So this is gonna do the backend upload. So this is uploading, and in the backend it actually starts something called AZ copy command, which is available with the PowerShell. If you want to do any changes later point, you can do it with the PowerShell, or if you are trying to work with the PowerShell. So this is the commandlet that has automatically created for us, and the file has been uploaded. So if I just go back to my Storage Explorer within the browser, so I'll just go here and to the blob. So I'll just click on the blob and containers, and from there I can see under, if you see here, this is the VHD-demo. So I'll just go here, VHD-demos, and inside this now I'm able to see here .rdb file which was just uploaded. So that's how it's going to work, the SAS. So this is same thing that you can actually generate for your entire storage accounts based on any of the service that you wanted to grant the permissions. Let's say I wanted everything, then you can just create that, and you can set even for the future date. Let's say I wanted this from 16th to 17th. So what happens is after generating this, I can use this any of these keys that I need to send it to my engineer who's going to work on that, maybe on queues or tables or file services. He can use that key to connect it. So in my case, I'm going to actually use a SAS token, and I can use this. So this is the password kind of thing, which is used. And for connecting, you can use this connection string for your programs and other things. So any of them you can use and try to connect it, but you cannot actually post to the connection. You cannot do any changes also, because it's not going to work because the time was not yet started. So there's no point of you connect it. And coming back to the previous one, we haven't option got the action to delete. So let's try to delete. What happens actually, it says that I couldn't delete it because insufficient credentials. I don't have permissions for the previous one. So that's how you are actually going to create a SAS based access. Let's try with the full keys, that's the access keys. So what happens is, if I try to connect by using the connection string simply and go back to my SAS. So if I want to disconnect here, I can simply click on detach. So that would actually take out my connection. And if I want to connect, again click on this connect button and say I want to connect with the storage account and key. So here I'm going to actually paste the complete storage account name, and then the key I would be pasting here. So I'll just go back to the Azure portal, and simply I use the key as this. So I'll simply paste the key information, and the account name is this. So this is the storage account name. So I'll just copy the account name, and I'll paste it here. And I wanted to give this display name as the same thing. So I'll simply click on next. That would actually go ahead and connect with primary key or the first key to my storage account, and it pulls all the services that are associated with this storage account. Let's say Blob, I can actually pull up all the Blob containers and files, and I can in fact create a file share. Say that this is for my shade 1 for file server. I can give this, so that's going to create a shade, and I can upload the files, and that can be anybody can upload the files also. So I have a full control. So only the concern would be in case in future if this key got compromised, all you have to do is regenerate that key. So I would lose the connectivity if at all I try to use with this previous key connection. It's not going to work. So that's how you're actually using and rotating. This is very important in terms of the real time when you're working on Azure storage account. And also you can in fact actually create a SAS out of this
storage account explorer also. In this case, actually, I have already regenerated, so I couldn't get any other key, but I'm gonna detach and reconnect it quickly to this. I'm going to reconnect by using the another key because I just refreshed during this demo, right, the key, so it doesn't work. So I'll just choose this time as the storage account name, and I'll copy paste the key and the account name and display name and simply connect. So this time I got able to connect it. So now as a next step, within this I should be able to pull any of these containers, and even I can actually grant an access right from here, a shared access signature directly from your storage account explorer. So let's say I want from a local time or UTC, I can choose, and later point I can read, write whatever the permission I wanted. I can simply click on create based on the time zone, and it's gonna actually create the complete permissions, very similar to that. You see here it has created the key now container. So simply have to all I have to do is just copy, and then I should be able to reconnect, or just to connect with the SaaS. Let's see, I'm going to detach this now, and I'm going to connect with that shared access signature with the URI. So I'll simply click on next, and I'll give this URI. That would actually gives me only that specific container, which is VHD demo only will be available for me with that specific permission. So this is very important and very useful in terms of using the storage explorer tool, because you can do almost everything from here, right, directly. And that's why Microsoft is trying to integrate, and in fact it is in a public preview currently, directly to work from Storage Explorer as a tool. Let's try to understand about the SaaS signature by creating one of the SaaS policy. So before we create the SaaS policy, let's understand the SaaS signature. So I'm going to generate, this is where the actually policy comes. We would be looking in a minute or so about the SaaS policies, and for now we'll try to take some of the permissions and try to generate this a specific time to so and so time to like 15th to 16th, like a 1 day, and let's try to create that. So it's going to actually generated a SaaS key, and if I try to copy this to my notepad here, and if I just increase the font for you, try to separate the entire signature URL with and symbol. So if you see wherever the and, that's actually a separate. So I'm just gonna hit and button to the next lines so that it will be easy to understand for us. So source is that, and this is the time. Again, hit enter. So you see here, this is the URL which is talking about the blob, as we talked in the introduction lectures. If it is anything coming as the blob as a service, that means it's a blob service. And this is the signature, starts date would be here. And this is the end date, start end date. So the service start time and the service end time is this. With the source as C, and this is a kind of Microsoft internal information. And if you see here, this is a signature. So what if I try to alter whatever it was there? For example, this is started from 15th to 16th only. So let's say if I start as putting as a 17th, it's not going to work because all these values has a signature, that is this. So this is a signature. So this has been generated based on the above all of these information. So if anything is changed, again this becomes as invalid, so you cannot have the access. So that's how you need to understand about this SaaS URI. If you break out, this is how it looks like. So let's jump into access policies to understand more also. So for we learned about the shared access signature or SaaS specific creation. So it's easy to create, but what if, or how do you actually manage whatever it was generated? So by doing this demo, I might have already created 4 or 5 times, right? So how do I know that the first 1, 2, 3 keys are the SaaS based URLs which are created? How can I manage it? So definitely you cannot manage if you try to generate from the browser-based Azure portal. So the only better way of managing would be use Microsoft Azure Storage Explorer and create a SaaS policies. So what exactly the SaaS policy? It's a policy that you first create, and on top of it you are going to regenerate the SaaS. So it's like the top policy would be a parent policy, SaaS policy, and on top of it whatever the SaaS is you're trying to regenerate, it becomes as the child. So you have a control on a topper policy. If you delete that topper policy or you modified, the inherited automatically the below policies. So let me explain that what I'm trying to talk here. Let's say I wanted to generate now a SaaS policy for my VHD demo. What I'm gonna do is, you see here, I'm gonna actually have an option here. When I try to create here get shared access signature, I'm gonna actually create here a policy, but I don't have a here policy. So what I'm gonna do is I'm gonna actually right click here and click on manage access policies. So this is where I can actually create a policy. So I'm going to click on add, and I can give here a name to identify. Let's say this is for my VHD's SaaS, and I wanted this to be granted access from 16th to let's say on till my 22nd of this month. I'm gonna expire this policy for only read, or I wanted to allow, maybe add also. So I can choose here, and the time zone also I can choose. So this becomes as a one access policy. Let me save this policy. What happens is, post to this, when I try to create any SaaS policy, let's say if I just right click this time and use get shared access signature, now I have an option here to choose this policy. Let's say the policy is, this is the policy for my VHDs. By default, now you have the start time and end time, so it was already added, and I can simply generate out of this by clicking on creating. So the timestamp is already given and the access permissions is already given. All I can do is I can simply create now. So what happens is, let's say I wanted to copy this to my clipboard. Now if I want to connect, I can connect it, but let's say I want to modify the currently created policy. Instead of the 17th, I wanted to modify right away. I can do that directly by going to the manage access policies and simply do the change to 15th here, so that it gets automatically when you click on the save, it is actually affected. So you have an option to control your shared access signatures. Earlier, whatever we have done so far just before the access policies, all that we don't have option to roll back, we don't have an option to control it. But when you create signature, you have an option, you have a control mechanism, so you can use it. So this can be is the best way to manage at least the SaaS options. Let's jump into the other topic, which is the last, which is the role-based access control. In fact, we have a dedicated lecture, and you can check out that lecture, but just wanted to high-level touch on it. So any of the Azure resources that you want to go for a role-based access, it's almost the same thing, that either you can create your custom role or you can use existing roles. So to configure the role-based access control, you can go to AM, that is access control, and from here you have an option to choose, check if a person is saying that, hey, I don't have a permissions, then definitely you can go and check it whether that specific person has what kind of permissions he has. And for the role assignment, you can assign directly from here for the users, and you can check the built-in roles that are available. Let's say you want to grant a permission on a storage blob, all that you can simply have to check out what is
most useful for that user. Let's say I want a blob complete owner, I wanted to delegate complete blob service on a storage. I can simply grant the specific permissions so that users can delegate a key which can be used in a sign-in for SaaS tokens. So such kind of built-in rules were available already for the storage account. You can use them. Otherwise, you can create a custom role and you can assign that specific role for your users or user groups basically. So I hope this RBAC is that you would be dealing in another lecture, but it's quite same, and all you have to do is just to go through these one line description on the I button, which is information about what it talks about, and then use that specific role-based access groups, which is a built-in groups most of the time. Otherwise, you simply grant that access, and for the troubleshooting you can always go ahead and check or give the input for the access and try to find out. I hope this lecture is useful for you. Thank you for watching this. We'll catch you in the next lecture.